Are we live? मेरी आवाज आ रही है? हेलो. Good evening, good evening, good evening, good evening. Ayush Pratap Singh, good evening, good evening. Welcome all JEE warriors. My name is Gaurav Singh Arora, and today we are starting the final 200 question sets that we have selected specially for you people. And trust me, see, hello, yes, Ayush is here. Ayush, I was watching you yesterday. You did great in physics. So I hope you will be continuing with the same enthusiasm today also. AKY, good evening. Sridharshan, good evening. I'm sorry if I'm misreading few names. So, I mean, my comment screen is, I can see it properly, but okay. So, welcome and our task. So, first point. After seeing your enthusiasm yesterday, what I have done post yesterday night is that I have worked on some questions because all the questions I have taken, we'll be starting a flow from as per NCRT. So even if you are sitting as per a frame of mind that you want to revise complete chemistry, student one, or another category of student who must be feeling, sir, we are not very comfortable, we do not know that concept, this concept, do not worry, because the tradition which you have followed yesterday also during physics, just please do one thing: sit with a pen and copy. Try the moment I show you the question, try and give it a try, attempt the question at least once, because obviously we can't pause for much amount of time, because I guess in total I have around 207, 200. I exceeded 200, so it will be around 206 or 207 questions. So let's say if we take 2 minutes per question, still we'll exceed that 6 hours. So I want to save your time, because 21st, so you will be having, the time is actually money for us. So I want you to sit with pen and copy, attempt the question, and then I'll give you the answer. Those who your answer is correct, then good. But see to the discussion also, because physics and maths, what happens is, physics and maths, we do questions. I mean, what amount of practice you have put in during your preparation actually matters. But chemistry, many people do mistake because they are half sure about options. They are 50% sure, still they play. So point is, marking correct question is obviously important, that will fetch you marks, but actually more important is whether it is a tukka or whether you are righteous about the answer. So if you're righteous about the answer, then your probability of going wrong will be very limited. And trust me, if you're falling at a category of around 130, 140 marks, you're not attempting wrong question will make your JEE AIR, I mean, the college that you'll be getting, even the branch makes a sudden drastic transformation by not attempting those wrong questions with 50% surety. So do thorough focus when we are discussing each question. So moving ahead again, let me see. Sonia Pratap, good evening. Pratap is asking, sir, I know basics, so if I attend this session, can I get more than? Yes, Pratap. Matlab, what I'm telling you is, see, it's a Gita term. Fal, you, before putting in efforts, you start talking of the marks. Obviously, the questions that I'm going to discuss over here is from complete physical, organic, inorganic. I've specifically chosen those questions which are high probable also, because that is the logic that NT is going to ask. I mean, the concept is going to remain the same. Obviously, the numerical value will change. So if you stay put to the whole session till the end, then obviously you will be going through complete physics, organic, inorganic, and physical chemistry, and that is NCRT. So NT is going to ask paper from that set only. But obviously, a thorough revision is definitely required. So for that revision, I am scan this QR code, and you will be able to join our WhatsApp channel, PWJ English, where we will be sending you practice sheet also. So with that practice sheet also and these lecture notes also, you can actually practice things very well. So Moving forward to the next question, to the first question actually. Pen copy, start attempting, guys. I just see I'm audible. Rishi, hello. Ganesh, Vimla. Acha, okay, they are saying hello to each other. Okay. High weighted chapter in organic chemistry. Actually, organic is I mean, these days, IUPAC, isomerism, you keep aside, alkyl halides, alkane, as in hydrocarbons, alkane, alkene, alkyne, carbonyl compounds, alcohol, phenol, ether. NTA gives it a packet. I have selected those questions only. NTA generally asks you need to know at least something about mechanism. So we'll be discussing mechanisms also, and then we'll be proceeding in every question. So starting, we'll make a flow as per NCERT. So I guess everybody has joined. So let us start. I hope some of you have got the answer. I'm starting with the flow is through NCERT. So we'll be starting with obviously NCERT class 11. So mole concept. Post that atomic structure, periodic table. I'll be following NCERT flow because that is the flow one should follow for complete chemistry, be it physical, organic, inorganic. Okay. So Ayush is saying 6. Okay. So shall I guess those, we are already 6 minutes up. So let's start. Sir, when you will do one-shot classes for second year organic chemistry? Pranav, I read your comment in the afternoon also. Second year chemistry as in 12th chemistry. GOC, it will be starting. Bacha, 15 minutes frame we started because obviously the hydrocarbon, I remember, was the last one shot, and it took, I wanted to make it precise for 4 hours. But obviously chemistry, organic is quite interrelated. So I took 6 hours, and obviously you people can't devote that much amount of time. So it will be coming soon. Our team will be obviously pushing more one shots, but obviously after this first January attempt. So Ayush has got the answer. Okay, so let us read the first question. Let us read the first question. The first question says 1.84 milligram sample of polyhydric alcohol. Okay, so I have an alcoholic group, polyhydric, as in you can have more than one OH. The compound is X. It has a molecular formula of 92. It gave this much ml of hydrogen gas at STP. Now you have to tell the number of hydrogen, the number of OH groups attached. Now, sir, we very well know. First, you need to know the organic. Whenever alcohol reacts with sodium metal, it forms salt and hydrogen gas is released. Now, this is the organic basic that you should know. What else, sir? Now the stoichiometry, the mole concept thing. 1 mole of alcohol, if containing one OH group, will be creating salt, but my stoichiometry is related with hydrogen. So how much of hydrogen will be, sir? 1 mole of this guy will be producing half mole of hydrogen gas. Now, for calculation of number of moles, whenever we write a reaction, we first balance it. Whenever we balance it, we should always read a reaction how 1 molecule of this reacts with 1 molecule of this to produce 1 molecule of this and half molecule of this. You can obviously read the reaction as per number of molecules. You can also read the reaction as per number of moles. But you cannot read that. You can't say 1 gram of this react with 1 gram of this. You cannot say 1 liter of this reacts with 1 liter of this, because the box, you do not know its weight. You do not know its volume. So what we do, rather, we convert every of these given quantities in number of moles. So what are the basic formula of number of moles? First is given weight upon molar mass. Second one is given number upon Avogadro's number, Na, which is 6 into 10 raised to power 23. And third one is only used for gases. Given volume upon volume occupied by 1 mole of gas. But volume occupied by 1 mole of gas is not always known. So if gas is present at STP, what is STP? Standard temperature and pressure. Generally, advanced play with that also, because actually standard pressure is 1 bar. But for mains, they take it 1 atm and they approximate it as the molar volume, they approximate to be 22.4 liters. So whenever you have a gas, like over here I have hydrogen gas, so in order to calculate number of moles of hydrogen gas, what formula you should use? Volume of gas upon 22.4, but volume of gas you have to place in liter, but this formula you can only use for gases. Now let us check the answer. I guess yes, Ayush is right. Answer is 6. And how to do it? I've already told you, this is alcohol. Half mole of hydrogen gas should be released. Now this much amount of uh, polyhydroxy alcohol you have. So first let us calculate number of moles. So number of moles becomes equal to weight upon molar mass. Weight, it is given, it is 1.84, but this weight I have to put in gram. Why? Because molar mass is in gram. So weight in gram will be, it is milligram, therefore 10 is power minus 3 gram, and molar mass of the polyhydric alcohol is given to be 92. So you solve this number of moles. 1 mole will give half mole. So let's say I have n moles of this, so it will give us n by 2 moles of hydrogen. But considering if it has only one OH, sir, that is the question. If this compound is having number of OH group, then I have to multiply. Let's say if this compound has X number of OH polyhydroxy group, so this X will also be multiplied. So this N into X upon 2 will be equal to, now how to calculate moles for this guy? Sir, volume is given. So this is 1.344 because it is in ml. So you put volume is also in ml. And I guess volume in ml for the question, okay, it's not given. So it is 22400. Now, X you can put from here. I guess X will be, this is quite clear. This is 2 times. So this is 2 into 10 is power minus 5. Just do the calculation. You put N over here and X you get as 6. I hope this is clear. At least this is the first question. So I need some responses. Is it clear? Sir, can we get notes of this and yesterday class? Yes, you can. Sir, when you do one shot, acha, that I've read. Admit card has been released. Okay. Okay, we'll be seeing that later. Now, attempt the second question. I need answer. Attempt this second question. Thank you, students. The level with which you are responding is huge. Thank you very much. Answer. I'm reading the question for you. Obviously, you should also try. Carbon reacting with hydrogen forming CO2. Carbon reacting with oxygen, I'm sorry, not hydrogen, oxygen, forming CO. That means above one is complete combustion and below one is incomplete combustion. Now, it is saying coal of purity 60% is allowed to burn in presence of insufficient oxygen. If it is insufficient oxygen, then this means second reaction, because if it is insufficient, carbon monoxide will be formed. 60% of carbon is converted to CO. Okay, so this is happening to an extent of 60%. And the remaining, as in 40%, is happening as per equation 1. Right, sir? Now the heat generated. Now this is just a basic stoichiometry question. Give it a try. Take number of moles. This is the weight given of the coal. So number of moles will be equal to 0.6 into 10 raised power 3. Because weight has to be placed in gram upon what is mole atomic mass of carbon 12. So here you get number of moles, but whatever weight is given, it's not pure. How much it is? Sir, it is 60% pure. So 0.6 of this, because this is the total weight, but total weight has impurity also. So what is the pure carbon? Sir, 60% of this amount. So 0.6 of this. When we calculate this, I get number of moles. Now, this is the total number of moles, out of which 60% is reacting in this way. If 1 mole would have reacted, 100 kilojoule would have been released. So 60, let's say this thing is N. So here, how much is getting reacted? 0.6 times of N. So 1 mole would be giving us 100 kilojoule of energy. So 0.6 N will be giving us 0.6 N into 100 kilojoule of energy. So from this, reaction will be getting this much amount of heat. From the above one, 0.4 N into 400. Add these two values, you just have to find this N. I guess you will find your answer. Option 4, someone is saying. Bingo, 6600, option 4. Good. But for such questions, you have to be very precise with your calculations. So, Ayush, very good. This is the next question. Give it a try. If you find any problem with any question, I'm trying to cover every topic. So be relaxed. The momentum will be gained gradually. So relax, take out your pen and copy and read the questions. Okay. I'm reading it with you. 100 ml of sodium phosphate solution contains 3.4 gram of sodium. Okay. The molarity of the solution is, now what is concentration terms? It is solution also, it is obviously mole concept also. Now the first and foremost famous concentration term is molarity. How molarity is defined? Molarity is equal to number of moles of solute upon volume of solution in liters. If you are placing it in ml, you have to multiply 1000 in the numerator. Now this is the formula. Now I'm having sodium phosphate 100 ml. So volume of solution I know 100. This solution, okay, but it is giving weight of sodium, sir, but this is solute. So do the stoichiometry. So but just 1/10 of stoichiometry has to be applied initially. If I have 1 molecule of sodium phosphate, it will be giving us thrice of sodium ions. It will give us phosphate also, but that is indifferent because we are given detail of the sodium. So if I had 3 moles of sodium ion, I'll be having 1 mole of this guy, this molecule. If I'll be having 1 mole of this, that means I'll be having 1/3 moles of this. So how much moles of sodium is given? Sir, 3.45 upon 23, because atomic mass of sodium is, this is the value of N. So this into 1/3 will be the moles of this salt upon volume of solution is 100 into 1000. Do the into divide, you will get your answer. Answer. I'm moving forward. Answer is 50. You just have to do that into divide. I hope it is clear. Moving forward, attempt the next question. Attempt the next question. One shots 50. Ayush, perfect. Ayush, perfect. AKY, perfect. AKY, at least tell me your name, bhai. AKY draws. These one shots now we used to record. So what I used to do is 30-40 minutes and then I'd, so but I was in very much urge that interacting with, actually students make a teacher. So we need a teacher, obviously. So in one shots also, I used to see the camera as in a student is staring at me. So that used to give a lot of confidence to actually, one has to interact with students. So thank you, AKY. Okay, Akshay. So Akshay sir, perfect. And Ayush, good. So, okay, let me read the question for you. Protein A contains 0.3% of glycine biomolecules. The what is protein? Sir, polymer of alpha amino acid. What is alpha amino acid? Sir, you should have, you should definitely have one chiral carbon, because for amino acid, its configuration is L form. This L means the horizontal present functional group is on left hand side. It has nothing to do with the optical activity. So alpha amino acid present in protein generally has an L configuration. So this is H, this is COOH. So what's an alpha amino acid? Sir, functional group COOH. This is the alpha carbon having NH2 group is an alpha amino acids. I can have any alkyl group or any group in the bottom, but if this is hydrogen, sir, then this carbon is not chiral. This is the only alpha amino acid which is not having a chiral carbon, the famous glycine. A biomolecule knowledge, although not required for this question, but moving ahead. So a protein contains 30% of this guy whose molecular mass is given. The minimum molar mass of protein A is. Now, if you want the protein to have minimum molar mass, so it is having this guy. Molar mass of this guy is how much? 75. How to calculate minimum, sir? Minimum, this guy has to be, what is the minimum number of this guy which has to be present, sir? 1. So 75 into 1, this much weight has to be the minimum amount of weight present in that particular protein. Upon now whatever will be the molecular mass, that molecular mass will definitely be the minimum molecular mass. Now weight of my marks upon total marks into 100 is the percentage. And what is the percentage for this glycine, sir? It is given out to be 0.3. Now do the math, you'll get the minimum mass. Okay, you have to convert that into 10 raised to power 3 also. So into divide, please, you have to make sure that you practice hard. So Akshay, AKY, or anybody answer? This is 25. So into divide, I've given this also so that obviously with beautiful pictures you can't make notes properly. So join our WhatsApp channel and you will be getting these notes also. I've religiously done this thing that at least you should not be having the pain of writing notes, so you can revise from these notes also. So that's why I've done this for most of the questions I've done it, which involves some basics of other chapters also. Now moving forward, attempt this next question. Ayush, perfect bhai, you got 25 also. I need more participation. Students, if you invest yourself with a pen and copy over here now, you will be, let's say if you are extracting 10 rupees out of this lecture, then if you sit with a pen and copy, once you commit a mistake na, the point of time when you commit a mistake, it teaches you so much that mistake hits and become a frame inside your head. So the probability of forgetting that thing reduces drastically. So sometime one says, sir, I read but I forget things. You forget things because you do not try questions out of it. You try questions from it, you get stuck in those questions, get back to your notes. Once you see those notes again, then it becomes a photographic memory. If I keep on rubbing this wall once, second, twice, thrice, and if I keep doing it for days, the place will have a permanent scar. That scar is made in the memory. How? When we practice and commit mistake. So sit with a pen and copy. I hope many of you have attempted this also. Let's read the question. The question says, the strength of 5.6 volume hydrogen peroxide. Okay, volume. Now what is English it is referring as? Sir, it is referring as volume percent. Now what is volume percent? Let us revise that. What is volume percent? Let us first revise that. So H2O2 is a unstable, now it is an inorganic knowledge. The JEE and NTA does it. In order to disturb you, what they do is they first use some inorganic knowledge and then make a question out of mole concept. So what is inorganic knowledge? H2O2 is a disproportionating agent, unstable, stabilizes itself to form water and oxygen gas. Now what is volume strength? Volume strength is the volume of oxygen gas released at STP by 1 liter of this solution. Now if 1 liter of this solution is highly concentrated, it will be releasing more of oxygen gas. If it is less, then its volume strength will be less. So volume strength is volume of this oxygen gas release. Sir, so how can we formulate it? You do not have to learn the formula. Formulate it with common sense. What is definition of molarity? I told you in this class also. Molarity is number of moles of solute upon volume of solution. Take kill one variable, volume of solution. Volume, if I take a bucket of rasna, it'll taste the same. If I take out a glass, the glass will also taste the same. So point is, volume is independent of concentration. So let volume of solution is 1 liter. So sir, if volume is 1 liter and its molarity is capital M, then number of moles is also capital M. 1 mole of this will produce half mole of this. So capital M moles of this will produce this much moles of oxygen gas. Now moles of oxygen gas you know, and number of moles is calculated in terms of volume with what formula? It is equal to volume of oxygen gas released at STP. That is the definition of volume strength. So that volume of oxygen gas released will become volume strength upon 22.4. So this is how you have related. So molarity is nothing but volume strength upon 11.2. Bingo. Many time what student, they learn this formula, 11.2 sometime goes to the denominator and they say we made this much of mistake. Do basic, because obviously it is quite difficult to remember everything. Obviously in organic we have to remember few facts. So at least for physical, keep it simple. Okay. So this is the relationship between volume strength, and for the question is volume strength, it is given, that is 5.6. So molarity is given. So this becomes 5.6 upon 11.2. I guess this is quite easy. This is 1 by 2. Calculation is also easy. So we know molarity. Molarity is 1 by 2. Now density of solution is also given. And what are you asked in this question? You are asked, okay, molarity you are asked. So we have found molarity. So it is this, but we have to calculate, okay, mass percent also. Now what is mass percent? Sir, weight of solute upon weight of solution into 100. Now, what amount of solution you have considered initially? Sir, 1 liter. We are doing calculation. We have assumed this 1 liter of volume. So 1 liter, question is giving the density of solution. So 1 liter will weigh, because density of solution is 1 gram. So 1 liter will weigh 1000 gram. So what is weight of solution? 1000 gram. What is weight of solute? Some molarity we know this much. Volume is 1 liter. So moles will be equal to molarity. Moles will be equal to molarity into volume. Okay. I need to find weight. So it will be divided by molar mass. So what is molar mass of H2O2? 38. Okay. Sorry. 38 by 2. 38 by 2 is how much? Sir, 19. 19. So weight is 19. So what will be percentage? Sir, 19 weight of solute, 1000 weight of solution into 100. So this is 1.9. 1.9. It is 1.1 point, answer is 1.7. 1.9 I do not have any option. Okay, 38 I guess H2O2 is okay. H2O2, I'm sorry. It is 16 to 34. So this is 34. That means this is 17. So this is also 17. Okay. Then this is 1.7. Okay. I hope you got the answer. Chalo. Into divide is a thing you should keep very focus and attention. Whenever you land up with the result, do into divide very religiously. Obviously I'm explaining also and doing also, so you guys should practice, and obviously we are there to help you. Now next question, make a try, make an attempt. Sir, I have a fair copy. Perfect. Do not write, Ayush. Actually write, keep it in your head. Make short notes. Writing will also take time, no? So, but if you are writing and keeping a note of it, it's huge. It's great. Sumit sir, thank you. Thank you, sir. It is all teamwork, sir. Yesterday physics session I was watching till night. I got scared. Reason? I told you, na. See, the more cushion you gain, the more alsi you become. So that is what has happened. Uh, a a class full of student gives so much of energy that it becomes very easy to continue for n number of hours. But yes, if you are working as if you are working right now, Ayush has got the answer again. Mass is 34. Perfect, Ayush. Let's check. Let us check the answer. 34. No, it is 5, bhai. Okay, you were correcting me for that H2O2. हाँ यार, H2O2 I wrote 38. But that mistake, even sometimes the examiner also religiously checks that हाँ ठीक है, if that this guy is doing small mistakes, so they would have given 1.9. And few of fast and rigorous working attempting warriors may have attempted wrong question also, but care. Moving ahead. Now, next question. The ratio of mass percent of carbon, hydrogen and carbon oxygen for a saturated acyclic organic compound are 4:1 and 3:4. Okay, so this is weight ratio. Then moles of oxygen gas required for complete combustion of 2 moles of organic compound. Don't miss this 2 moles. You have to combustion, you have to oxidize. Combustion is complete oxidation. 2 moles of that organic compound. Sir, but weight is given, molecular formula we do not know. So I've intentionally used this question. This is also a type of question of determination of empirical and molecular formula. How we calculate empirical and molecular formula? With a table. What is that table? Boards will ask that. What is that table? Sir, table. Fast come. What is that table? Write whatever elements you have, write in the first column. In the second column, write their mass. Sir, but mass, it is not given. They have given ratio. So use ratio. Weight of carbon. Ratio, they have, take any species as reference. So let us take weight of oxygen is, let's say, 4a. So weight of carbon will be 3a. So these two are fixed. So let's say if weight of carbon is 3a, then what is weight of hydrogen? Weight of hydrogen will be 3a by 4. So weight of hydrogen will be 3a by 4. Weight of carbon is 3a. Weight of oxygen is 4a. So what you write in the first column? Weight. Then calculate moles. Sir, how to calculate mole? Divide by the atomic mass. So sir, 3a upon 12, 3a by 4 upon 1, hydrogen is 1, and 4a upon 16. Now, once you find it, find the simplest ratio. Sir, what is empirical formula? It is the simplest formula. So if you need to find the simplest formula, calculate the smallest species, as in the smallest number out of these three. Which is the smallest? Let us find it. Sir, this is 1 by 4. Sir, this is 3 by 4. Sir, this is 1 by 4. Sir, why we have not written a? Because anyway we have to divide with the smallest quantity to all. So because 1 by 4 is smallest, so 1 by 4 upon 1 by 4 will become 1. This will also become 1, and 3 by 4 upon 1 by 4 will become 3. So this becomes your simple ratio, and simple ratio is empirical formula. So that means you know your empirical formula. What is our empirical formula? C1 H3O1. Now question is saying 1 mole of this guy will be using oxygen to do what? To undergo combustion. Combustion of hydrocarbon produces what? Sir, CO2 and H2O. So it will produce CO2 and H2O. Sir, carbon stoichiometry is 1. Here also it is 1. So carbon, you do not have to worry. Hydrogen, it is 3. So in order to make 3, I have to add 3 by 2 over here. Now let us calculate oxygen. 1 oxygen is there in organic compound only. So RHS, I have how much oxygen? 2 plus 3 by 2, as in 2 plus 3 by 2, as in 3.5. 1 is here, so I need 2.5. So 2.5 as in 5 by 2. So 1 mole of this guy will be reusing 5 by 2 moles of oxygen. So 2 moles of this guy will be using 5 moles of oxygen. Perfect, Ayush. Perfect, AKY. Next question. Perfect, guys. Perfect. These are all type of questions, friends. So make sure you practice them, and then JEE is yours. I'm audible, na? I should speak with less magnitude because we have to last long. Chalo. I hope you got your answer. No. Okay, we are trying. Okay, let me read this question for you. 10 milligram of effervescent. What is an effervescent tablet? A tablet which releases CO2 is an effervescent tablet. So 10 milligram of tablet containing sodium bicarbonate. What is sodium bicarbonate? Sir, NaHCO3. And oxalic acid. What is oxalic acid? H2C2O4. Releases 0.25 ml of CO2 at this much of temperature and this much of pressure. If molar volume of CO2, okay, now remember I've deliberately told you that volume occupied by 1 mole of gas at STP is 22.4, but at STP, question is changing temperature and pressure. So PV equal to nRT, you can calculate also. But why to calculate, invest time? Question is giving you that for this particular temperature and pressure, molar volume is 25. So what is the number of moles of CO2 question is supplying you? 0.25 ml upon this much in ml. So this is into 1000 because this is ml. So this also has to be in ml. So this is easy. It is 1 upon 10 raised to the power 5. This is a moles of CO2 that it is releasing. Who is releasing? 10 milligram of tablet containing these two. Now, after this, it is saying what is the percentage of sodium carbonate. Now, you have to calculate percentage of this guy. Sir, out of that 10 milligram, let's say this is X milligram. So this will be 10 minus X milligram. Now, sir, they must be reacting with each other and forming CO2. You put tablet in your stomach, it gives some reactions. So with that effervescence, you must be giving a Dakar. So what is the reaction? So these two guys must be reacting. So this is an inorganic knowledge, a very basic knowledge, because this is 10th class double displacement reaction. Sodium will be going with this ion, which is oxalate ion, forming sodium oxalate, and bicarbonate will be going with H plus, so it will be creating H2CO3. But carbonic acid is a weak acid. As in weak acid, it dissociates also partially and it is unstable also. Carbonic acid decomposes also to form CO2 and H2O. This is the inorganic knowledge you should know, and once you know, you write the reaction. Once you write the reaction, you balance the reaction. Sir, balancing is class 10th job, so which I have done that job for you. Now, sir, we know 10 milligram is given. So let's say it is X milligram. So X upon molar mass of sodium bicarbonate is 84. Because it is milligram, so I have to multiply 10 raised to the power minus 3 also, because I have taken X in milligram. Now, this is the moles of sodium bicarbonate. So if 2 moles of sodium bicarbonate would have been reacted, 2 moles of CO2 would have been produced. So 1 will be producing 1. So this much will be producing this much moles of CO2. So moles of CO2 produced will be equal to this much, which is given out to be 1 upon 10 is power 5. We calculated it in the previous slide. We can find value of X. Now what else we have to find? Percentage. What is its percentage? What is its weight? Sir, X milligram. What is total weight? 10 milligram. Milli will get cancelled into 100. So actually 10x will be your answer. So calculate X from here, multiply it by 10, you will get your answer, and it will be option D, which is, I guess, 8.4. So I hope this is clear. Attempt the next question. I think you have. Acha, all time hardest. Ayush, I have not intentionally taken those hardest question. Actually, the more you see number of questions now, the more inorganic and organic knowledge also I can share. And maybe NTA has to repeat concept. Maybe they'll repeat the same one, because in sessions they repeat questions like anything. So that's why deliberately I have taken those questions which can give you some inorganic, organic knowledge also, and stoichiometry knowledge also. So that's why. Chalo. This question, we can take time. because point is you should get benefit out of it. We'll make it till 12 1 whatever, but after seeing yesterday's physics, I was very much actually I was very much encouraged by seeing the confidence. Even if this amount of hard work is helping one student, it is more than sufficient for me. So no worry, Ayush. Add, acha, remove ads. Okay, I'll just tell the team. I'm sorry, I'm sorry. I'll just message him na. I in the break I'll message him, bhai, hai na. Chalo, I hope we got the answer. You try options now. Okay, balle balle, we reached atomic structure. So okay, first question, AKY, option D, only according to you most appropriate. Okay, according to you only this is correct. No, I guess you're wrong. I mean, try. Acha, Ayush also. Let's check. I guess you're right. Nah, I told you this is B. Okay, let's check. Let's check. I've written few basics for you because this I'm starting new chapter. Board theory, you get question from this. That's why learn this formula. No derivation. Learn it. Energy of nth orbit is equal to minus E naught into Z square upon N square. E naught is equal to 13.6 electron volt or 2.18 into 10 to the power minus 18 joule. Learn it. Total energy is equal to kinetic energy plus potential energy, and for earth also, for atomic structure also. What is valid? Total energy is equal to minus of potential energy, and total energy is also equal to half of potential energy. Learn it. What is velocity of electron in nth orbit? V naught into multiplier Z upon N. What is V naught? A constant value is 2.18 into 10 to the power 6. That is minus 18. This is 6. So learn 2.18. Unit meter per second. Radius of electron in nth orbit, sir, Rn is equal to R naught into N square upon Z. What is R naught? 0.529 angstrom. So very important formulas. Now, sir, what to do with these formulas? Apply these logics. Kinetic energy, sir, you already told us kinetic energy is equal to, here it is energy, so it is proportional to Z square upon N square. So this one you have obviously, so this is definitely correct. Okay, what else? Product of velocity and principal quantum number. Now, velocity formula we know, Vn proportional to V naught. So we need the proportionality. Why invest time in V naught? So V naught into Z upon N. But it is saying if this velocity is multiplying with principal quantum orbit number N, sir, so Vn into N is proportional to Z only, no? It is proportional. Okay, it is proportional to Z square. Then option B is incorrect. It is proportional to Z, but it is given as Z square. So this is wrong. Now, frequency. Sir, what is frequency? Reciprocal of time period. What is frequency? Frequency is reciprocal of time period. Sir, what is time? Time is distance upon speed. Sir, what is proportionality? We should use distance. When you move in a circle, what distance you cover? Sir, circumference, that is 2 pi r. So what is proportionality? Proportionality of r, that is r naught into n square upon z. What is speed? Sir, velocity. So proportionality v naught into z upon n. Kill these constants. So what variables we are left with? So proportionality is z upon n into, this thing goes to the numerator, this comes to the denominator. So this is z square upon n cube. This is z square upon n cube. This is z square upon n cube. Okay, it is giving z cube. So the option is playing with us. It is not z cube, it is z square. Hence, this is also incorrect. Now, Coulombic force of attraction on electron is z cube. Now, sir, how to, now, a basic derivation of gravitation. What is Coulombic force of attraction? Sir, the nucleus is attracting electron. So what is why the orbit is fixed as per Bohr? Because force acting inside will be equal to force acting outside, that is centripetal is equal to centrifugal force. What is the mathematical relation that we know? Sir, mv square by r, which is the centrifugal force. What is the centripetal force? A Coulombic attraction, as in k q1 q2 by r square. So this is the Coulombic force, and you have to say about this Coulombic force in terms of the proportionality. Mass is constant, so proportionality will be velocity squared upon radius. So this force will be velocity squared, as in n square upon z square, because velocity is z upon n. Okay, I'm sorry, velocity is z upon m. Velocity is z upon n. So velocity square is z square upon n square. And what is radius? It is n square upon z. So z will be coming in the numerator. So this is z cube upon n raised to the power 4. Very beautiful thing. Z cube upon n raised to the power 4. This is correct. So actually D is also correct. So our answer will be okay. That's why you guys were saying A. You have missed this D. A very beautiful D option. Make note of it. So this is Z cube upon n raised to the power 4. Moving to this question. I guess this is quite clear. It is basic. What is wavelength? If I'm moving from here, when my motion will become periodic? Once I reach here. So this length traveled will be called the wavelength. Wavelength is lambda. Lambda by 4 value is given. So lambda by 4 is given out to be 3 by 2 picometer, as in 1.5 picometer. Now what are we asked? Frequency of the wave. So how frequency of electromagnetic radiation is related with wavelength? A very basic formula. Nu, which is frequency, is equal to velocity upon wavelength. Why I have written C for velocity? Because electromagnetic radiation always travel with a constant speed of light, which is C. Its value is 3 into 10 raised to the power 8 meter per second. Lambda we know. We have to calculate this nu, convert it into 10 raised power 19 format. In hertz, obviously we are putting everything in SI unit. Okay, this is picometer. So 1 picometer is equal to 10 raised power minus 12 meter. I'm giving you a trick also, because many students miss it. Keep it with a rhyme. Deci with first finger. Deci, centi, milli, micro, nano, pico, femto, etto. So how many fingers you are putting out? 8. Again the rhyme. Deci, centi, milli, micro, nano, pico, femto, etto. 8 fingers. Then the multiplier. -1, -2, -3. Then 3 stable. -6, -9, -12, -15, -18. Perfect. So my pico is 10 to the power -12. Do the calculation and I guess you will find your answer to be 520. 5, Ayush. 5. No worries. Beta, I'll be taking a break and then I'll be informing the team to remove that. It will be coming because it's a team thing, but it will be coming, but you can see options. Attempt this next question. We'll finish atomic structure, then we'll take break for 5 minutes. Hai na? हाँ 5. Okay, 5 you are saying for the previous question. This one. Whatever questions I'm taking, they are all meant for theory revision. Although they are PYQs only, but I've picked those PYQs which will help you to revise whole of the theory, the relevant theory which is probable. Option 1. Okay, Ayush. Statement 1 is true, 2 is false. Let's check. Perfect, right? Perfect. Now, this is a very conceptual and beautiful concept which says orbital having same energy are called degenerate. Yes, it's a theory. Orbitals having same energy are called degenerate. In hydrogen atom, 3p 3d are not degenerate. Now, quantum theory tells us that energy of orbital depends on the value of n plus L, the Aufbau rule. So Aufbau says energy of any orbit depends on the value of n plus L. But for hydrogen, why we read those derivation of Bohr theory? Because still, as per quantum theory also, quantum theory also suggests that whatever Bohr calculation he has done is approximately right. That's why we still now we do those derivations, because Bohr theory is approximately correct, but for single electron species. Because for hydrogen, even quantum theory says energy only depend upon principal quantum number n, only n. So if this is 3s, 3p, 3d, I'm not depending upon L, so value of principal quantum number is 3. So these all are degenerate orbital. A very famous advanced question. If someone is asking you, I'm giving him another question. What is the degeneracy of hydrogen in the second excited state? So this is ground state, this is first excited state, this is second excited state. So what is degeneracy? As a number of orbitals having same energy. So this is 5 plus 3 plus 1. So answer will be 9. A very famous advanced questions. That's why I've used this one. Next question. Again, a question on quantum numbers. Very, very, very loved by JEE. Easy questions, but beautiful questions. Now, you are having atomic number 37. 37 as in, okay, I want you to revise this periodic table also. Now, how periodic table helps us? So, first period is 1s2. Second period is 2s2. As per above also, as per periodic table also, this is the level of electronic configuration that we use. Although this is not required for this question, I'm building it a frame for the later questions also. Now, third period is 3s2, 3p6, because here from fourth period D starts. So from fourth period, this is 4s2, lessen by 1, so 3d10 and 4p6. So what is the final outcome? For S and P, what is the period number becomes the principal quantum number. For D, it is 1 lesser than the period number. Then fifth period, 5s2, 4d10, 5p6. Sixth period, F will start, so 6s2, but fill first lanthanum, so 5d1. After 5d1, go to 4f14. After 4f14, again come back to 5d2 to 5d10. Post that 6p6. Repeat the process. 7s2, 6d1, only the first one, actinum. Then 5f14. Then for the later ones, as in 6d2 to 10. And last becomes 7p6. Now, because these are the electrons, so atomic number of last electron of fourth period will be 36. So I am talking of 37, which is nothing but an alkali metal. Alkali metal in this fifth period. So this is 5s1. So value of N will be 5. M and L will be 0, because S has L equal to 0, because it is one orbital. So M is 0, and because it is first electron, so its spin will be plus half. Moving forward. Next question. Now you again have to do that electronic configuration, but now do one more thing. Calculate magnetic moment. I'm audible, right? हाँ, Ayush, option 1, perfect. AKY, you told me your name, yaar. I forgot, bhai. Sorry. Chalo. So, what are we doing over here? These are the electronic configuration that is given to us, and we are asked the highest magnetic moment. Now, what is magnetic moment? Sir, when I have unpaired electrons, I will be attracted by external magnetic field. Why? Because I will try to cancel that magnetic moment from the external magnetic field. And if I have all the paired electron, I will not be interested in external magnetic field, and in fact I'll be getting repelled out of it. So then I'll be called a diamagnetic substance. So diamagnetic substance have all paired electrons, and paramagnetic substance have unpaired electrons. Those who have more number of unpaired electrons will be more paramagnetic, and the level of paramagnetism is calculated by their magnetic moment by the formula under root of n into n plus 2 Bohr magneton, where n is number of unpaired electrons. So for these configurations, we know D is a degenerate orbital. So let us fill those electrons. 7 as in 1, 2, 3, 4, 5, because Hund says pairing you do after singly filling them. So number of unpaired electrons are 3. Over here, it will be 1, 2, 3, 4, 5, 6, 7, 8. So number of unpaired electrons will be 2. Over here, again it will be 3, and over here it will be 4 because 6 are getting filled. So obviously 4 is your answer. Perfect, Akshay. Moving forward, let us try this next question. Orbital angular momentum of an electron in 3s orbital is given. You have to calculate value of x. Do it. Now, I'm iterating also. Orbital angular momentum. Mind you, Bohr theory says orbit angular momentum, which is MVR. It is not speaking of Bohr theory. Initially, it is speaking of orbital angular momentum. So, formula of orbital angular momentum is under root L into L plus 1. Multiplier is same, h upon 2 pi. So, I hope you have attempted. I've given you that formula under root L into L plus 1 whole into h upon 2 pi. It is the orbital angular momentum. As per Bohr theory, it is the normal orbit angular momentum. So, this is equal to MVR. Although it is not asked, because for question this is asked, and for 3s, sir, I know L equal to 0 for S subshell. So this becomes 0. So orbital angular momentums becomes 0. So 0 will be your answer. Moving to the next question. Perfect. Perfect, Ayush. Good, yaar. Okay, Akshay. Sorry, bhai. Sorry. Hey, you should write Akshay. What a beautiful name you have. Handsome name, as in. So write Akshay. हाँ, but हाँ, swag. Akshay draws. Perfect. Chalo. This is a question from photoelectric effect. I'll be giving theory also. Do not worry. Now, work function of these metals are given. Okay, sir. Number of metals which can show photoelectric effect. Sir, what is photoelectric effect? Incident radiation falls. Metal present in the bulk will gain that electromagnetic radiation. Will snatch. Will remove all the attraction force it is gaining from ions, but that will require some energy. So that energy which is taken by the electron to come to the metal surface is called work function energy. And once it reaches to the metal, it ejects out. Puck. That ejects out will give it a kinetic energy. So what is the mathematical relation? So incident energy is equal to work function energy plus kinetic energy. Now, why trick written? Into divide. Into divide is the thing which actually disturbs students. So what is a basic trick of formula which will help you to do questions in a faster manner? Whenever you have to calculate energy in electron volt, use the multiplier HC. H is 6.626 into 10 to the power minus 34 joule into second. C is 3 into 10 to the power 8 meter per second. But you have to convert, because 1 joule, 1 electron volt is equal to 1.6 into 10 to the power minus 19 joule. So do not do, obviously you can, but in order to save time, learn this. Use multiplier HCS 12,400. But you have to put wavelength in angstrom. So if you use this formula, 1 angstrom is nothing but 10 to the power minus 10 meters. 1 nanometer is equal to 10 to the power minus 9 meters. With these multipliers, you can quickly do the calculation, because here wavelength is given in nanometers. So this will become 1240. So 1240 upon 400. So this will be 12.4 divided by 4, as in 3.1. So your R work function is 3.1. So which all metals can create photoelectric effect having incident energy? This is the okay. Sorry, this is the wavelength coming. So this is the incident energy, and work function is given. So how many of these can show photoelectric effect, which can have for whom 3.1 is greater than their work function? Let us see their work functions. So this is, yes, it can eject. This can, okay, this is the orientation is wrong. So this can also do photoelectric effect. This will also do. This can't do. This can't do. This can't do, because they are more than 3.1. So answer will be 3. Beautiful 3. A beautiful question requiring practice. Okay, okay, Vikram. Okay, let me see, bhai. Sir, attempt these question, guys. Sir, I have first year inorganic and second year physical revision. I have. Okay, you done that. Inorganic. Except coordination pending. I'll be discussing coordination, bhai. NCRT flow. So it will be coming after 9:30, 10ish types. After around 10ish PMs, you can see. Okay, Akshay got C. 6 pi A naught. Let's check. Perfect, bhai. Perfect. Huh. I've given you the basic also. Let us do it a bit quickly. Let us gain some momentum now. Radius formula, sir, again, we know revising. Now, as per how we have reached quantum theory from Bohr, Bohr said it is all mass. De Broglie said if for every particle, mass and wave nature are inversely proportional. So if my wave nature is high, my particle nature will be very less. Mathematically, de Broglie formulated as de Broglie wavelength is equal to h upon mv, where mv is the particle nature. So if we know this, that de Broglie wavelength is equal to h upon mv, and question is asking us de Broglie wavelength of third orbit. Sir, third orbit, then we have to go to Bohr model, because what Bohr said, what distance from nucleus is can be regarded as orbit, where if there is no Damar road around nucleus. So why we'll say it is orbit 1, it is orbit 2? Bohr said that distance will be termed as orbit where angular momentum of electron is quantized as a multiple of h upon 2 pi. So first orbit will be 1h upon 2 pi, second will be 2h upon 2 pi, third will be 3h upon 2 pi. What is orbit angular momentum? MVR. So this MV upon h can be seen in de Broglie also and in Bohr's postulate also. So replace this MV, so we get 2 pi r is equal to n times of de Broglie's wavelength. And you are asked for the third orbit. So for third orbit, 2 pi, this becomes third. This lambda we have to calculate. What is r? R is equal to r naught into 3 square upon, for hydrogen z is 1, so this got cancelled. So this is beautifully 3 2 just 6. Perfect. Ayush, you got your answer. Attempt the next question. Ayush also, Akshay also. Perfect, guys. Good. I'm enjoying. Very good. Let's finish this chemistry today. Chalo. Again, I guess it's a doable question, because again the radius thing is used. Radius of first Bohr orbit is given as an r naught value is given to you. Radius of third Bohr orbit of helium, that means n equal to 3, third Bohr orbit, and z you have to use as 2, because this is He plus. So obviously you will get your answer 270 picometers. Into divide you have to do. I've told you. Now this I'm leaving. It is quite doable. 270 picometers. Leave. Move forward. Next question. Shortest wavelength. Perfect, Ayush. Next question. Attempt this one. That was just formula based. So I moved ahead. Shortest wavelength of hydrogen in Lyman series is lambda. Now what is shortest wavelength? Wavelength is short, frequency and wavelength are inversely proportional. So if wavelength is minimum, frequency is maximum. Frequency is maximum as an energy difference is maximum. Why I'm doing like this? Because hydrogen spectrum picture is very famous. This picture. From this is energy. What is energy of nth orbit, sir? E, anything about infinity, 0. So of infinite distance, energy is 0. Sir, this is x-axis. What is energy of first orbit? Minus 13.6. So if you plot this in an xy plane, you will see this is large energy difference, this is less energy difference. If electron make a transition from higher state to ground state as in n equal to 1, the spectral lines are called Lyman series. Similarly, Lyman, Balmer, Paschen, bracket P fund. I say P fund because that P, English is a mysterious language. So now Lyman series in the broad spectrum lie in the ultraviolet region. Balmer lies in the visible region, and Paschen bracket P1 lies in infrared region. Perfect, sir. Now, it is saying Lyman series, the what is highest energy? Sir, highest as in highest energy difference. That means from infinity to 1. So what is the formula for wavelength? 1 upon lambda is equal to Rydberg's constant into z square into 1 upon n1 square minus 1 upon n2 square. Whenever electron is making a transition, lambda cannot be negative. So you always, when mathematically doing it, put n1 lesser, n2 greater, as in 1 and infinity, which is lesser value 1. What is greater value? Infinity. So anything on infinity will become 0. So 1 upon lambda is nothing but r. This is given because it is saying for hydrogen. The longest wavelength in Balmer series of He plus. He plus, student miss this. For He plus, Z will be 2. So this Z square will be used. So use this. For R, you can write 1 upon lambda. So that 1 upon lambda dash put in this formula. But what will be N1 and N2? The question is saying longest wavelength of Balmer. So wavelength maximum. Wavelength maximum as in energy difference minimum. That means it will be 3 to 2. So 1 upon 2 square minus 1 upon 3 squared into helium, that is 2 square. What is R? R is 1 by lambda. So this will be equal to 1 by lambda dash. Solve and I guess you will get your answer as Bombay. Options are already given. Perfect. Moving forward. The radius of second Bohr orbit. Again a doable question. I'm just writing the values for you. Second Bohr orbit as an R2 is given, but R2 of Li plus 2 is given. It is given out to be X. What is the formula? R0 into N square, which is 2 upon Z for lithium is 3. Do for beryllium. Orbit is 3, beryllium atomic number is 4. I guess. Very good. Akshay gave answer B, 4 by 9x. Akshay, you did some calculation mistake, bhai. It is C. See, whenever you gain confidence na in the okay, but beta, what pressure I am giving? Mains will give you more pressure. Answer is C, bhai. Answer is 27 by 16x. You must have forgotten about this third orbit and beryllium. Beryllium has Z4. Chalo. It is C. It is given out to be X. Sir, it was for the previous question. Okay, I'm sorry. Perfect, guys. Moving forward. Next one. The wavelength of electron neutron will become equal when velocity of electron is x time velocity of neutron. Okay. Wavelength when velocity of electron is x time velocity. Okay. So mass and wavelength, how it is related? So de Broglie. So use de Broglie's equation. So wavelength of an electron becomes equal to wavelength of a neutron. When does this happen? When velocity of electron is x times velocity of neutron. It happens at this point of time. So you have to calculate this value of x. So use de Broglie equation. So this is h upon mass of electron into velocity of electron. H upon mass of neutron into velocity of neutron. It is saying velocity of electron is nothing but x times of velocity of neutron. So this will be cancelled. This will be cancelled. So I guess you got your answer as 1 upon mass of electron into x will be equal to 1 upon mass of neutron. Now maths you have to do, mass of electron, mass of neutron, the ratio you have to do, and you will be getting, okay, I guess into divide you have to do bhai over here. You will be getting a value of x. I am giving you the answer. Into divide you have to do very precise. So such questions, be scared. Ayush, perfect. You have got the perfect answer. 1758. Perfect, bhai. The next question. Attempt. Which of the following is correct plot for probability density as function of distance r from the electron from of the electron from nucleus or 2s orbital? Now listen, guys. if I'm moving radially, first I should know that when the probability will be 0. It will be 0 at node. What is the formula of radial node? Node is a region where probability of finding electron is 0. What is radial node? Formula can be calculated by the formula n minus L minus 1. So for 2s orbital, it will be 2 minus 0 minus 1, as in it will be having one radial node. S, what is shape of S? Sir, S is a sphere. That means at the origin, probability of finding electron is maximum. For P, D, F, all, what is their shape, sir? Their shape at origin, it is always getting 0. So for P, D, F, the probability of finding electron at origin, at center, is 0 for P, D, F orbital. So their graph starts from 0. But for S, it starts from a maximum. Now, first you should know this. What is the second point that you should know? Number of radial nodes, because that many times you have to become 0. Now, I'm coming back to this option, but first let me give you a basic. For S, I will be starting from maxima. So starting from maxima. Then, because it is having one radial node, so make it 0 once. Again increase. Now this is wave amplitude. What is wave? Sir, wave have positive notion also, negative notion also. So graph will go positive side also, negative side also. And then it will turn 0. So we only take node as this. Node at the center and at infinity is not considered. This is point number 1. So this is a graph for wave amplitude. Now square this, you get probability density. So sir, I'm not asking you to take the value, just the notion of the graph. Sir, it will be positive and this negative will also become positive and then it will approach 0. So this graph you have to tick from the option, which will be option number B. And nodes formula also I have given for those who are taking notes, these notes as their nodes. So radial node is this. There is also one more, which is node, which is angular node. What is angular node? It is calculated by the value of L for the orbital. Now, sir, what is probability? This is density multiplied by volume. What you get is a probability distribution function. Now because it is multiplying by the volume, so it will be having that radius, the radial function. So if the y function is also having that r, so it will be definitely starting from 0. How to draw this? It is always an increasing graph, as in how many radial nodes I have? 1. So increase the probability, then make it 0, because initial and infinity you do not calculate as node. Again, it attains a higher maxima and then approaches 0, because there is only one node. Why? Because for 2s, I have initially calculated radial node as 1. So these will be the 3 graphs for 2s. In the question, you are just asked about this graph. So answer will be option number B. Moving forward. These graphs question are famous in mains also, and they are very, very famous in advanced also. Next question. Attempt. If uncertainty in velocity and position, this is simple Heisenberg's equation, which says uncertainty in position into uncertainty in momentum, but because question is using velocity, so I'm writing velocity. It will be greater than or equal to h upon 4 pi, but because over there I have not written momentum, so mass will be coming here. Uncertainty in position, both value are given. So this is delta v, this is delta x, h is already given, 4 pi mass. This is the question I'm just using to revise the formula for Heisenberg uncertainty principle. So not investing much time in this, because it is also calculative. You'll solve, you'll get 21.98 approximately, you'll say it is 22. So such questions, beware of attempting them. Attempt them in the second round. Initially, although you know the formula, but still leave them. That's why I have taken that question. In the second round, you can come back to it. Ayush, it is 20, it is not 23, it is 22 bhai. So that's why, sir, these questions, see, if you start a question and in 30-40 seconds, you will get a feeling it is calculative. Leave it. Come back to it in the second round, because there will be many questions in physics. Maths, obviously you have to But there also you can build an approach. You tomorrow you will be having your mathematics lecture also. So building approach, do not attempt the paper in one go. Always attempt in two go. Whole physics, chemistry, maths. First, all attempt physics, chemistry, math, easy and moderate ones. I'm saying easy and moderate one, which are taking less time. That's it. What theory I know, if I remember it, answer will be easy for me. But my point is, I mark easy and difficult as per the time consumed in that question. So never attempt, even you know the question. If you have, let's say you have attempted 1 minute, but you know it will be it will be taking 4-5 minutes more, then it's better to leave it. Come back to it later, but at least go through the complete paper first. So never attempt paper in first go. Moving forward. Now, attempt chalo 50-watt bulb, as in it is giving you power. So what is power? Work done per unit time. What is work done? The energy given. What energy? Total energy upon time. Now what is total energy given by a source? Sir, source releases electromagnetic radiation. How many electromagnetic radiation it is releasing? Let's say photons, it is releasing n photons. Energy of each photon will be hc by lambda upon time. So this is how you relate power, number of photons per unit second, and energy of each quantum or photon. I guess power is given out to be 50. Put the value as this is power P 50. SI unit is watt. So just put 50. Wavelength is 795 nanometer, as in 10 to the power minus 9, because SI unit is meter. Number of photons emitted per second, as in n by t, you have to determine. You have to determine this value. And once you solve this HC, we know it is also given in the question. Once it is given, you try to, because it is saying it is x into 10 to the power 20, so you have to be precise with calculation also, then make it in that format. So I guess I have given you the logic. Into divide is your here approx can be done. There are some questions I told you yesterday. I thought I'll be calculating every questions also, but by the amount of time we consumed yesterday, therefore I did some modification this morning. So you can, here approximation can be done. You can practice. Moving forward. Atomic structure done. We move to periodic table and chemical bonding combined. Identify the correct standard enthalpy of formation. Now, what is enthalpy of formation? Amount of energy released when a compound is formed. Sir, if a compound is formed and compound is stable. Sir, if a compound is stable, that means its energy will be less. So where the energy has gone, it must have, when it was formed, it must have released much amount of energy. So whenever enthalpy of formation is high, the compound formed is very stable. You are given sodium salts of halogens. Sir, which? They are all ionic compound. So ionic compound having perfect lattice. Not perfect, as in having strong lattice. So ionic compound having strong lattice will have highest urge of getting formed. So it will have maximum enthalpy of formation. Okay, that means this question is talking about lattice enthalpy. So lattice is attraction between plus minus. So plus minus, sir, it is charge density. So lattice enthalpy will depend on charge density, as in charge upon size, ionic size. Sir, charge +1 -1 all are same, so it will depend upon size. Sir, cation is same, so whichever anion is smaller will have highest delta H lattice, as in fluorine. So answer will be 2. Very good. 2 of our players have. Okay, for you, for those who are finding it for theory, whatever I've iterated, I've given it a picture also. So moving forward. Now attempt this one. Given below are two statements. Atomic radii of O2 minus and Mg plus 2 are same, and both are isoelectronic. This is, both are isoelectronic. This is right, but obviously this is not right. A very basic point. Why? Sir, we know for isoelectronic species, we can do this. What? Sir, we can calculate the number of electrons and protons. Sir, size is a play of tug of war. So if number of isoelectronic species have same electrons, so those species who are having a stronger number of protons will pull the electrons, and therefore the size will get reduced. So when will be the nucleus is having more protons? Sir, more will be the positive charge, more will be the number of protons for an isoelectronic species. So more positive is smaller and more negative is larger. So anions are bigger, cations are smaller. If you just know this, you will get your answer as D. Moving forward, attempt this one. This is just a logic of periodicity. Periodic table, remember I told with quantum theory also, with 37 atomic number, it was, I mean, there was no need of giving you the complete. But why I have given that picture to you? Because now the atomic numbers are given. So if the atomic numbers are given using magic numbers, 2, 8, 8, 18, 18, 32, 32, you can find it, they belong to which, they will lie in which period. Then place them using the atomic number given, 33, 53 and 83. So first position them. So periodic table we know. So this is 36. So this is 36, 35, 34. This is 33. What is 33? 33 is X. So 33 is X. Now what are the two? 53 and 83. 53 and 83. So this will be 53, which is Y, and 86, 85, 84, this will be 83. It will be Z. Now, sir, obviously we know down the group, metallic nature increases because size increases. Along the period, sir, metallic nature decreases. In fact, non-metallic nature increases. But in between, they are metalloids. In between, they are metalloids. So now going to the option 83, which is Z, must be a metal in comparison to 33. So going to the options, Z, see, Z is a metal. This option is also saying Z is a metal. This is also saying, it is saying non-metal. So this option is definitely gone. Now, Z is a metal. All these options, obviously all are not metal because they are lying in P block, so they can't be metal. Only the extreme down one will be metals. Now what about X and Y? About metalloid and non-metal. So this we can say some middle ones are generally metalloid. So X will be metalloid and Y will be non-metal, because along the period I am moving. So along the period, non-metallic nature increases. So X will be metalloid and Y is a non-metal. Is a very good applicative question for understanding the periodicity. I guess you got the answer. Perfect. Ayush has given the answer. Good. Moving forward. Next question. A very famous question. This one also. 5 successive ionization energy. Now, why I'm giving you this question? Because you can even predict valence electron. How? Once successive values of ionization is always increasing, because once you take one electron from me, I'll become a positively charged species. If I'm plus, I will always have affinity to attract minus. Why will I give one more electron? So if you try to remove second electron, whatever be the electronic configuration, still successive value of ionization will always increase. But when it increases drastically, it means configuration has become inert. So 800, 2400, 3 times. Not even twice. Oh, 10 times. Done. That means I was having 3 valence electrons and now I must have become inert. So number of valence electrons are 3. Perfect. Moving forward. Do this question. Perfect, Ayush. Perfect, Akshay. Perfect, guys. Now, first ionization energy of this respectively are. Now again, periodicity you again have to apply. Now applying that, you have to calculate this value. Now the only point of difference will be in magnesium and aluminium. Why? Because magnesium has fully filled NS subshell and aluminum has 3p1, which is partially filled. So obviously because this magnesium guy is having fully filled configuration and penetration of S subshell is penetrated closer to the nucleus. So removing electron of S subshell is rather difficult. Therefore, there is along the period, what we say, periodicity says along the period ionization should increase. But there's an anomaly from group 2 to this p block, which is boron family. So therefore, answer is definitely option A. Perfect. We got Vinod also. Perfect. Vinod, Ayush. Perfect, guys. Moving forward. Now, next question. I'm trying to cover all the theory, guys. So, giving you notes also. I'm iterating some theory because I've written. This morning I've done this because I can't write and be quick, na? Because physical, organic and organic was taking too much time. Okay. Now, aluminum is usually found in +3 oxidation state. In contrast, helium exists in +1 and +3 state. This is due to, now, a very famous concept of inert pair effect. A very famous concept of, very good, Vinod. We got one more participant, Vinod. Inert pair effect, very famous. Now what is it? I'm just iterating it. I've written it. Valid for p block elements. What happens is, down the group, when we go to p block elements, sir, after 4th period, D is filled, 3D, 4D, 5D, as in 10 protons are added extra. So if 10 protons are added, nucleus is very strong. What amount of attraction valence electron feels? Sir, effective nuclear charge. What is effective nuclear charge? Nuclear charge minus shielding. 10 protons are added. So if 10 protons are added, so Z increases, so Z effective increases. But sir, electrons are also added in D and F, which have not poor, very poor shielding. So sigma decreases, so Z effective becomes drastically strong. So if my effective nuclear charge is very increased, and it will be increased to maximum magnitude for whom? Sir, when F will also be filled. That means for 6th period elements. So especially for helium, the most heavier elements of boron family, carbon family, nitrogen family, their Z effective is not huge. It's very huge. Sir, if nucleus is huge, it will do what? It will attract. Attract whom? Valence electron. Penetration of Ns is more. So they attract S to such an extent, then S is not regarded as valence electron. Because I have attracted you so strongly, you can't go. You are now my inner shell. You are not my valence electron. So down the group, metallic nature increases. Agreed. These are metals. Agreed. Metal give electrons. But what electrons? Valence electrons. Now Ns are not regarded as valence electrons. So stability of group oxidation state -2. Why? Because Ns has 2 electrons. So for helium, +1 is more stable. Lead, +2 is more stable. Bismuth, +3 is more stable. A very important point. JEE will ask in n number of options, which is reducing agent, oxidizing agent, but you should know this. So for the given question, answer is D. Moving forward. Let us attempt this question. Highest dipole moment. Now, electric dipole is a property of charge. Electric dipole is a property of charge. So who will have more charge? Sir, this carbon, no polarity. Sir, organic resonance. Let us do pi delocalization any side. So let's say I'm doing this side. So 1 will become minus, this guy become plus. What is aromatic compound? Cyclic conjugation. You should be sp2 hybridized, so it is planar. Current loop is also there, but current loop must be created by 4n plus 2 pi electrons, not 4 pi electrons, because if 4 pi electrons will create that current loop, I'll become anti-aromatic. Aromatic is stability and anti-aromatic is highest order of destabilizing. So non-aromatic is aam aadmi, average. Aromatic is hero and anti-aromatic is terrorist. So I do not wish to become anti-aromatic, but if I do this, this guy becomes anti-aromatic, because then it will having 4 pi electrons. So this will not be happening. Similarly, this guy, if you move any side, this will also, because 1 will become anti-aromatic. This is a perfect case. Why? This will become plus, so it will have 2 pi electrons, and it will become minus, so it will having 6 pi electrons. So both these rings will become aromatic, hence perfect. Option 4 is right. Vinod, perfect. Okay. Okay, Ayush, good. Acha, I have given answer. Hey, I am sorry. Moving ahead. So anti-aromatic is terrorist. Who wants to become terrorist? Chalo. Moving forward. Which of the following process the bond order increases and paramagnetic character changes to diamagnetic? Very question. You will get this question, a form of this question. I'm writing it. You will get one question of this. This is nothing but MOT. One MOT question, obviously, all the time in every session comes. How to learn MOT? Perfect. Option C. Perfect, mere bhai. Perfect. So revising MOT very fastly. That's why for nitrogen and smaller species, what electronic configuration we follow? Intermixing happens, and when intermixing happens, this one. When intermixing happens, pi 2px, pi 2py is filled first, sigma 2pz is filled later. For oxygen and heavier elements, obviously sigma 2pz is filled first, pi 2px and pi 2py is filled later. Now, once we fill these electrons, how to fill these electrons? First, above lower molecular orbitals are filled first. Post that, pairing you will do when singly you have filled those electrons. And in order to calculate bond order, what you do? Number of bonding minus anti-bonding upon 2. If they have unpaired electrons, they'll be paramagnetic. Paramagnetism is calculated by under root of n dash into n dash plus 2, where n dash is number of unpaired electrons. If they have all paired electrons, they are diamagnetic. But you have to religiously do for all, then you will definitely get your answer. Now, sir, but this is NO. NO is not, MOT is valid for homonuclear diatomic molecules, not for heteroatomic. But for heteroatomic, we do some generalization. What is the generalization? You check the neutral molecule. If the neutral molecule like NO is the neutral molecule, calculate total number of electrons. If the total number of electrons are more than 14, then go for electronic configuration of heavier members, as in for oxygen. So we are doing MOT of oxygen. If the total number of electrons are falling less than 14, then go for nitrogen. Although this is not a rule, this is a generalization that we do, and in JEE we find answer. Mains you get your answer. But obviously you got an answer, but there is an exception. Exception for, there is no exception actually. Whatever we are doing for heteroatomic molecule, more than 14, less than 14, this is no theory. This is a generalization that we do, and it satisfies answers. Actually, when two atomic orbitals linearly combine, the Lakau thing, linear combination of atomic orbital, when they are homonuclear, it's a perfect Lakau. It's a perfect linear combination of interfering, because waves interfere, constructive also destructive. Constructive interference, formation of bonding molecular orbital take place. Destructive results in the formation of anti-bonding, high energy, less stable, the least unoccupied molecular orbitals, LUMO. Now, if participating atomic orbitals have dissimilar energy, like oxygen and carbon, then actually you should actually know their MOT. Sir, then we have to learn. Nahin. For CO, you should learn the trend, the energy trend. What is the energy trend? Sigma 1s, sigmastic 1s. Sigma 2s, sigmastic 2s is an anti-bonding molecular orbital of second orbit. For carbon monoxide, its value is not increased. It is increased by all the bonding molecular orbitals of second shell. Therefore, after sigma 2s, fill the other bonding molecular orbitals of second shell. So it will be following, because CO is having how many electrons? 14. So it is not more than 14. So follow all that rule you should follow, because what rule we have generalized? If it is 14, we will follow for N2. So follow for N2. But only with this exception, that sigma 2s will have energy even more than these bonding molecular orbitals. Then sigma 2s will come. You fill, you find bond order, you will find bond order as 3. For NO plus, we have already calculated as 3. Okay, for CO it will also be 3. So summation you are asked in the question, which will be 6. Although I tell you one thing, for this particular question, if you do not even know this, you will get your answer as 3. But for good questions, I am giving you, and JEE, it is famous. If CO plus you are asked, then electron of this anti-bonding will be removed. So for those questions, you should know this. This question can even be done by the generalization method. Moving to next question. Admit card website not working due to high volume. You can leave for, I mean, whatever city and center it has been allotted to you, it has been allotted to you. It will not change. So first study, then after session you can go and check. It will be opening. I was listening to BMC election also website. It was saying, acha, no political. I was just listening to news today. Chalo, next question. High traffic. Yes, Akshay. A very important concept of back bonding is asked in this question. Sir, what is back bonding? Now, if somebody is having lone pair of electrons and it is forming a sigma bond with another species which is having empty d orbital, then lone pair of this, if I have lone pair, I will be acting as a Lewis base. That means I would wish to give electrons. If I want to give electron to other, if I have an in-house molecule which is offering its empty orbital, why won't I will be furnishing my electrons to that guy? I will, and that particular bonding is called back bonding. So nitrogen, because of presence of lone pair, is a base. Silicon is a third period element, so it will be having available empty 3D. So this nitrogen with silicon will form a back bond. It will be a 2p 3D back bonding. Sir, it can happen here also. Resonating structure, here also. Resonating structure, here also. These all are canonical or contributing structures. Molecule does not exist in the canonical forms. In fact, it exists as a resonance hybrid. So every bond is single. Sometimes you are double, sometimes you are double, sometimes you are double. So its hybridization is sp2 because lone pair is not available on nitrogen. Because lone pair is not available, so it will be trigonal planar, sp2 hybridized. So it is a planar molecule. While this nitrogen, why it is not coordinating? Carbon do not have empty orbital. Therefore, it is your simple knowledge, sp3 hybridized. Geometry, how you have positioned them is tetrahedral, but shape is with respect to nucleus. So trigonal pyramidal. I hope answer is clear. Answer is A. Vinod has written option D. Maybe for the previous question you have written, answer is A. Moving forward. Attempt this question. Sum of pi bond present in peroxo. Now what is peroxo? Peroxide linkage. What is peroxide linkage? O bond O linkage. Disulfuric acid. Sulfuric acid we know, remove H of H2SO4, make H here also, H2SO4. Now, why I'm iterating it first? Because structure I've already made in the next slide. What I'm trying to tell you initially only that whenever, first you should know a structure. Let's say you do not know a structure and you are attempting it for a go. Make structure symmetrical. Make structure symmetrical, as in peroxide linkage. Now, if you draw a symmetrical structure, peroxide linkage, for H2SO4, remove one H. So OH, S double bond on this. Repeat the same structure. So generally, structures when comes, they are symmetric generally. Although you have to know these structures, but even if you do not know, I am giving you a sense of level, how to predict them. Now, this is peroxodisulfuric acid and a very famous compound. What is pyrosulfuric acid? When you remove this peroxide bond, keep it only one oxygen. This is pyrosulfuric acid. What is the number of pi bonds? I mean, it is quite clear. These are 4. These are 4. So answer is 8. I'm giving an extra information. What is that? What are the types of these pi bonds? So these pi bonds are p pi, d pi. Whose p is used? Sir, oxygen. This p orbital is used for oxygen. This p orbital is used for making the pi bond. For sulfur, this is ground state. So these electrons will get excited to the D subshell. So this D pi will be bonding with this 2p pi. So this will be D pi p pi bond. although not asked, but some questions ask that also. That's why I've made this picture. Moving ahead, next question. Moving to the next question. It is having assertion reason. Assertion says zero orbital overlap is an out. Yes. Combining atomic orbitals overlap with each other to do what? To pair then unpaired electron. Who told us this? VBT. But we know that if orbitals are not aligned in sync, then they can have ineffective overlap and hence no bond will be formed. So zero lap overlap is due to out of phase overlap. So this is correct. It results due to different orientation. Yes, this is also correct. So both are correct, I guess, and both are true. R is correct. Option 1 will be right. Huh? So this is a picture to those who do not know that this is this amount of overlap. You don't, sir, this much is happening. No, this is not. This is zero overlap. Moving forward. Which of them? The famous question of Poisson's rule. Which of the following is least ionic? The question is saying which one of the following is least ionic. Sir, how to calculate ionic nature? Go to Poisson's rule. What is Poisson's rule? In ionic compound, how you check their covalent character? The covalent character of an ionic compound increases first when you have D block cations. D block cations, especially with pseudo inert configuration. Pseudo inert configuration as in those who are having completely filled D, they have high Z effective. High Z effective will do what? Will withdraw electrons and will create the polarization. It will increase the polarization power of cation. Once polarization power of cation is increased, it will try to attract electron of anion also. If it is attracting electron of anion also, it is attaining a sharing nature. So covalent nature will increase. Point number 2, if cation has more charge density, more charge, more covalent nature, less size, more covalent nature. Because of the same fact, polarization power increases. And last thing is, larger be the anion. So a larger anion tends to give away its electron easily. And therefore, it is in English, it is termed as polarizability of an ion increases. So these 3 points increases the covalent nature in an ionic compound. So comparing for all these 3, obviously I can see this guy is a D block cation, silver. Sir, but cobalt is also D block, but silver is having pseudo inert configuration. So AgCl will be most covalent, and because it will be most covalent, so it will be least ionic. So I guess Vinod, Ayush, perfect too. I guess Vinod is giving answer for previous question. So answer is, I've given you the complete theory. Answer is AgCl because time is less. Moving to the next question. Using the same logic. Now, using that logic, apply in this question. It says lattice energy. Based on lattice energy, which one of the following alkali metal chloride is expected to have highest melting point? Who will have highest melting point? Ayush, give answer 3. Okay. Who will be having highest melting point? Sir, melting point is a property of ionic compound. So more will be the ionic character. More will be the ionic character. More will be melting point, boiling point, solubility in water, whatever ionic compound property has. Sir, so based on lattice, sir, more stronger will be the lattice, more will be the ionic nature. So actually, the lattice question we have done. Sir, lattice is proportional to charge upon size. Lattice enthalpy thing. So charge is same, so again it will be decided by size. So anion is same, so cation is different, so size of cation is increasing, so lattice will be weakening. So top one will be having high lattice. High lattice has an, do not apply Poisson's rule. Tribhuvan, if you directly apply Poisson's rule, what you will commit wrong is first check the lattice. So as per lattice I'm saying is the cations at the top, which are small, will be having stronger lattice. So cations at the top will form a salt with stronger lattice, and because their lattice is strong, so they will be having high melting point. Now that's why I am rejecting rubidium and all the potassium. I am competing lithium and sodium because these are salts of smaller alkali metals. But with only lattice consideration, we will think LICL should have highest. But now for LICL, because second period elements are not small, they are very, very, very small. And because second period elements are very, very, very small, therefore now Fazan's rule will dominate for only LICL. And what Fazan's rule will compel LICL to build, LICL to be, Fazan's rule will say, Li, you are very small. Li plus will say yes. So Li plus covalent nature will increase because of high polarization power of Li plus. And because its covalent character is relatively increased for a stronger lattice. Therefore, relatively it will have more covalent nature, and therefore NaCl wins the race. A very beautiful question which confuses students. So actually NaCl is your answer. I've given you the detail also, but it's a good question. Because question is initially telling you also based on lattice. So first see lattice and then go to Fazan's rule. A good question. Moving forward. Theoretical explanation. Attempt this one. A question for calculation of hybridization. Hana? So what you say after this chemical bonding, we'll do a break. Hana? Yes sir, I can't control my English. Can I speak Hindi? Sonali? You can speak. I can't control my English. Okay, Sonali, you can write in Hindi. I will be obviously replying in a common language, which this channel is for. Okay. You can't control my English. Okay. If you will be writing in English, then you will be writing something different or what? Chalo. So I guess the reaction in which the hybridization of underlying species. I was asking some because I've opened the gate. So, chalo, moving. Hybridization of underlined atom. This is the underlined atom. Phosphorus. Sir, you can definitely draw the structures. Obviously, it is an oxo acid. So, P double bond O. Because it is H3, only one oxygen. So this is OH, H. These are, mind you, again I'm deliberately because they consider block logics also. What are the block logics? Sir, hydrogen connected with phosphorus are reducing hydrogen, not acidic. So this guy is having only one acidic hydrogen, although not asked in question. Now, when this guy undergo disproportionation, this is a oxy acid of phosphorus. Now I'm moving forward because inorganic knowledge I can't write, it take much. This hypophosphorus acid, block chemistry knowledge giving you, it disproportionate to form phosphine and orthophosphorus acid, simply H3PO3. So because here also, the hybridization is same, because although oxygen are gone, but sigma bond is replaced by lone pair, so steric number will remain the same. So hybridization is same. So answer, it is not our answer. Why? Because hybridization is same, but I am giving you block chemistry logic also. Now, H2SO4 reacts with NaCl. Sir, does what? Sir, it is an acid based reaction because H2SO4 has a very high boiling point. Again, a block chemist. So such a high boiling point acid can produce other acids of less boiling point. So HCl is produced. Now here sulfur is sulfate, here sulfur is sulfate, as in sulfate is in form of sulfate only, so hybridization is not changing, so not an answer. Ammonia, because it's a base, it reacts with H plus, forms ammonium ion. But here lone pair is replaced by a sigma bond, so that nitrogen is also sp3. This nitrogen is also sp3, so hybridization not changed. Yes, a very important inorganic reaction, block chemistry logic. XeO4 reacts with antimony pentafluoride. This is a flow, it releases F in form of F minus and gives that F minus to antimony, and it becomes SbF6 minus because fluorine is small, and the this antimony, which is an oxygen family member, it has an ability to accept that F minus from this fluorinating agent, so it will form a cation and it will form an anion. And obviously you can see the hybridization from sp3d 2 of xenon is changing to sp3d, and obviously of that guy is also changing, so it is your answer. A very important block chemistry logic also. Moving forward, next question attempt. Okay, Sonali's paper is on best of luck girl. And remember, Sonali, 21, do not make this thing a point for, I mean, a, a, a Lakshman Rekha for you. 21, 22. If you're having a paper on 23, you will be having 4 papers. 21, 22. 21 you will be having shift 1, shift 2. 22 you will be having shift 1, shift 2. Attempt those 4 papers as if you are attempting your JEE paper, because then you will be giving that paper 5th time. On 23rd, your shift is shift 1st or 2nd. I am from Laksh batch. Okay, Sonali. Thank you. At least you are participating here, because here, see, when students are less, we are new channel, so students are less, but we can interact. So it's, I mean, it's a one-to-one class. So obviously, when I saw physics, I thought it is very good because we can interact. So perfect. So those of you who are having paper on later slots might see, Vinod. Okay, your is on 21. So I mean, it is not a profit. I mean, it is a profit. Actually, NT repeats pattern, and I'm not saying you'll get the same paper, but the temperament you will build. I am telling you that if let's say you have paper on 23rd, attempt paper analysis also will be coming as soon as possible. You will be getting paper within 1 hour of the when paper is released. Start attempting those questions as if it is your, sit with a pen and copy in front of YouTube. Whatever, who we'll also do analysis. So, do see the question and then start doing. It will it will give you a temperament. You will be very accustomed in 2nd or 3rd day. People say don't study at last moment. I tell you one thing. I passed out from NIT Kurukshetra back in 2011. Our hostel at that point of time, new hostels were just getting built. So from that to examination center, it was a walk of 1 kilometers. You know what we used to do? Autonomous college, your professor will make the paper, so you know what the professor is going to ask. There are some topics which are very time consuming, but you are very sure they will be coming. For 100% they'll be coming. We used to do that topic, that 12 out of that 60 marks, total 60 marks, that 12 marks coming paper, we used to finish that in the last 1 hour. Not last 1 hour, last 1 hour before reaching the examination hall. In the walk, we used to finish in the 1 hour walk. You also check for yourself. You must have attempted your board examination class 10th. The amount of study you can do in one night, you will be astonished by studying that much. You will not believe that you can do that much, because you can. The only point is you should know your why. So that's what I'm saying. If you have paper on 23rd, 21, 22, religiously practice. Practice as if you are giving your paper. And trust me, whatever score you will be getting, add 20-30 marks to it. Huge difference. Chalo, this question. Now, boiling point of H2 is this. H2S. Obviously, sir, we know H2O involves hydrogen bonding. Hydrogen bonding is the strongest intermolecular force of attraction. H2S is polar molecule, so it will be dipole-dipole attraction, weaker. So obviously, if this is 373, so it will be much lesser. So it will be lesser than 373. What options I have? Equal, no. Less than, maybe. More, no. Greater than 300, but less than 373. Why? It should be much lesser. Why it should be much lesser? Because for oxygen, I'm saying this. Else, remove oxygen, go to periodicity. So down the group, size increases, mass increases. So size and mass increase. So obviously, 10 kg will be getting boiled and melting at a higher pace, because more be the size, higher will be that case of intermolecular attraction. So down the group, generally, because as dipole mass increases, down the group, boiling point, melting point both increase. But for oxygen, because the intermolecular interaction for oxygen containing species, for O bondage containing species, is not simple dipole-dipole attraction. The extreme case of dipole-dipole attraction is hydrogen bonding. Hence, answer will be option A. This is obviously this H2S will have the least. So if it is least, so why we are saying more than that? So it will have the least. Whatever less option is given, that is option A will be your answer. Good question. Moving forward. Perfect, Sonali. Perfect. Good. And thank you. At least you are here also. Good. Now, this is a reaction. Okay. I guess equilibrium is starting from. So, what can we do is, let's, you can obviously try this question, and we are taking 7 minute, 7 minute breaks because I need to refill my water. So, stopwatch, where is stopwatch? 7 minute break. 7 minute. 7 minutes break, guys, है ना? So go to restrooms and fill up your water bottles. We'll meet soon. Yes. Okay, I'm sorry, I'm late by 1 minute. I wrote. Actually, I started that timer. While I was taking away my bottles, I saw it was 7 hours. That's why corrected it. Okay, now, guys, I'm audible. Hello, hello. We are back, sir. Okay, audible. Okay, thank you so much, sir. The flames. Okay, chalo, guys, I'm audible. Thumbs up. ऑडिबल सर केमिस्ट्री में बायोमोलिक्यूल बहुत दिक्कत दे रहा है हाँ सोनाली बायोमोलिक्यूल्स एक्चुअली सी in your mocks if you are scoring more than 160 165 then invest time in biomolecules because for biomolecules I'm telling you one thing only as per biomolecule for at least do all the reactions of mains as in NCRT. For mains, do all the reactions of NCRT because biomolecules is a chapter loved by advanced and definitely advanced also ask fun questions. But for mains, do only NCRT and whatever notes you have for biomolecules for that particular chapter and for salt analysis also, turn those notes regularly in the morning while brushing. Brush, keep them in front of you. I mean, you have to do it regularly. Even if you start from today 4-5 days just browse through those pages regularly even you will remember that this thing is written over here now make this thing a point that whatever you revise from the same copy and same picture do not change the picture always if you are reading a reaction from read the same place read the reaction from the same place from the same words so that the pictures get inside you so then you'll say Arey, we are forgetting something it was written somewhere here our brain is prone to have photographs inside it so read everything from a single place that's why after yesterday's class what I've done is I've included because when a teacher writes in a hurry the writing is not that beautiful I mean some teachers do I'm an engineer so engineers do not write that good so I mean, I'm not saying those. No, okay, no controversy. Okay, you got my point. Is that we read from the same place. Okay, moving forward. Now, the next question says the gas phase reaction, which is this, is an exothermic reaction. That means heat is getting released. Okay, sir. The decomposition of N2O4 in equilibrium mixture of NO2 can be increased. By now, you have to increase. So, what are the steps by which you can increase? So steps are this heat addition of inert gas at constant pressure. Now if I add inert gas at constant pressure that means it is like a balloon inert gas will be added how pressure will be remain constant balloon will blow volume will increase so volume increased as in for reaction mixture concentration is moles upon volume so when volume will increase concentration will decrease and once concentration will decrease they will try to oppose so if concentration will decrease they will try to increase the concentration so in order to increase the concentration reaction will proceed in that direction where moles will increase so where moles are increasing for this particular reaction in the backward why backside because 1 mole is getting converted to 2 moles so both moles is getting increasing so it will be proceeding in backward direction from this so because it is not favorable so this is wrong now lowering the temperature now because it is exothermic so heat is a product is a type of product for exothermic reaction so if you lower the temperature product will get reduced to oppose it reaction will try to increase the product and hence reaction will proceed in forward direction so yes this is good increasing the pressure again if I increase the pressure reaction equilibrium also tries to oppose that is Le-Chatelier principle so in order to oppose it should try to decrease the pressure and for decreasing pressure it will move in the direction where moles of gas will decrease so 2 will become 1 so it is decreasing so that's why this is also correct so 2 is also right 3 is the question is asking us okay it will be having options in the later slides addition of inert gas at constant pressure because mains can't have 2 no so it will have some other options addition of inert gas at constant volume sir if volume is constant then concentration will not change. You have added inert gas, but my concentration is my moles upon volume. Volume is same. My moles are not interacting with those inert gas. So concentrations, the partial pressures and concentrations will not change. So therefore Q will not change. Therefore it will have no impact. So what are our answers for making favorable? 2 and 3. So okay, okay, a very good question. Okay, I'm sorry. I guess it's hiding the question. Ayush, perfect bhai. Actually, uh, Sumit sir, can you please ask the YouTube people to at least hide this. I'll just okay. I'll also option A. Now coming to the question, I'll just come back to the that thing, that the strip that is coming out now. For this particular question, we missed the theory. Actually, it is saying for this reaction is an exothermic. It is perfect. The decomposition of N2O4. Sir, here N2O4 is getting produced. The theory is saying for decomposition, not for this. So obviously, read the complete question. So for decomposition of N2O4 as in reverse of this reaction. So this option was not creating any impact. This was creating favorable for the reverse reaction. So it will not be creating, and that guy will win the race. I thought there will be a more option. That's why I was moving forward. Okay, good Ayush. Moving forward. Let us try this question. By the time I just message the removal of this. Yeah, I'm audible. Perfect. Okay, thank you, sir. Thank you, sir. Even I called. Chalo. Let us do this question. Now, consider this reaction. Now we have to consider this reaction only. Number of factors which will increase yield of SO3. Now this is the same question. So number of factors are, Ayush is saying 3, B, C, D. B, C, D. So I'm checking A and E. Increasing temperature. Sir, this is also exothermic. So if it is exothermic, so increasing temperature as in product will increase, then reaction will try to oppose, and in order to oppose, you should try to decrease the pressure, so reaction will proceed in backward direction. So obviously this is in not favoring, this is not favorable for formation of CO2, so A is not right. Catalyst anyway do not impact equilibrium, so this is not right. Obviously B, C, D are correct. You can check also because this is just a similar question. Answer is 3. Perfect. Moving forward, next question. It's a numerical. Attempt this one. Attempt this numerical. 4 moles of argon. You have 5 moles of PCl5. We have. They are introduced in a vessel. Volume is 100 liter. Temperature is 16 Kelvin. The system is allowed to equilibrate. How it will equilibrate? PCl5 will form PCl3 and Cl2. Now, the question is saying I'm having 5 moles of PCl5. So let's say out of these 5 moles, X are gone. So X and X are produced. Now, but I'm having these 4 moles of argon also, which is an inert gas. We have recently seen for inert gas, they do not impact the state of equilibrium, but they will increase some pressure. So they will obviously create. So how to calculate? For gases, use PV equal to nRT. And for such gaseous reaction, we only use Kp. So what is Kp? Partial pressure of PCl3 into partial pressure of Cl2 upon partial pressure of PCl5. Sir, how to calculate partial pressure? Partial pressure is mole fraction into total pressure. Now, total pressure question is giving you to be 6 atm. So, what will be this total pressure? Total pressure will be equal to partial pressure of PCl5 plus this plus this. So, if you add these three, it will be 5 plus x. But the total pressure, that inert gas will also create some total pressure. Now, these are moles. So, first, okay, so I mean, I'm first calculating the total moles. So total moles will be equal to that 4 will also be getting added, because that 4 is also creating the total moles and hence will be creating the total pressure. Sir, so what will we do? Just calculate partial pressure. How? Moles pressure is equal to partial pressure of any gas is equal to moles of that gas RT upon V. Now this is the maths you have to do. Moles, what is the value of R that you will be placing? 0.082. Temperature is 610. Volume is 100 liter. Now I have done that calculation for you because it's a question relating to inert gas. So I have done that pressure calculations for you. So what is the pressure of PCl5 initially taken? It was P naught. So that P naught was due to whom? Sir, that P naught was due to 5 moles of PCl5. So that 5 moles of PCl5 is nRT upon P upon V. Total volume is 100 liter. Similarly for argon, it is having 4 moles. So nRT upon V. So these calculations are the most important and the most hectic task for a physical chemistry question. Now once I have this partial pressure, because I am calculating Kp, so why taking moles? That's why I have taken pressure over here. But for that, these religious calculation has to be done. So now pressure is P naught, so 0, 0. So P naught minus x. So now I can say total pressure which was given out to be 6 is equal to this plus this plus this, which is P naught plus x, because these minus x's I'm removing, plus partial pressure of this argon, that is 2. This P naught is 2.5. So I guess clearly you can see this x is 1.5, I guess. This x is 1.5. Now what are we asked in the question? Value of Kp. What is Kp? Partial pressure of these, that is x square upon P naught minus x. What is P naught? 2.5. 2.5 minus 1.5 is just 1. So answer is just x square. So 1.5 squared as in 2.25. That was the answer. So option A. Moving forward, a good question, but you should invest into divide. You should invest time in into divide very religiously. So that practice will make you perfect in those questions. Moving forward, let us attempt this one. Okay, Ayush A, perfect. Sir, we can do it by, you can do by calculating Kc, but for Kc then you will calculate as per, because over here this everything was getting cancelled, no? That 1.5 squared is easy, 2.25, because 15 square we know. So that will be more calculative. But yes, Ayush, you can do that also. For calculate Kc, then Kp is equal to Kc RT raised to the power delta Ng. Then RT, R into T raised to the power delta Ng. That calculation has to be done. So anyway, you have to do that calculation. Now, attempt this one. At 600 Kelvin, 2 mole NO are mixed. 2 mole NO are mixed with 1 mole of E. Okay. So 2 moles of this is mixed with 1 mole of oxygen to form twice of NO2. The reaction occurring as above comes to equilibrium under a total pressure of 1 atm. Okay. The reaction comes at equilibrium at a total pressure of 1 atm. So total pressure again we know. Analysis of the system shows that 0.6 mole of oxygen are present at equilibrium. Okay. At equilibrium, how much oxygen? Now, in the previous question, total pressure was given. In this question, they are even giving you 0.6 mole of oxygen is present. So now that Ayush was saying, calculate Kc. Now that would be a better thing to do, because here it is saying that 0.6 mole of oxygen are present at equilibrium. So moles are given. So this was 2, this was 1, let's say this was 0. So this is 2 minus 2x, this is 1 minus x, and this is 2 forms 2. So 2x will form 2x. So this will be the equilibrium moles for these guys. Now question is already telling you that this 1 minus x is 0.6. So x is nothing but 0.4. So I know moles of O2. 0.8. So this I know it is 1.2. And this I know it is 0.4, 0.8. Okay. Now volume, I know moles and the equilibrium constant. Now you have to calculate K, but for K I need volume. These are moles. 2 moles of this are mixed with, okay, these are moles. And for volume, okay, you have to calculate volume also, because concentration is moles upon volume, and volume it is not supplying. Then actually this here, it will always leave a space for volume. Okay, let us calculate by this logic only. 0.8 squared upon 0.4 into 0. Okay, 0.4 into 1.2 squared. 1.2 squared. Calculate this. I guess it is 64 upon 144 into 0.4. It will be calculative. Let me check. This will be calculative, guys, because here you have to calculate Kp. So what you can do is Kc. It will be calculative, but see, moles we have calculated 1.2, 0.4 and 0.8. This much we have done. Now because volume is not given, so you can directly calculate pressure, like because Ayush said Kc, so I was interested in calculating Kc, but obviously Kp should be the best thing, because we know moles, we know temperature. So for Kp it will be partial pressure of each. Now total pressure, okay, total pressure question is giving na. Total pressure is 1 atm. So moles I know, so partial pressure will be mole fraction into total pressure, and because total pressure is 1, so mole fraction will be directly the partial pressure of individual gases. So what will be partial pressure of this guy? 0.8 upon total moles. What will be partial pressure of O2? 0.4 upon total moles. What will be partial pressure of NO? 1.2 upon total moles. Now that will give you partial pressure of each components. Do that. Now partial pressure can be directly used. So partial pressure of NO2 squared upon partial pressure of NO squared upon partial pressure of O2 squared. Now that calculation you have to religiously do, and then also you will get this 52 by 27. So then you will approx and answer will be 2. So it is a calculative question. Yes, a dangerous thing for chemical equilibrium. That was a very calculative question. Moving forward. Now let us try this one. I hope you got the point. Sir, Ayush, we can do first calculation Kc, then multiplying by I delta Ng, we get Ayush. Actually, I committed that also, but see, if you want to calculate Kc, you will put moles upon volume. So volume factor was needed, na? So what was the volume was, you can then again for volume you have to do total pressure is equal to, because total pressure at equilibrium is given to be 1 atm. So PV is equal to nRT. For total you will do, then you will calculate volume. So actually volume was not given, that's why it was important in that particular question to calculate partial pressure. How? Dalton's law. What is Dalton's law? Mole fraction of component into total pressure. Hai na? Sir, it was for previous. I already told you that you can calculate Kc, and then for Kp you do RT raised to power delta Ng. Perfect. Now attempt this one. equilibrium composition for reaction A is given. Okay, now the question is giving you equilibrium concentration. Now, okay, 0.2, 0.1 and 0.4. You are adding 0.2 mole of Cl2 at the same temperature, the equilibrium concentration of PCl5, and asking you the equilibrium. Now, sir, if I have this equilibrium, which is this one, let's say at a variable time t, which was actually a time of equilibrium, PCl3 was 0.2, Cl2 was 0.1, PCl5 is 0.4. Now, at this moment only, question is asking you that 0.2 mole of Cl2 is added. Sir, that means product you are adding. Reactant you are adding. So if I add reactant, reactant will do what? Reaction will proceed in forward direction. Why? To consume the extra added product. So now I know at this point of time equilibrium gets disturbed, and in order to attain equilibrium again reaction will proceed in forward direction. Now because it was initially 0.1, I've added 0.2, so it becomes 0.3, but because it becomes 0.3, so equilibrium gets disturbed and reaction proceeds forward direction. How it will proceed forward direction? 1 mole of this, 1 mole of this, and produce 1. So minus x, and that x. Now what will not change? Sir, k will not change. So at this point of time, can you calculate k? I guess that k is already given. That k is already, you can calculate also, but it is given also. It is given out to be 20. Equilibrium constant never changes, so this k value will remain as it is, so it is 20 only. So this will be 0.4 plus x upon 0.2 minus x, or 0.3 minus x. Now you have to solve this quadratic, and once you solve this quadratic, I guess it is also quadratic you have to solve. So answer will be 49. Once you solve that quadratic, you find the value of x, but you are not asked x in that question. You are asked concentration of PCl5, which is actually 0.4 plus x. So whatever x you calculate, add 0.4, that will be your answer. Make it in the format of 10 raised to power minus 2. So what integer you will be landing up? You will be landing up with 4949. Moving forward, attempt is what you can do for the later time, because right now we are learning concepts over here. Now moving to thermodynamics, this is a thermodynamic starting question. Attempt this one. Vinod is saying my answer is same. Perfect, bhai. Perfect. Okay, Ayush was saying for some previous question. Okay, bhai. Good. Keep doing. Chalo. Ideal gas undergoes a cyclic transformation. This is the cyclic process from point A and coming back. Okay, it's a cyclic process. Perfect. As shown. Now the total work done in the process, you have to now, because this is the start of thermodynamics. Yes, my answer is same. Vinod is saying 2. Okay, let's check, Vinod. Now obviously answer is area under curve. So area of triangle you can calculate. What is area of triangle? Sir, half into 20, 30 is 20, 30 minus 10 is 20, and this is also 20, but unit dimension, because I want this work in SI unit joule. So what is SI unit of length? Sir, meter. It is decimeter. So 1 decimeter is equal to how many meter? 10 is power minus 1. So 1 decimeter cube will equal to, so it will have a factor of 10 is power minus 3, which will be converted into meter. Now this is kilopascal, so kilo will be 10 is power plus 3, so plus 3 minus 3 will be gone. So okay, if you do not think about it, then also the question is served to you in such a manner that unit dimension error, if even if you commit, it will be giving you same answer. So this is gone, so the answer is 200. Decimeter. Answer is 200. But you are saying 2. Answer is 200. Okay, Vinod said 2. Ayush, answer is 200. Okay, Vinod did SI unit wrong. Okay, answer is 200. Now, for this question, although I wanted to give you this question for unit dimension also, but for one thing, I'm making this for cyclic process, work is always area under curve. Okay, sir, done and dusted. But I'm giving you a thing to learn. Actually, question is not asking you about the sign, that is work done by the gas, because work done by the gas is negative and work done on the gas is positive. So for these PV curve, you just learn this. If PV, as in P is an y-axis, V is an x-axis, and it is going clockwise, then it is negative, and make converse for everything. That is, if it is clockwise, it is negative. If it is anti-clockwise, opposite, it becomes positive. But this is for PV, as in P in y-axis, V in x-axis. If that reverses, then reverse this thing also, as in if V comes in y-axis and P comes in x-axis, if it was clockwise, and if it is clockwise, if this was negative, this becomes positive. So everything reverses. Just learn one. What one? PV clockwise is always negative, because in some question for mains also the sign is also asked. So I've just added this slide for you. Now moving forward, let us attempt this next question. Perfect guys, perfect. Thank you very much. You are all participating perfectly, and it is good whenever we stuck at questions now, that thing remains here and helps not to at least to remember it for a longer duration. So taking break till next chapter. Okay, it's your backlog. Okay, Ayush. Actually, for thermodynamics, I've separately done a one shot also, because many people fear dynamics and thermochemistry. So initially only I've done that one shot. So you can obviously, if get time, you can do that one shot. Now, let's try this question. But Ayush, I suggest I'm doing some pretty what questions which will help you if you, let's say, if you do not have time to completely watch that one shot for your mains examination. I've separately taken those questions which are that's why I'm discussing everything also. In the previous question, sign was not asked, but that's why I've taken those slides also, because I'm trying to conclude everything in a smaller amount of time. That is the purpose of this 200 questions revision session, right? Marathon. Now, the enthalpy change for the following reaction. Now this is the reaction. Okay, sir. Two reactions are given. Okay, sir. Enthalpy is an extensive quantity. Extensive as in it depends upon amount. Intensive, independent. Extensive, that depends. So enthalpy is an extensive quantity. So when you add, it gets added. When you subtract, it gets subtracted. So can you form this reaction using the given reactions? Yes, sir. Let's say this reaction is 2. I need carbon here. I need thrice of carbon here. So multiply this reaction 3 times, because, and then add it. So thrice of this will be produced. But I need Fe, and Fe is over here. 2 Fe in the product side, also 2 Fe. That means I need just the same reaction but in the reversed form. So to this equation, I will multiply 1 times only, but with the negative sign, because I want this reaction to be reversed. So whatever mathematical operation I'm doing with the reaction, do with the value of delta H. So delta H for this reaction will be twice of this thing, as in minus, this second reaction into 3 times. So 3, 3, 0 with a negative sign, and because it is getting reversed, so this minus will become plus, and this will become 822. So 822, do the simple maths, you will get your positive answer. So your answer will be 492. Simple. Moving forward, a very famous question, a very doable question, which thermodynamics people fear, but it will be a crime to not attempt such a question in JEE Mains. That's why for the single go, so at least with this 200 question marathon, what we are trying to attain is give you all at least a browse of all the topics, so that if easier topic comes, you attempt them. And why I have deliberately taken those good questions also with calculation, not to attempt them, because within a frame of 1 minute, maybe 60 seconds, 50 seconds, you get a feeling that it is calculative. Leave it. That's why I'm mentioning those questions and practicing those questions, because I'm also in a time constraint that I have to complete chemistry till the night. So the large amount of pressure you will feel during your examination 4 days after. That's why attempt paper in 2 phases, 1 and 2. Now moving to the next question. Ayush, perfect. Vinod, perfect. This question: 5 moles of an ideal gas expands from this liter to this liter. So this is V1, this is V2, that is moles. At so temperature, okay, isothermally and reversibly. So this is again a question which will be a crime not to attempt. So reversible work is equal to minus nRT ln of V2 by V1. V2, V1 given. Number of moles is 5. R is given this much. Temperature 300 Kelvin. Because it is ln, so multiply 2.303. Log of V2 is 100 by 10. So it will log 10 is 1. So just simple calculation and you will find your answer. Okay, into divide again you have to do, but this is just into divide using the same data. Answer will be 28721. Aha. Nahi Vinod, 28. Okay, Vinod is saying nah, it is just asking you the exact answer. I mean, I did these physics. Okay. Moving forward. Good. With practice, calculation can be increased. Ayush, perfect. Vinod, a slight error. I take the value of R which question is giving. I guess you have taken R from your whenever question is supplying the value of constant, use that constant value is what I'm trying to tell you. Moving forward. Again a type of question. Now what types are? See, enthalpy of formation of ethane. Ethane is a saturated hydrocarbon. From ethylene. Ethylene is an ethene, 2 carbon. This is ethene, generally named as ethylene. By addition of hydrogen, where bond energy. Now sir, if bond energies are given, generally enthalpy of reaction is equal to enthalpy of formation of product minus reactant. But if bond enthalpies are given, it is equal to summation of bond enthalpies of reactant minus product. And for that, calculate for each reactant. That's what I mean, this I have already done for you. Reactants minus products. Never commit this mistake. For enthalpy of formation is equal to enthalpy of formation of product minus reactant, but here formation is not given. Bond enthalpies are given. So bond enthalpies is reactant minus product. So obviously these values are obviously given to you. C single bond H, C single bond C, C double bond C, H bond H. Values are 1, 2, 3 and the fourth one. Place the values, subtract obviously with the appropriate coefficients, and you will get your answer to be 125. Somebody got the answer? So this question is on my test. Okay, calculation issue. Calculation, bhai, that can only be enhanced with practice. Ayush got 125. Good. Next question. Trying to browse through the logic. Calculation, yaar, we cannot do in class. We have to finish complete chemistry. This one. Logic. How do you check spontaneity of a reaction? Spontaneity of a reaction can be checked by Gibbs-Helmholtz equation, which says delta G is equal to delta H minus T delta S. Now, if you want the reaction to be spontaneous, delta G has to be negative. This guy has to be negative. So when this guy can become less than 0, when it will be depending upon this operator. Now question is telling you that value of delta H is positive. So if value of delta H is positive, then this thing can only become negative if this magnitude, as in T delta S, is greater than delta H. I am just talking of the magnitude, because this is in the question, it is given to be positive only. So the only way it can turn negative is this T delta S magnitude has to be larger than delta S. So that means T must be larger than delta H. upon delta S. Now I guess it is a simple maths. Perfect. Vinod got answer. This is 2000. Perfect. Moving forward. Next question. Next question is speaking of bomb calorimeter. The amount of heat produced as measured in bomb calorimeter. So what bomb calorimeter is famous for? Bomb calorimeter is famous for calculating heat exchange at constant volume. So heat exchange at constant volume as in QV is equal to is representing the internal energy change of the system. So this internal energy is 1406. So sir, why writing minus? Because energy is released. So whenever energy is released, work is done, it is always with the negative sign. So delta U is given. The amount of heat produced is given. At the minimum value of T delta S needed to reach equilibrium is. Okay. Now, for this reaction, now question is giving you delta U. But for equilibrium, sir, at equilibrium, no effective work is done. That means at equilibrium, delta G becomes 0. So delta G naught can be related with equilibrium constant K. But so for delta G, I need delta H. Question is giving me delta U. So relate delta H and delta U. How? Very famous formula. Delta H is equal to delta U plus delta NGRT. Now delta U value is given minus 1406. What is delta Ng for this reaction? Sir, G as in difference of moles of product minus reactant. But what moles? Only gaseous moles. Now this is gas, so delta Ng will be 2 minus, this is liquid, so I'll not take. This is gas, so 1. So 1 plus 3. To both I'm taking, so it will force. So delta Ng will be minus 2. So it will become, this is minus 2. R value is given, T is 300, but remember this is kilojoule, so you have to convert it into either divide by 1000 and convert this thing into kilojoule, then you will get your value of delta H. After you find value of delta H, delta G is equal to delta G naught plus RT ln of Q. This is how you relate effective work and equilibrium constant. Now, this is not equilibrium constant, this is reaction quotient, because when reaction is at equilibrium, then quotient becomes equal to K. Right now, at any variable point of time, you can calculate, you can relate reaction quotient with Gibbs free energy change as this. Now this Gibbs free energy change is used to calculate useful work, but at equilibrium rate of forward reaction becomes rate of backward reaction, so no useful work, no useful work, so no useful work as in delta G is 0. So this becomes equal to delta G naught plus RT ln of this Q becomes K. So this is RT ln of K becomes equal to minus delta G naught. So if you are asked to calculate K, the minimum value of T delta S. Okay, in this question it is just asking T delta S. Okay, but this formula, okay, I thought it is asking equilibrium constant, it will be asking you equilibrium constant in the later question. So I've already given you this formula. It will be used in the later question. A very beautiful relationship, very much asked by JEE. It will be used, but in this question you just have to use do the previous thing only. What previous thing? T delta S you have to determine. Delta H you know, so we know delta G is equal to delta H minus T delta S. Now delta H we have recently calculated. The T needed to reach equilibrium, and at equilibrium, this thing you need to know. At equilibrium this is 0. So this becomes 0, delta H you know, so T delta S is nothing but negative of whatever delta H you find. How to find delta H? Delta U minus delta Ng is minus 2 RT. That calculation you have to do. I guess I have done that calculation for you. Answer is 1411. Do anybody has got answer? Vinod has got. Delta Ng is not 0, my friend, it is minus 2, and answer is 1401. No, it is 1411. Into divide is a thing which you have to, which instigates students. I understand, but with practice it will come. Moving forward, This one, the next question. Now, I've told you the same thing is used, log K. Now, this question is asking log K. This is the reaction and it is exactly asking you log K. So how to calculate log K? I've given you the formulas. Delta H naught is given. This multiplier value is also given. So this will also be a calculative question, but I've already given you the formula. So I'm iterating that formula. This is the reaction. Delta H for the reaction is given. So delta G will be equal to delta H minus T delta S, because it is standard, because question is supplying you with the standard data. How they represent standard data? By applying a naught. So this value is given, that side. Delta S is given. Make sure this is kilojoule, this is joule, unit dimension. Temperature 298 Kelvin. You will find delta G naught, and delta G naught is equal to minus RT ln K, or minus 2.303 RT log K. Log K you have to find. Again, you have to do calculation using these results and you will get your answer as 10. Okay, this might be getting cancelled easily because answer is 10. I am from Maharashtra board. Okay, so did anybody solve this one? Chalo, do the next question. Attempt this one. Sonali is from Maharashtra. Perfect, Sonali. Perfect. So I can tell my mom. Ha, Ayush, dinner, equilibrium, we are done. I guess next will be ionic, will be done after, I guess, UC. Okay, I will. Right now I'm quite energized. I guess you also will be quite energized. So we'll take a break around 9. Okay. So right now we have a lot of time. 1.5, 1 hour 15 minutes. After 9 we'll take. Okay. I have brought water. Khub sara water. Chalo guys. Let's see. Consider the following reaction. Equilibrium constant, equilibrium at 27 degrees Celsius and 1 atm pressure. Okay. Now, sir, what is this? This is Kf and that is Kb. Actually, equilibrium, why K do not depend upon concentrations? Because K is actually ratio of forward rate constants and backward rate constants. So equilibrium constant is a constant because it is actually ratio of constants, and that's a JEE question also. So Kf is 10 is power 3 and Kb is 10 is power 2. So this is 10. So K you have calculated as Kf upon Kb. Now, standard Gibbs energy change, which is delta G naught for a reaction at this particular temperature, is something like this. Okay, now K, again I have to, there we have committed unnecessary calculation, but here it will be used directly. K it is given, so delta G naught will be equal to minus 2.303 R T, because ln, now 2.303 you can take 2.3 because log 10 is 1. So that calculation you will do, and in kilojoule you will get your answer. Okay, that now see, these are also questions which are easy to calculate also. Now committing a frame that no, thermodynamics is a backlog. That's why do not leave any question. Attempt, if taking time, leave it, but at least know everything. That's why I've taken all the questions with the varieties also, that some question will require calculation and the same type of question will not require calculation. That's why you were getting some answers like 6. That means approximation can be done in those questions. No. Now, next question says 40% of HI undergoes decomposition. Okay, so I have this HI, it is getting decomposed to form H2 and I2. Now, one thing I'm telling you, whenever alpha is given, student make this mistake a lot of time. Whenever alpha is given, okay, Sonali and Vinod are giving answer that it is 5.727, that's why it is 6. So that means it is also calculative. Okay guys, so now Whenever alpha is given, make sure you try to take this thing as 1. Why? Because what is alpha? Moles dissociated upon moles taken initially. So if you do it with respect to 1, in general, you do not commit a mistake of stoichiometry. So it's just an advice you can do by taking any stoichiometry. You will see in most of the cases, you may land up with a multiplied by 2 or divided by 2 answer. So in order to remove all those errors, what I'm telling you is, whenever you are given alpha for a particular reaction, take the concentration, take the stoichiometry as 1. For example, if this is 1, initially nothing is produced, and in order to balance, introduce a coefficient in the product side, as in 1 minus whatever alpha of 1 is what? The same thing as in 0.4. 40% is 0.4. So 1 will be dissociated and will be producing half. So 0.4 will be dissociated and producing half of 0.4 as in 0.2. So this will also be 0.2. So this will clearly, because these are the, let's say this is the concentration now. Delta G naught for the decomposition of the reaction 1 atm pressure is now. Sir, K we have calculated. How? Sir, K is simple. K, because I'm taking 1 is the concentration. Because K does not depend upon concentration. So whatever initial concentration you take, K is independent of it. So that's why I've taken 1. Now, it will be simply 0.2 under root 2, 0.2 under root 2. So this is 0.2 raised to the power 1, because root 2 is 1. Upon this is 0.6. So in easily you get K is 1 by 3. So once K is 1 by 3, now it is again that same formula which we have done in that question. Delta G naught will be equal to minus 2.303 R T, I guess it's given. T is given into log of this K. K is 1 by 3. See, log 3 value they are also giving. But this will also be calculated because it is, they are giving till 3 place of decimal. But logic, I guess you know. This I've mentioned separately also, so these notes will help you also, that whenever alpha is given, it is moles dissociated upon moles taken initially, to do not commit that stoichiometry error by taking it as 1. Answer will be 2735. I guess I was seeing that answer from some of you. 2799 2343. Vinod, lekin commendable bhai, you are trying perfect. Answer will come, will not come. This is into divide, this is just practice. But practicing is what giving 100%. So if we give 100%, nature also reciprocates gradually. Moving forward. Now, the variation of equilibrium constant. Okay, a very famous topic, which is Van 't Hoff equation. I'm directly jumping to the topic. Van 't Hoff equation. What is Van 't Hoff equation? Sir, K does not depend upon concentration, yes, but K depends upon temperature. K depends upon type of reaction. If you, sir, my calculation, Vinod, it is not issue. You can, it is, nothing is an issue. Practice is required, my friend. Working hard is not an issue. It's a practice. So gradually everything will come. So about 21, 3-4 days is also a gradual for a decent engineer. If you are going to crack JEE, then 3-4 days work is a lot for you. So keep practicing. Gradually it will come within. How many of you know how to swim? I learned swimming when I was like, I mean, quite mature. I mean, in 2013-14. If you learn swimming, let's say in 40 days, can you say on 20th day I learned 50% of it? No. There's a feeling of buoyant force. It may come in the 39th day. So if you stopped at 38th day, the level of swimming, you know, is still 0. Because, you know, it's a feeling. There's a point of time when you curl your body, do like this, then buoyant force, you just feel the force. Oh, arey, there's no, exactly every work is like that. You just have to keep working. The time when it will become field, it will be felt by you, is you cannot predict it. Keep working, gradually everything happens. But keep working without actually having the idea of getting a thing. You be disciplined with your work. Do not expect I am giving 8 hours today, I will be getting that much without before starting. That is our job. We will set your targets. You just have to move and follow the path like a horse. Moving forward. Now, temperature changes, equilibrium constant change. How? Van 't Hoff has quantified and said d by dt of ln k is nothing but it is equal to delta h upon RT square. A very famous relationship. Please do remember this. Now, how to find the relationship of different temperatures? I am just giving you this relation. Learn this, and obviously in a few time you can, in a few second, few line you can derive it further. Now, so d of ln k delta h upon RT square dot dt. So I guess it is quite clear to you. Let us integrate it from temperature T1 to T2. So let's say at temperature T1 equilibrium constant is K1, at T2 it is K2. What is integration of dx? X, so it is ln k, upper limit minus lower limit, so ln of K2 minus ln of K1, so ln of K2 upon K1. Delta h, considering it is constant, so it will come out of integration. R coming out of integration, so delta h upon R. Okay, it is t square, I'm sorry. So what is integration? 1 upon t square dt, as in x raised to the power minus 2. So a minus sign will be coming over here and it will become 1 by t. So upper limit 1 by t2 minus 1 by t1. Obviously this will go inside, so it will become 1 upon t1 minus 1 upon t2. Now, two different temperatures, equilibrium constants are K2 and K1. In the previous question, the exact values are given to you. You have to, it is very calculative, but you should know this because graphs question are also asked by JEE in some of the session. So learn this Van 't Hoff equation which quantifies equilibrium constant K change with temperature. And for this question, answer will be A, which is very calculative, but you should know this. Moving forward. Now, let us attempt this question. Again, a theoretical question and a crime to leave this piece of cake. Why? Because any salt, all ionic salt are soluble in water? No. Only those salts are soluble in water where released energy as in hydration energy is more than the amount of energy required to break the lattice, as in lattice enthalpy. So very famous and a very common practice of Hess law, which says if I have a solid, that solid ionic salt will be soluble in water and the enthalpy change will be enthalpy of solution. It is equal to enthalpy of lattice plus enthalpy of hydration. So whenever I am soluble, this value will be negative. When it will be negative? When delta H hydration, which is always negative, is larger in magnitude, while delta H lattice, which is the amount of energy required to break this 1 mole of solid into constant gaseous ions, it is the endothermic process. So obviously energy can't be created, can't be destroyed. So by Hess law, this enthalpy change is equal to this plus this, and obviously with simple plus minus you get answer is C. Moving forward, a very important logic. Now next, student attempt this question and student gets stuck in entropy questions. Perfect. Ayush perfect, Akshay perfect, Vinod perfect. Now two blocks. Okay sir, student get confused with entropy question. Basic entropy definition is entropy is equal to Q reversible upon the constant temperature. Why constant temperature? Because you have to supply heat so slowly, so reversibly that temperature should not rise. Now this is the theoretical definition, but I'm not saying to remember the derivation, but at least remember one formula, this formula. Just remember this. What if something is not given, that simple Q reversible upon T? Just don't do the derivation for JEE Mains, but just remember this formula. Delta S is equal to N CV ln T2 by T1 plus N R ln V2 by V1. If it is constant pressure, if it is constant volume, if it is constant pressure, then this same things become ncp ln t2 by t1 plus nr ln v2 by v1. Just remember this formula. Whatever case you are supplied with, you can import the data in this form. So at least learn this formula. This is the slide from my GOC of ionic equilibrium. I've intentionally taken it, those who want to learn all, but at least all should know this formula. Now, why, sir? Because question is saying us that there are two blocks, different temperature T1, T2. They are attaining thermal equilibrium. So thermal equilibrium, heat lost by one will be heat gained by the other. So heat lost by one will be heat gained by other. Now, because I'm losing heat, and what is the situation I'm losing? Sir, at constant pressure, both blocks are kept at constant pressure. So heat lost as in QP. So QP is equal to what, sir? Heat capacity of the question. In the question is saying heat capacity is CP. Options are given also. So let's say heat capacity at constant pressure, and it is saying that both blocks are of same mass and same material. So heat capacity will be same. So heat lost will be, because I'm losing, so heat lost will be minus. So minus heat capacity into difference of temperature. What is the final temperature? Let's say they both will attain a same temperature. Let's say that temperature is T. So T final minus initial is equal to heat gain as in positive. So it will be plus. So plus Cp. What is the final temperature? So final is still T upon what is initial. For the other block, it is given it is it is at a temperature T2. I do not know which one is larger. One will be larger. Whoever will be larger will give. Whoever will be lesser will take. Both will attain a final temperature of T. And obviously you can see that final temperature is nothing but average of, you can obviously check, it is average of T1 and T2. Now we know that formula of heat capacity. So what will be total heat capacity? Heat capacity, I'm sorry, entropy change. You are asked total entropy change. So entropy change of block 1 plus entropy change of block 2. Sir, but entropy change, there is no Q reversible. That's why ncp ln t2 by t1 plus nr ln v2 by v1. Sir, here temperature is changing, volume is obviously same. So it is nothing but n moles are not considered because Cp is specific and values are also taken. So if you see options also, there is no mention of moles over here. See, no mention of moles. So just take heat capacity. So it is Cp ln. Now what is T2? We say T2 as in final temperature. So final temperature is T1 plus T2 by 2, and initial temperature for block 1 is T1. Okay, sir. Plus Cp ln. Final temperature for second block is also the average upon initial temperature for this one is T2. So I guess this is quite clear. Cp will come out to be common. ln A plus ln B is ln of A into B. So T1 T2 gets squared upon 4 T1 T2. So answer will be option A. Somebody got answer? So how much marks can I score? Okay, this is 114. So try to do this question. I'm saving this for you because when my panel gets question more than 100, it hangs for a while. So this was, I have 4 folders like this. So one is done, 3 are more. The last one is very small. Anyway, we have to complete this. So let's go to, this is the live 2. So obviously we are finished with thermodynamics also. Congratulations. And a reminder, for all the chapters and practice sheet, scan this QR code, join our WhatsApp channel to stay more updated. Moving forward, let's attempt the question from ionic equilibrium. You guys attempt. By the time I read some comments, sir, my calculation issue. C. Okay. See, England Test cricket. You will see Why you have written your name as Test Cricket? Why not 10 over or 2020? Because actually class takes time. So if you are over expecting, then this video is, do not over expect. But if whatever your marks is at this point of time, let's say you are getting 100 marks. If not doing this, you were getting 100 marks. With this, I can assure your marks will be multiplied to like 20, 30, 40% more. If you just abide by the principle that you will be selecting doable questions. I have taken good questions in order to at least discuss the concept, because using the same concept, easy question can also come. But in a frame of 40-50 seconds, we get an idea. I'm again and again repeating it, that it will take time. So leave, move ahead, so that you will not miss easy and doable questions moving forward. Now, the pH of 10 to the power minus 2 molar energy solution is okay. Kw is given. I guess somebody has got the answer D. Let's check. D as in 9.6. Let's check. It is. See, for water, equilibrium never changes. So for ionic equilibrium also, equilibrium never changes. For water, it gives H plus and OH minus ion. So for water, we know Kw is equal to concentration of H plus ion given by water and OH minus. You add any acid, any base in water, K of water will not change. Take the P, I mean minus log. So pKw will be equal to pH plus pOH. And at 25 degrees Celsius, we know equilibrium constant value is 10 to the power minus 14 for water. So pKw becomes 14, and pH and pH both are 7. That we know at 25 degrees Celsius, and question plays with it. Question has changed the temperature. So if I have increased the temperature, dissociation of water must have got increased, and therefore Ka value would have got increased, because it will be 10 to the power. Initially it was at 25 degrees Celsius, it is 10 to the power minus 14. Minus 13.6 is a larger value, so K is increasing. Okay, but question is not asking increasing or not increasing. It is asking you pH. So sir, it is 13.6. So divide 13.6 by 2, because pKw will now be equal to 13.6, and it will be equal to pH plus pOH. For the solution of a base, you are giving, so minus of log of this 10 to the power minus 4, because OH minus ion concentration by MOH will be 10 to the power minus 4. So minus of log of 10 to the power minus 4 is plus 4. So this will be plus 4, and this you can solve. So 13, it will be somewhere around 9.6. I guess whoever is saying D, perfect, is right. Moving forward, attempt this one. Perfect. Perfect, Ayush. Perfect, Ayush. Music ethic. Sir, my calculation issue. Sir, what chapter is next? After ionic. After ionic, we'll be moving to GOC. After ionic, it will be organic, GOC. Now, hydrogen ion concentration H plus changes by a factor of 1000. Okay, so let's say initially it is H plus, so it will be minus of log of H plus. Now H plus ion changes by a factor of, so let's say pH nu is equal to minus of log of H plus, but H plus question is saying it is getting increased by a factor as in 10 to the power 3 times of H plus. So log of A into B is log of A plus log of B. So this will be minus 3, minus of log of H plus is again the previous pH. So this new pH will be equal to previous subtracted by 3. So answer will be decreases by 2. Moving forward, attempt this one. Perfect, perfect, England. England cricket, perfect. Acha, first, okay. Moving forward, I guess this is also a simple application. You must have got the answer. If you add two reactions, equilibrium constant get multiplied. If you subtract two reaction, equilibrium constant gets divided. So because this reaction I am attaining by adding the above two reactions, so equilibrium constant for this reaction, let's say, is K3, so it will be K1 into K2. So it will be just simply option Delhi. Moving forward, let us attempt this question. No one gave answer for the previous one. Delhi, Ayush. Okay. 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 Thank you. But love yourself more. Do questions very religiously. Chalo. Next question. 0.01 moles of weak acid is dissolved in 1 liter of 0.1 mole HCl solution. Okay. Now this is just a question of common ion effect. Again, a very common and very famous logic. So I have a weak acid HA. Weak acid anyway dissociate very partially to constituent ions. Agreed. Value of K is given 2 into 10 to the power minus 6. Okay. Now, if it is dissolved in 1 liter of 0.1, so what is the moles I am using? Okay, 0.1 only, because 0 molarity into volume. So I am creating 0.1 moles of HCl, but from what? From a strong acid. So sir, when we take this HCl, because it's a strong acid, it will completely dissolve. Yes, it will completely dissociate and form H plus and Cl minus. And now again apply Le-Chatelier's principle, because H plus from the strong electrolyte is of so much magnitude, concentration, product concentration for this will increase and equilibrium will be further suppressed. So it was a weak electrolyte, but now its concentration will be much lesser. But what will not change? Value of K. This K will remain as it is, as in 2 into 10 to the power minus 6 will never change. It will be equal to concentration of this plus this. Now because we know it is negligible, so if it is 100 rupees and it is 1 paisa, so you can add 1 paisa? No. So actually we calculate H plus ion simultaneously from this particular guy only. So H plus ion concentration of this particular guy is 0.1, as in 10 to the power minus 1. Although its dissociation will be very less, let's say it is X. So this X is not added in front of this, but this X can be easily calculated from this side. And what is concentration of HA? Because it is not at all getting dissociated, so whatever concentration we have taken, we'll take that concentration in the denominator, which is 10 to the power minus 2 moles. That's it, it's solved. So this is minus 1. So here denominator is having minus 1. So this becomes minus X becomes minus 1, na? 2 into 10 raised to the power minus 7, I guess. It is saying minus, so answer will be 200. Let's check. Okay, I'm sorry. Where it is? It is 2. We have done some 0 mistake or what? It is asking us 2 and raised to the power minus 5. So, okay, moles. That is also moles. 1 into 0.1. This is 10 raised to the power minus 1 of that guy. And this is 10 raised to the power minus 2 of weak acid. 2. Sir, but I got wrong only because of calculation. Calculations you sometime miss, my friends. Like, I guess I am also missing something over here. HA, it is creating H plus and Cl. Let us do it. So its moles is 10 to the power minus 2. So this is 10 to the power minus 2, negligibly forming. So minus X, this is X. This X is very, very negligible. H plus given by strong acid is how much? It is 10 to the power minus 1. So Ka is equal to H plus, which is 10 to the power minus 1 into X upon 10 raised to the power minus 2. And we have to calculate what? The degree of, okay, we have to calculate degree of dissociation. Nahi, you wrote in reverse. Nahi, What is degree of dissociation? Alpha. What is alpha? Moles dissociated is x upon moles taken initially. So how much moles I have taken initially? 10 to the power minus 2. So what is x actually? X we have found from here. X is 2 into 10 raised to the power minus 7. So 2 into 10 raised to the power minus 7 upon moles taken initially is 10 to the power minus 2. Once it is gone, then it is 10 to the power minus 5. So actually we were trying to give value of x. Question is asking value of alpha. Or else you can say that also, that it is asking degree of dissociation. So whatever x is, I mean, if you are taking, if you're not considering that percent, so actually, because what is that mathematical, because we are taking moles, so what is the mathematical definition of alpha? Moles taken initially, moles dissociated upon moles taken initially. Else whatever x you have calculated, because you are supposed to calculate the percentage, to multiply, for calculating percentage you multiply by 100. So anyway you decrease those 10 to the power minus 7 to 10 to the power minus 5, because after multiplying 100 also minus 7 becomes minus 5. So your answer will be just 2. Perfect. But we missed this, so make note of this, that alpha is moles dissociated upon moles taken initially. I did with alpha under root. Okay. So Ayush, you got your answer. You did alpha equal to under root Kc. That is the simple basic formula which you can apply. Perfect. Perfect. That can also be done. Perfect. Now, let us do this question. Which of the following compound cannot act as Lewis base? Now, what is Lewis base, sir? Which has lone pair. If I have lone pair, I'll donate those lone pair. So this guy has lone pair. This guy no lone pair. This guy, yes, sulfur has lone pair. Chlorine, yes, lone pair. So obviously, because this guy do not have lone pair, so answer will be, this is a basic. Why taking this question over here, sir? Because acids and bases, Lewis acids and Lewis bases are ionic concepts also. Now these questions will be crime to leave such questions. What is conjugate base? Bronsted and Laurie said, if I give H plus, my conjugate part will be a base. If I'm a base, my conjugate part will be an acid. So remove H plus, it will be HPO4 with 2 minus. So answer will be Bombay. Moving forward, attempt this one. Now such questions you also get. Now pK of weak acid and pKb of weak base. Okay, so acid is also weak, base is also weak. And what does weak acid, weak base? So it is weak acid, weak base are forming a salt. So if you have a salt, then what is the formula for hydrolysis of salt? I'm not deriving it. I'm just giving you a trick to remember. If salt is acidic, so it is 7 minus. If it is basic, so 7 plus. If it is both of them are weak, then value of K will decide. So it will be 7 plus half of pKa minus pKb. You have to remember this formula, and I guess you can clearly see this is 0.2. So minus 0.2 divided by minus 0.1. So answer will be less than 7. So minus 0.1 as in 6.9 is your answer. Moving forward. Next question. Vinod said 3. Okay, I guess you must be giving answer 3 for the previous question, but no worries. Moving forward, let us attempt this one. A liter of buffer solution contains 0.1 mole each of ammonia and ammonium chloride. Okay, so it is a buffer, 1 liter buffer. You have ammonia and you have ammonium chloride. 0.1 of both of them on addition of 0.2 mole of HCl. Now, what is a buffer? Buffer, if you add strong acid, if you add strong base, pH, it resists change in pH. Why? Because it has buffer action. So let us see that buffer action. If I add HCl, now ammonia will be interacting with water, but because it's a weak base, it will try to form NH4 plus and OH minus to a very small extent. Perfect, sir. So this reaction will not at all move forward. Moreover, when NH4Cl, which is a salt which completely dissociate to forms the constituent cation. So this will be completely gone and will be producing 0.1 mole of ammonium ion. Looking at this common ion, the weak base will not at all dissociate, so its dissociation will further be suppressed. So 0.1 of ammonia will remain as it is. This will remain as it is. Now, what are we doing? We are adding HCl. HCl will do what? Sir, H plus will be taken by OH minus and will form water. But sir, H plus has entered, but it is not allowed to be there because H plus is neutralized by OH minus. And why this OH minus is available? Because whole of the ammonia is holding over here. As soon as one H plus comes, it will take that H plus, OH minus will take that H plus and forms water. So pH change is resisted. Till what time it will take place? Till whole of the base is completely finished. That's why we say you add small amount of weak acid or weak base, pH will not, but small amount. The amount that you add should be lesser than this. Now, how much we are adding? 0.2. So 0.2 of this will get decomposed. 0.02. So how much is left? 0.08. Now, because this guy has decomposed, OH minus has taken H plus, but ammonium ion is now extra created. How much? 0.02, because this much is gone, so that much will be created. So its concentration will be increased by 0.02. A very beautiful thing, a very common basic we should know. Now again, but still this is a buffer, because buffer is weak base in presence of its salt with a strong acid. So still it's a buffer. And for buffer solution, formula of pH is, pH of a buffer is pK of the weaker part, which is the base. So pKb is given 4 point plus log of the ion, the salt part, which is now 0.12 upon base, which is, so this is nothing but 12 by 8. So that is 3 by 2. Log 3, okay. Log 3 and log 2, they are also giving. So you have to do calculations. And you have to do calculation. Your answer will be 9079. You have to, I've given you the data. Log values are also given. So religiously do it and you will get your answer. Moving forward to the next question. Attempt this one. Sir, reply please. Sir, this is my first attempt. What should I do now if I'm 0 for 5 days for NIT? Beta, perfect. What you are doing right now is the perfect thing that you can do. Don't, whatever questions we are discussing, just learn those, attempt those questions and keep revising them. Physics we have done yesterday, chemistry we are doing today, maths we'll be doing tomorrow. Keep revising them in the coming days. If you feel for some chapters you need some special attention, then you have to invest. But for the 4 days, I'm saying just keep revising these chapters, because you will be seeing number of formulas through the question, through the exact question of JEE. That is the most famous practice that you can have. Specified practice can only be done by those students who are lying specifically short in that particular area, who are already there at 170, 180. Like Sonali was saying, sir, by my, so for them, for practice, but for the special attention, they have to give those to those weaker or lesser known concepts to them. So for those students, their practice has to be quite segregated. But for, if you're starting at 0 and you just have 5 days, practice and see all possible questions, the probable questions, which you are definitely doing. So I guess we got our answer. We know this thing. Okay, now there are salt, but some salt are sparingly soluble, like these salts. And for these sparingly soluble salt, what is mentioned? Their solubility constant. So let's say this salt is, for the case of simplicity, cation zirconium I'm mentioning as A, and phosphate I'm mentioning as B. So this is A3 B4. So it will dissociate add as this plus 4 cation 3 these minus 3 phosphate anions, this is a number. Now because it's a sparingly soluble salt, so when 1 mole of this will dissociate, 3 and 4 will be formed. But because it is sparingly, very less will be, but it will have some solubility. Let's say that some solubility is S. So if S is dissociating, 3S will be produced and 4S will be produced. Equilibrium constant Ksp is equal to concentration of this, as in 3s cube into 4s raised to the power 4. That's it. So you solve this. So this will be s raised to the power 7. So either this and this will be, and I guess you solve it and you will get your answer. 2, Vinod and Ayush are saying. So definitely that multiplication, definitely answer is 2. Moving forward to the next question. Solubility questions are very famous. Those logic you should know. Now, what spice we are adding, what tadka we are adding, what tadka JEE adds. We have a sparingly soluble salt, barium sulfate. Its solubility is very less. We know, sir. We have seen that. Now, solubility of barium sulfate in 0.1. Now, I am using K2SO4, which is creating a common ion. So I was a salt, not at all guessing. The same question which we have done, where we have the 10 is for minus 2 factor, where alpha was asked. The same question is this, the same common ion effect. So let us apply that common ion effect. Now, so barium sulfate dissociates as Ba plus 2 and sulfate, although its solubility is very less. But due to this common ion, its Ksp is given, so its solubility will be Ksp is equal to, this is Ksp, so S squared, but that solubility is in pure water. Now, in presence of this common ion, what is the common ion? Sulfate. What common ion will be produced? SO4 2 minus. How much? If 1 mole you will take, then 1 sulfate will be formed. So how much mole I am taking? 0.1, so 0.1. But because of this high amount of common ion, its solubility is further reduced. Let's say the new solubility is S. So this is small, very small. But what will not change? K will not change. What is K? K is 10 to the power minus 10. So this K will not change. It is equal to concentration of this, which is very small value, but that is S. This is very small value plus 0.1. So 0.1 will neglect that very small value. So it will just 0.1. That means 10 to the power minus 1. So now this is, over there it was asking alpha. Now it is simply asking S. So answer is 10 to the power minus 9. That means here integer. Okay. Unit is gram, my friends. Playing with unit. It will be S moles per liter. But it is not moles per liter. It is gram. So this is 1 gram. This is 1 mole per liter. So what is 1 mole? Molar mass of the compound. So that n gram is the mass of 1 mole, because it is 1 mole. This is 1 mole per liter, because S will be 1 into 10 to the power minus 9 moles per liter. So obviously you have to, okay, barium sulfate molecular form. So this is 233. So the multiplier will directly be 233. Perfect. A good question. Moving forward, let us attempt this one. Good guys, good. Very good, in fact. Perfect, guys. Let us attempt this one now. The question says the density of monobasic acid. It's an acid which gives just 1 H plus. So the density of monobasic acid, as in MOH, whose mass is given as 24.2, is this much, 1.21. The volume of the solution required to completely, okay, I guess from here I have started redox. Ayush was asking after mole, after NCRT part 1 Ayush, then NCRT part 2 first is redox. So I've taken redox also. So these redox questions have started. The volume of its required for complete neutralization of, now I am having this base. It is saying volume of its solution required for complete neutralization of itta molar is this much. It is giving, okay, is dash into 10. The question is having a misprint. It is dash into 10 to the power minus 2. So you have to tell the volume. So what does redox tell you? Sir, for acid base also, for oxidizing and reducing agent also, what we do, number of gram equivalents are always equal. Why? Because number of moles can only be equated once we know the perfect stoichiometry. For that we have to balance the reactions. The balancing of the reaction in case of redox reaction is a big task. So law of equivalence help us to say that number of moles can be equated using moles of reaction, but number of gram equivalents are always equal. And number of gram equivalent of any reactant is always equal to number of gram equivalent of the another reactant. It is always equal to number of gram equivalent of product produced. And number of gram equivalent has formulas: normality into volume, weight upon equivalent weight, and number of moles into valency factor. Some basic formulas which you should know for law of equivalence. Now, once we know this, which I've iterated, now I have a base. What is the base? NaOH. So number of gram, I'm not writing the reaction, although for acid base you can easily write, but introducing law of equivalence, which says number of gram equivalent of acid will be equal to number of gram equivalent of base. Now for base, what is given? Molarity and volume. So what formula you should use? Molarity into volume into valency factor. So for base, molarity is 0.24, volume is 25, it is ml, so it should be in liter, into valency factor, because what is valency factor for a base? Number of OH minus ion given, NaOH gives 1 OH, so it is 1. Now monobasic acid, okay, it's for acid. Now number of, how we will find number of gram equivalent? Sir, number of gram equivalent of acid, the density is given, density of acid is given, okay, its molar mass is given, density is given, molar mass is given. So what can we again go to concentration term? I guess some of you must be remembering that. If not, I'm helping you with it. What I'm trying to tell you is that you can also relate molarity with mass percent into density of solution into 10 upon molar mass of solute. Why? Because here density of solution is given out to be 1.21. It is gram per liter or kg per liter or gram per ml, both are same. So let's say I'm taking in gram per ml, so that one into 10 into percentage. Now percentage is weight of solute upon molar mass of solute into weight of solution. I can take weight of solution, because if I have a weight of solution is 1 liter, weight of if it is okay, density of solution is given. Rather what we can do is molarity we calculate as, rather instead of that formula, that will also, because here percentage is not directly given, so rather instead of this you can do simple molarity definition only. Molarity is equal to number of moles of solute upon volume of solution. Now let's say I take volume of solution as 1 liter, because this solution, if I take 1 liter, I know weight. So let's say volume of solution of this solution, I take 1 liter of the solution. So 1 liter of solution will have number of moles equal to molarity. Now it is giving us density. So 1 liter solution will weigh how much? 1.21. So weight of solution will be 1.21 kg, as in weight of solution will be 1210 gram. Now I know weight of solution. What is this solution? This solution is of this acid. So I know weight of this solution, weight of this acid. So if weight of this acid is this much, then can you find number of moles? Yes sir. Weight upon molar mass, its molar mass is also given, 24.2. Now this is a tricky part, because generally while seeing density people relate with molarity. So this is a bit tricky part, because this is this strong acid solution. So I'm considering whatever weight it is having is having of the strong acid only, because there is no other property quantity given. So this will give me number of moles. But sir, I have to find number of gram equivalent, number of moles into valency factor. Now valency factor of this monobasic acid, it is saying it is monobasic, that means it can give only 1 H plus, valency factor will be 1. So that direct thing you can take over here. So this is 1210 upon 24.2 into 1. Now this is moles. So moles into valency factor. But sir, we have to find volume. So this is the moles you are adding. How much volume you need out of it? This is the moles of acid. Now, do I need the complete volume? No, sir. This is the moles which are provided to us. How much moles I will take? That moles will be decided by, this is the moles of the, let's say you have a bottle. Am I pouring the complete bottle? No, sir. I will pour a minimum amount of bottle. So, but I know what are the moles present in it. So this moles is present in 1 liter solution. So this moles upon 1 liter will give us the molarity. So molarity of the solution is this much. Into volume, how much you will take, that volume you can calculate in ml by dividing 1000, and this volume will then become in ml because valency vector is 1. What I'm saying is number of moles, this much number of moles is present in 1 liter. Are you pouring the complete 1 liter? No. You are taking a portion of it. What portion? That VML you have to calculate. So a good question relating, basics. So with this calculation, I guess calculation is quite easy, doable. So with calculation, you will find answer to be 12. I'm skipping the calculation, but iterating the concept. Moving forward, let us attempt this question, a question relating to indicators. Let us attempt this question. सर ऐसे और हो सेशंस और होंगे बेटा. You are having mains on 21st. Tomorrow you will be having maths, by the way. So obviously you will be having maths. So tomorrow you will be having a session, no doubt. Attempt this one. C. Perfect, Ayush. Let's check. Perfect, Ayush. Phenolphthalein. Now, why I have taken this question? Because indicators are also loved by JEE. So I am giving you some details regarding indicators. That question, Ayush, very good. But I've deliberately taken that question because I need to give you some details regarding it. What are the details? Detail number 1. Phenolphthalein is actually a weak acid. I'll be repeating it once. Phenolphthalein is actually a weak acid. Structure you can forget. Phenol type of thing. So phenolphthalein. Just like phenol type of thing, it is also a weak acid giving H+. Phenolphthalein, when associated, is a colorless compound, and once it gets ionized, color changes to pink. So pink color is because of the ions that phenolphthalein creates. Now, you tell me, if you make the medium basic, let's say increase OH minus ion concentration, OH minus ion will take this H+, and once concentration of product will decrease, reaction will proceed in forward direction. So pink color is due to ionized form. That is the answer to this question. This question is done, but I'm giving you more information. So answer is C. This is done. Its pH range is 8 to 10. Learn this. If solution has a pH less than 8, it is colorless. If it is more than 10, it is pink. Another indicator is methyl orange. Methyl orange is actually a weak base, so it creates OH minus ion but very less. Color of methyl orange is yellow, not orange. Color of methyl orange associated form is yellow, not orange, like this. Structure you can skip, but when it forms ions, it forms ion because of formation of this quinoid. Has been asked 2 times by JEE. So this is the quinoid. Do not learn the structure but name quinoid. And because it's a weak base, so it proceeds forward when, sir, if you increase acidic, if you give H+, sir, H+ will take away this OH minus ion, reaction will proceed in forward direction. So introducing H+ will bring the reaction forward, and introducing OH minus ion will shift the reaction backward. So the color changes happens at the point of equivalence. What is the equivalence range? 3 to 4.5. Before 3 it is red, after 4.5 it is yellow. These are the facts which, if possible, you should write at a point at some side and keep note of it. A famous point. Moving to next question now, because as I promised, I'm trying to revise chapter also using questions. Now, next question, please attempt. I guess you have got the logic behind this question. This is also law of equivalence that we were discussing. Initially we have done for acid base, now doing for redox reaction. So for KMnO4, number of gram equivalent is molarity into, okay, the volume of KMnO4 we have to determine. So this volume is in ml. So if this is ml, that one will also be in ml. It is also given ml. So let us keep it in ml only. Do not know 1000. Now this is a redox knowledge. You should know this. MnO4 minus in acidic medium changes to Mn plus 2, and it generally behaves as with ferrous iron. It reacts in acidic medium only now, because it is saying Mohr salt. So Mohr salt is ferrous sulfate dot ammonium sulfate dot 6H2. So that sulfate when goes to water as an H2SO4 type. I mean, it is not specifically mentioned, but because nothing is mentioned, so we are, because of presence of sulfate, we are taking it as, because Mohr salt generally undergoes oxidation in acidic medium only. So in acidic medium, KMnO4 changes to Mn plus 2. So valency factor becomes 5. So this becomes number of gram equivalent for KMnO4. What about ferrous? Sir, Mohr salt, only ferrous iron gets oxidized to Fe, from Fe plus 2 to Fe plus 3. So valency factor is 1. So volume is 20, molarity is 0.05 into 1. So this is a very simple law of equivalence question. If you solve it, you will get your answer to be 30 ml moving forward. Now, again, now our redox, while doing redox you should know some inorganic. Vinod, perfect Ayush. While doing redox you should remember one thing. For some compounds you need to know the structures also. Sir, can you tell this is a JEE question. So some compounds I am giving you structures also. Why? Because I want you to understand how to calculate oxidation state using the structures. So first you need to know the structures through chemical bonding and through knowledge, through facts. Now, actually this polythionic acid in nature are of basically two types. The value of X ranges from 3 to 5. There are two types. It is trithionic acid with formula H2S3O6. Tetrathionic acid also exists in nature with formula H2S4O6. I am audible, right? Because I have, I guess I have reduced the amplitude. I'm audible. At least one thumbs up or okay. This much voice is clear, is loud to you, or should I bring my mic closer to? Yes, okay, thank you. Now, these are the two types of polythionic acid that are present in nature. Okay. Obviously, this structure, how you can predict, sir, this is S3, so S will come in between. I told you, make structure symmetrical. So making structure symmetrical, because there is two hydrogens, one OH here, one OH here. That one is having H2S4O6 with this structure. Now let me help you to identify, when you know the structure, how to calculate oxidation state. Go to the electronegativity. Sulfur oxygen having two bonds. Who's more electronegative? Oxygen. So this is -2, this is +2. So +2 from this oxygen. Similarly, +2 from upside. Similarly, +1 from downside, because there is only one bond. One bond, one contribution. Sulfur. If two atoms are of same electronegativity, do one attracts and one withdraws? No. So here contribution will be 0. So can you calculate total partial oxidation state? +2, +2, +1. So this sulfur is in +5 state. This guy is also in +5, and this guy is in 0. What about this one? Similarly, +2, +2, +1. So this is +5. This is also +5. This is 0. This is 0. So your answer, what are the possibilities? 0 and +5. A very basic but a very important question moving forward. Now, let us try this one. Delhi, AIMS Delhi aspirant. Okay, perfect. Perfect. We are joined with some new students. Whoever has joined, beta, please take out your pen and copy. Attempt, and if at all I'm moving, till now I have maintained a slowy pace. So, but if at all I'm moving aside, take out your pen and copy and keep attempting. Okay, Ayush, answer is C. Okay, now this is also P block logic, so I'm giving you directly, but absolutely answer is correct. The reason I'm giving you this is because P block has been removed, but still JEE loves it. So H4P2O7 is pyrophosphoric acid. H4P2O5 is pyrophosphorus acid and H4P2O6 is hypophosphoric acid. Very famous formulas. And if you, I just draw for one, for let's say I'm drawing for this one. Okay, I draw for this one. Phosphorus, double bond O. Now, phosphorus, double bond O. Now, why I'm doing like this? Because I have two phosphorus. For oxo acid, you need a double bond O. So, how many oxygen gone? So, out of 5, 2 gone. So, how many are left? 3. So, I told you make structure symmetrical. So, 1 OH. Okay. Then phosphorus can form 5 bonds. Now, so I can form, because I have to satisfy hydrogen also. So, 1, 1. So, this is OH. This is OH. Phosphorus has how many electrons in its valence shell? 5. So, in order to make it symmetrical, you can, obviously through NCERT, if you know, good, you can predict also, is what I'm trying to do. So, one oxygen will make it perfectly not symmetrical. So, this is OR, and how many hydrogen it has? So, H and H. So, this is all the structure which is making it symmetrical. Now, in this case, what is its oxidation state? +2 from this side, +1 from this side. From here it is -1, because phosphorus hydrogen, this is reducing hydrogen. Phosphorus is electronegative, so -1 and +1. So these two are gone, so this is +3. So if this is +3, this is also +3. So in the middle one, you have oxidation state of 3. So just by making that structure, you can easily, I'm not, for the options also, it is not even required. So option is 3. Moving forward, let's try this one. Now, 4 gram mixture of NaOH, sodium carbonate and some impurity was first titrated with, okay. Now, why I have given you phenolphthalein and methyl orange? Because JEE loves it. I mean, it is a good question. Sir, I use X method because it was not a complex structure. Can do. But sometimes they also ask number of reducing hydrogens. So for that you need to know the structures. So there is a topic in NCERT also, partial, fractional and paradox of oxidation number. So that's why I've intentionally diverted you to calculate oxidation state using structures. Moving forward. Now, phenolphthalein and methyl orange. Sir, phenolphthalein changes color. When? Sir, when pH reaches around, even if neutral solution has taken place, phenolphthalein will change color because its range is 8 to 10. So actually, because phenolphthalein has a pH range 8 to 10, so it can't show complete neutralization of what? Of base. Like if I'm a base, let's say I'm NaOH. When I will neutralize, when whole NaOH will be gone. So if one bit of NaOH is present, pH will be more than 7, approximately 8. So phenolphthalein will not change its color. If last NaOH is gone, phenolphthalein will change its color, become colorless. But what if I have sodium carbonate? Sodium carbonate forms, first it forms sodium bicarbonate, and sodium bicarbonate has a anion which is bicarbonate, so it has a tendency to give H plus also. So sodium bicarbonate, when it is formed, that is sodium carbonate is half reduced, is half neutralized. So that becomes an acidic solution where pH drops below 8 and phenolphthalein changes color. So phenolphthalein cannot show complete neutralization of sodium carbonate. Therefore, using the same logic, it is saying 0.4 gram of this and some impurity was first titrated with N/10 HCl using phenolphthalein. So when you used phenolphthalein, let's say, okay, see, I have made so that, because this is a good question, I mean a logic, a concept. Now, sodium NaOH and sodium bicarbonate, this is 0.4 gram. So let's say I have A moles of this and B moles of this. Perfect. So A moles of this will be completely neutralized by this much of HCl. So number of gram equivalent of HCl used will be equal to number of gram equivalent of these two. So number of gram equivalent of NaOH is equal to number of moles of NaOH into valency factor. What is valency factor of NaOH? 1. It gives 1. What is Na2CO3? It changes to although it is a salt. So for salt, formula is charge. But why I'm not saying charge? Because it reacts with HCl and will not turn into NaCl. It will first form sodium bicarbonate. And if you just write the reaction, this plus HCl gives NaHCO3. So the next structure will be, the next molecule will be H2CO3. Sir, this is balanced. So if it is 1, if it is also 1. So here valency factor is also 1. So my point is, number of moles of this into valency factor is number of gram equivalent of this plus number of gram equivalent of this guy is also B into 1, because only 1 mole is using. And these both of them are getting neutralized by how much gram equivalent of this guy? Sir, HCl molarity is given, volume is given. Because here I am taking moles, so I'll be putting that in liters, because moles, so I can't put in ml. So for that, normality into volume, but in liters, so I'll be dividing it by 1000. So this is a relation between A and B, equation 1. Now, question is saying that same solution further requires HCl. But how will you know it is requiring HCl? Because now we are using methyl orange. Methyl orange will show its complete neutralization. So methyl orange will help us and tell us how much more HCl is required, 1.5. But this 1.5 will neutralize what? Will neutralize only this. What is this? Sir, here it is B. So B moles of this will be produced. So this will be neutralizing this much moles. So if 1 mole of this is used, then 1 mole of HCl will be reacted. So B will be reacting with B. So what is moles of HCl used over here? B. So value of B is directly given because molarity is 1 by 10. Moles is B and volume is 1.5 in liter. So this is 1000. So directly I know B. By knowing B, I'll put the value over here. I'll get A. What we are asked in the question? Sir, we are asked, I guess, weight percent. A good question. Weight percent of sodium carbonate. Now, what is, sir, sodium carbonate is B. So B, okay, you do not have to solve this. Just solve this. Okay, we'll do this because this is quite doable. 1.5 into 10 raised to power minus 4 or 15 into 10 raised to power minus 5. This is moles. Now, for calculating weight, what you have to do? Sir, if that is moles, it will be multiplied by molar mass. Molar mass of sodium carbonate is 106. So that will be giving you weight. That weight will be in 10 raised to power minus 5 format. So make it in milligram, take 10 raised to power minus 3 away. So it will be 0.15 into molar mass, which is 106. That weight upon weight of mixture is 0.4. Divide into 100 will give you the percentage. A good question, a calculative question. And once you do that calculation, your answer will be approximately 4. I have iterated the complete concept. Moving forward. Hope it is clear. Moving forward to the next question. Very good, Akshay. Akshay is saying it is 4. Perfect, bhai. Perfect. Moving forward. Moving forward. Moving forward. Let us try this one. For the reaction this, the sum of total number of atoms in one molecule each of A, B, C. Okay. NaCl is reacting with K2Cr27 forming A. That A is reacting with NaOH forming B and some side products. That B is getting reacted with dilute H2SO4 and H2O2. Forming C and side product. The question is asking us sum of total number of atoms in one molecule. Sum of total number of atoms in one molecule of A, B. You have to take. Now this is a classic case of D block. I guess this is from here. This is a classic case of D block elements. Because it's a factual NCERT knowledge, so I'm giving you. NaCl reacts with K2Cr27, a strong oxidizing agent in acidic medium. A very famous salt analysis reagent, it forms chromyl chloride with formula CrO2Cl2, forming some byproducts also. When this chromyl chloride reacts with base, it forms sodium chromate, Na2CrO4. with some byproducts. This sodium chromate reacts with H2SO4 and in acidic medium it reacts with hydrogen peroxide to form this beautiful butterfly structure of chromium pentoxide CrO5. Now with some byproducts. So you are having one molecule of, you are asked number of atoms. So if we add number of atoms of this, this and this in each molecule, the total number of atoms will come out to be 18. The reason I am discussing this question because this is a D block famous fact you should remember. Moving forward, answer is 18. Now moving to the next question. Why taking that? Because it is also redox related, because every reaction was oxidation state of chromium, because chromium is an oxidizing agent, it oxidizes and therefore reduces itself. So a redox because a D block logic, but a known fact, so you should know that. Moving forward, now the very famous and probable question for redox reaction, now the last I'm discussing, is balancing of redox. Redox reaction can be balanced in acidic medium also, basic medium also. Let us finish the balancing quite quickly. Now, how to balance a redox reaction? Write the two half reactions separately. So first half reaction will be Fe plus 2 is converting to Fe plus 3. How? This is the first half. Except oxygen and hydrogen, what you have? Nothing. So directly balance charge. How? If I add one electron over here, plus 3 minus 1 become plus 2. So this is balanced. What about the other half? Other half is Cr2O7 2 minus is changing and forming Cr plus 3. Okay, sir. How to balance half reaction? Leaving oxygen and hydrogen, first balance all atoms. So leaving oxygen and hydrogen, what I have? Chromium. Chromium is Cr2O7. So in order to balance chromium, I have to multiply 2 first. Then for balancing oxygen, how many oxygen I have? 7. So I'll add 7 water over here. Now to balance hydrogen, add H plus. How many? 7 2 are 14. So this is 14 H plus. If medium is acidic, and because here medium is acidic, so done that. Now after balancing hydrogen, balance charge. How? By adding electrons. Minus 2 plus 12, that is minus 2 plus 14 as in plus 12. This is plus 6. So if I add 6 electron, it will also become equal. Now then equate the transfer. This is 1, this is 6. So I will multiply the first reaction by 6 and then add both of them. So once I add both of them, if it is getting simplified, simplify, and then you will get the coefficients, and directly these coefficients are asked in many questions. So, and then you have to report the value of this x plus y plus z. I've already done that question, done this for you. You just do it by yourself also. And I'm moving forward with the answer to confirm to the students, because somebody gave me answer. Only one Kerala. Acha, 23. Vinod, perfect. 23 is your answer. Moving forward. Now, if, so this question can be continued by organic, like Itard reaction. Nahi, point is it chromyl chloride, actually chromium complex Itard reaction, you from substituted benzene, you form aldehydes. So chromyl chloride you use there also, you form chromium complex, yes, but it was using so many chromium complexes. So that's why I referred D block to a larger extent. But yes, you are definitely right on that front also. Now you are given a reaction, okay sir, but now you have to balance in basic medium. What else? Sir, acidic medium, we know, do whatever you note in acid medium. For basic medium, just we'll modify one step. How? Let's see. First, write the two half reactions. Acid forming sulfide. Here there is no oxygen hydrogen, so just balance atom. How? 8 2 are 16, so 16 electron. Balanced. What is the other half? Sir, S8 is only changing to S2O3 2 minus, because sulfur is changing to this also. Sulfur disproportionation can also take place. I can oxidize also, I can reduce also. This is getting reduced. Let us see. Now, apart from oxygen and hydrogen, balance all other atoms. So apart from oxygen and hydrogen, what you have? Sir, sulfur 2 8, so 4, sulfur balanced. Now 4 3 जा 12 OH minus, क्योंकि after balance oxygen, how? By adding uh, sorry, balance by adding water. I'm sorry. Balance oxygen by adding water. So this is 4 3 is 12, so this is 12 water. Now add H plus to balance hydrogen. This is 24 H plus, so 24 H plus. The amount of H plus you added, add the same amount of OH minus on both sides. Why? Because medium is not acidic. So sir, how will it will become acidic? I am showing you. H plus and OH minus, as you know from ionic equilibrium, it is not an electrolyte. It associate, so form water. Medium will turn basic. Mathematically, we have not done anything, because the amount of H plus you are adding is present in this side. Add OH on both sides. Mathematically, you are not doing anything wrong. And chemically, chemistry wise, I know this is water, because H plus and OH associate and forms water. So this is 24 water, this is 12 water, so 12 water will be remaining. Now balance charge. So just this one step of adding OH minus and balance charge, like we did in the acidic half. So this is minus 24. 4 into 2 is 8. So 24 minus 8 is 16 electrons, I guess I'll be needing. So 16, you do not have to multiply. Simply add the reaction and you will get the answer. If it is getting simplified, then cancel that coefficient, and then you will be getting a simplified equation where OH minus ion coefficient is A, this is B, and this is C, and this is DC. These set are okay, but question is only asking you A, so you just know what is OH minus ion coefficient. Somebody is giving answer. Sir, class kab tak chalegi? 12. Beta, I guess 12 we'll try to increase the momentum after dinner, but yes, it will be somewhere around 12:30 maybe. So answer is 12. Perfect. Vinod, perfect. We'll be taking dinner break. Can we continue for like, because I feel I should continue for like more. So can we delay the dinner by half an hour, 40 minutes maybe? Guys, on you, because you are continue. Okay, so we will be perfect. Yes beta, yes, after GOC है ना. So we are continuing, and we'll for 30-40 minutes also. For more we continue, and then we take a break है ना. चलो okay. नहीं, then we'll for 30-40 minutes whatever we'll do. See, I told you how many parts I have. 4. Live 1 gone, live 2. So let us finish live 2. Live 2 will be containing organic. Let us finish organic. Then live 3 and 4 we'll do after dinner. Okay. So let us finish live 2 now. Tanish, perfect. Chalo. Some basic questions now. Okay. A, I guess people have got this answer. I just repeat a basic over here, because this is a common thing which makes chemistry doable. So now easy chemistry is coming now. Sir, this is benzoic acid. So benzoic acid, and this will be 1, 2, 3, 4, 5, 6, because location is over here. Over there you do not have any branch. So I guess your answer is definitely A. Perfect. This is 12th. With organic I will be summarizing. That's why I'm saying with organic I'll be summarizing. So Tribhuvan, we have already started organic. So we'll do straight only. Now again, the structure, I guess, guys, be a bit more vigilant now, because from organic our speed will be increased, because obviously this is much doable. Now answer, Bombay. No. Ayush, check again. Ayush, check again. Still Bombay. Vinod is also saying Bombay. There's some option error. What? 3 amino butane nitrile. Okay. I have written is 2. Okay. Okay. You are giving B, no? So answer is C. 3 amino. Okay. Then, guys, you are committing the same mistake. What mistake? I'm investing. By CN is also containing carbon. So nitrile is a functional group carrying carbon. So that carbon won't you consider in main chain. You have rule says start numbering from the carbon having functional group. So this triple bonded N is connected to this carbon. So this will be 1, 2, 3, 4. 3 is having a branch because NH2 is a junior functional group. So it will be 3 amino butane, and triple bonded N has a suffix of nitrile. So nitrile is a suffix for triple bonded N. For cyanide, the suffix is for CN. The suffix is cyanide, but we do not take that suffix cyanide. Why? Because that carbon containing suffix is only used for functional groups when they are directly connected with the rings. Like cyclohexane is containing CN, so it will be cyclohexane 1 cyanide. Generally we take that carbon in the main chain. Okay, I hope. Perfect. Moving forward, next question. Fast. ABCD. ABCD. Nice. Sir, I have my shift on 21. I'm averaging 100 marks. Will I get any NIT? Yes, beta. See, don't doubt yourself. Na. You will get whatever is best for you. You have still 4 days. Work these 4 days and then see. Whatever you were getting, it will be enhanced. Chalo. So I guess I see. Ayush C. Let's check. Perfect. So this is, I just explained, this is functional group which is aldehyde. Numbering will start from here because the 2 is having a branch. Here there is no branch, so 2, 3, 4, 5. So this is nitro, this is amino. If it was just CH3, it would be methyl, but this branch is having a branch. So branch having branch is called hydroxymethyl. Prefix is, it becomes a complex branch. So hydroxymethyl. Laksh is saying A, no Laksh, answer is C, because this is 4th is having hydroxymethyl. Hydroxymethyl, it is a complex branch. Moving forward, I hope it is clear. Attempt this one. Now this question lets you revise IUPAC also. Okay. Yes. So I hope AA who was giving wrong one. Chalo, I hope you got your point. Okay, koi baat nahi beta. Perfect. That's why we are here. No, not your bad, our bad, and we have cleared our bad. Chalo. Now, what I'm saying is, obviously you can name it easily, because if I number from here 1, 2, I'm having a branch also, multiple bond also. 1, 2, I'm having multiple bond but no branch, so that will be our selection of main chain. So it will be 1, 2, 3, 4, 5, 6. So it's a 6 carbon chain with 2 having ene. 6 carbon chain with 2 having ene. So 2 having ene and 4 having ine. So obviously these options are, but 2 out of 2 and 4, which is right, will be decided by this E and Z. Although it is saying E, both options are saying E. So let us check. 2E, 1E. Okay, it is. It will be. Actually, 2 is having bromo. So 2 is having bromo. So answer is 4th. For this question, because mains has asked us question in such a simple manner that they have not created option in this E and Z format. Actually, I've taken this question in order to tell you the E and Z nomenclature. What is EZ nomenclature? Let me summarize that. Although you have got your answer perfect. Now, That's what for E only. Ayush, for E only I'm telling you. Actually, EZ, like for geometrical isomers, if similar group are on same side, it is cis. If it is opposite side, it is trans. We know this. But what is EZ nomenclature? The carbon, the sp2 hybridized carbon, the two free valencies it has, you do seniority, as in you apply sequence rule. Sir, how to apply? Just go to the added atom, to the sp2 hybridized carbon. More be the atomic number, more will be its seniority. Like for example, if this is alkene, so let us mark seniority. Okay, I have already circled it. This carbon is connected, this carbon is connected with an hydrogen, and this is connected with a carbon. Who has higher mass number? Carbon. I'm just looking at the direct atom connected with sp, so this becomes senior. Similarly, connected with C, connected with bromine, which is higher? Bromine. So senior group are on opposite side. When senior group are opposite, it is said E. Iterate, start saying opposite as opposite, so that you may learn it is E. It is just a rhyme to remember. And obviously when senior groups are same side, so it is Z. But that question was not asking us to know E and Z, because it was helping us through options. Moving to the next question attempt. Now I'm just increasing, because these are some basic questions. So directly moving to the structure. This is the structure. You can obviously make, calculate sigma bonds. Why I have taken this example is because many students do not count this hydrogen. Those sigma bonds you count, but you miss these hydrogens. Hydrogens also are making sigma bonds. So these hydrogens count them also. Many of them miss them. So sigma bonds will become 14, and pi you can obviously count 1, 2, 3, 4. So total will be 18. So your answer will be 18. Moving forward. E for opposite, enemy op. Okay, whatever rhyme you make. 18. Next question. This is a typo error. Numerical is wrong. I mean, these are. Now again, this question I'm giving you because it is a mains question, but these heterocyclic, these organic, these general names you should always remember. These general names are not famous. They are very famous, my friends. So these general names you always be very friendly with them. What are them? Furan, pyridine, pyrrole, tyrosine. Tyrosine is a type of alpha amino acid. Now, all of them are aromatic compounds. Now, this is thiophene. This is thiophene, and this is also an alpha amino acid called cysteine. So these are all some famous structures. In the question you are asked how many of them have sulfur. So these two have sulfur. So your answer is 2. It is a JEE Mains question, but you should know these basics, please. So some facts you should learn. So whatever questions I'm giving you, I want you to at least have a view on them, overview, so that you may recollect them once the direct question is coming. Now, next question, application of electron displacement effect. Obviously, the most stabilizing effect is if a carbocation attains aromaticity. What is aromatic? You should be planar. You should follow a complete delocalization, and complete current loop should be formed by 4n plus 2 pi electrons. If it is happening, you are attaining aromatic nature. So the most stable carbocation is aromatic stable. Less than that, resonance stabilized, because extreme case of resonance is aromaticity. After that, check for hyperconjugation, and at last you should check inductive. So I guess Tribhuvan is saying 2, but then 1. AKY draws. Okay, this is okay. I guess C is reso. Okay, let's check. I guess most of them have attempted. Moving forward now, sir. If you see C, that's why I was explaining aromaticity so clearly. Because if I have a carbocation, then only the complete cyclic conjugation has taken place, which is taken place by 6 pi cloud. So yes, this plus is making it not resonance stabilized. Daddy, extreme case of resonance, which is aromaticity. So C will be most stable. So because C is most stable, so answer will be either 1 or 4. And then you can obviously see this is a 2 degree. I mean, This is a basic 2-degree inductive. This is resonance stabilized from 2 sides. This is resonance stabilized from 3 sides. So A, B and D. So your answer will be obviously Delhi. But for those, because I have iterated a lot of things, so I have written all those things that electron deficient species are stabilized by electron donating group, electron rich species are stabilized by electron withdrawing group, and order of stabilization is this. I have even written what are the conditions for compound to be aromatic. I have done my part for you, so please at least do remember them. Moving to the next question. But in A, resonance is but in A, not because of carbocation resonance is present. In C, if there was a carbocation, then it would have gained resonance also and aromatic nature also. Okay, Ayush. But 2 by 3 phenol groups. Yes. See, if I see, okay, I'm just moving one step. See, let's say I have this halogen over here. Let's say there is no carbocation. Is still this compound aromatic? Yes. Carbocation forming, carbocation not forming. Because if benzene is there, its aromatic nature is there. But does that aromatic nature has anything to do with this plus? No. Got my point? Here, if this plus goes, this compound is not even aromatic. It will be just a compound having resonance stabilization or pi cloud. That's it. So that's why that is the compound. If the radical is making you aromatic, obviously it is aromatic stabilized, daddy of resonance. Attempt this one. Sir, can't see the option. Okay, I'm sorry. Now, because of me, I'm fat. Yes, I am. I was standing there. I have this full jar of chai and it is having a lot of sugar also, but still I should avoid. Sir, just like tautomerism, we have to change if it present or absent. Sir, just like tautomerism, we have to change. I didn't get. See, tautomerism, hydrogen movement take place. What I'm saying is, whenever you get a radical, and because of that radical, you are attaining aromatic nature or resonance stabilization, the extreme case of, then you are more stable. And in that particular case, even if you remove that carbocation, still it was having resonance. So that's why I've taken that account. Now, obviously, this is quite clear. I guess most of you, D4, I'm getting the answer. D4, let's see, let's check. Why it is not moving forward? Yes, answer is 4. Why? Because this is 3 degrees, so more stable. This is, the degree is same, but 6-membered ring is free from any Baer strain, while 3-membered ring is having most Baer strain. Baer strain decreases as ring expands, and what 6-member is free from any type of strain. So this is stable not because of some electron displacement, but because of the strain in the ring. So that is more stable. Here, this is on an sp2 hybridized. After it is gone, it is now sp hybridized. So more be the S character, more be the electronegativity. So this guy will not try to take any radical, whereas this B is resonance stabilized, pi sigma radical. So this guy is more stable. But in option D, because this is 3-degree benzylic and this is just hyperconjugation stabilized, so therefore this is more stable. And in the question we are asked, A should be more stable. So D is our answer. Perfect. Moving forward. Let us attempt this one. And for this one, I'm directly giving you one logic. Actually, from aromatic nature also, as I told you, 3-membered carbon is in the maximum Baer strain, because carbon wants to stay at an angle of 109 degree 28 minutes, because this is an sp3 hybridized carbon. But it is forced to form a cyclopropane. It is forced at an angle of 60 degrees. So angles are having lot of strain. Therefore, they have a pi character, delocalization character. And therefore, whenever a cyclopropane has a carbocation just adjacent to the atom, it will try to delocalize the cloud. The sigma cloud undergoes delocalization in form of pi cloud and undergo ring expansion, and therefore provides tremendous stability. So this case of cyclopropane having carbocation just adjacent to it is the super stable carbocation. So this becomes even stable than. So how do we know this? This is through experimental data. I'm telling you, just learn this much, that this is even stable than aromatic stabilized species. So this becomes your famous this becomes your famous not famous, I mean the top contender. So correct order will be C. D will be most stable, then Bombay. Where is Bombay? This, because this is 3-degree resonance stabilized. Then A. Why A? Because this is also resonance stabilized, pi sigma plus. And last is C, because this is just hyperconjugation and inductive. What I told you, what is the most stable dominating effect? Aromatic. But more than aromatic is this cyclopropane carbocation. Cyclopropyl carbocation having cyclopropyl group attached to it is extreme case of stability. So it will give you answer as option 2, these things. Now actually the question is asking over here, in this question it is asking hydride affinity. So hydride affinity as in I want H minus to attack. So if I'm stable, why will I want H minus to attack? So if I am stable, I will want H minus not to attack. So whom H minus will attack to the greatest extent, which will be least stable. That's why C is written first, because C will be least stable among these carbocation. That theory I've written over here. I guess you got your answer. Moving to the next question. Understood? Okay. Tribhuvan, perfect. Dancing resonance. Yes, Ayush. The term is called, actually I was intentionally not using that term dancing resonance, because some students hear this dancing resonance, we are learning. So I was giving you logic also. Perfect. Now again an application of resonance effect. OCH3 is what group? Now I'm summarizing this resonance application also for you. How? Sir, if I have an atom and I'm not having any vacant orbital, and my lone pair will always be going to the conjugate system, so I will be a plus R group. So OCH3 is a plus R group. Similarly, this N, nitrogen have empty orbital? No. So it also has lone pair? Yes. So it is also a plus R group, but this plus R is in cross conjugation, because this can go here also and carbonyl group can also withdraw. So it is less activating, it is more activating. Why you are saying activating, sir? Because whenever plus R group is attached, it creates electron density at ortho and para position and creates richness of electron in benzene ring. Benzene is electron rich, can only be preferentially attacked by electrophiles. So where electrophile will be directed at ortho and para position. How they are directed? They will be super happy to attack this electron rich benzene ring. Hence they are called activating groups and ortho and para directing. Now if I have, I'm doing this for options also. If statement B is wrong in that question. Why? Because OH is also a plus R group. It is also ortho para directing. It is saying otherwise. Now, why statement C is correct? Because C, now, sir, you whenever an atom attached to benzene ring has vacant orbital, it is always minus R. Sir, but this carbon do not have vacant orbital. Draw the resonating structure. Nitrogen will withdraw electron, creating carbocation. Carbocation containing empty p orbital. So that empty p orbital will try to withdraw electron. So it becomes a minus R group. Similarly, sulfur has empty d orbitals. So this also becomes a minus R group. Now, whenever I am minus R group, I will withdraw electron through resonance. But resonance is always operational at ortho and para position. But if I withdraw electron, I will create positivity at ortho and para position. Now, benzene is always attacked by electrophile, because benzene is electron rich species. So if I have an electrophile approaching, electrophile will not be feeling comfortable in attacking this electron deficient benzene ring. Here it was feeling activated. So therefore these are called deactivating groups. And if at all electrophile is produced, where it will be directed at meta position, because electrophile is plus 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 repel each other. So relatively, where is electron density? At meta position. So they are also called meta directing. With one question, I'm giving you all the GOC logic. Now, talking about halogens, fluorine is minus I also, but plus R also. But fluorine being most electronegative, its minus I is huge. Therefore, net ultimately generally inductive is weak. But for halogens, because their resonance is not strong, for fluorine plus R is perfect, but its minus I is very strong. So ultimately, fluorine becomes electron withdrawing group. What about halogen? Halogen have empty d orbitals. So through plus R they can take also, but through minus R they can withdraw also. So they can even do plus R, they can even do minus R. Moreover, they are electronegative elements. And through electronegative, because of electronegativity, they are minus I. But sir, inductive you said is weak. Their resonance is weak. Why? Because they are forming pi bond. Chlorine is forming 3p. Bromine 4p. Iodine 5p. Dissimilar energized orbital when form pi bond is very weak. So weak pi bond, that means weak resonance. Therefore, these halogens are actually electron withdrawing groups, not activating. Point number one. Yes, if electrophile is produced, it is not interested. Like here, they are activating. Electrophile is getting anxious to join their party, but electrophile does not. But yes, if you have not eaten for 10 days and if somebody will give you one roti, so if at all electrophile is formed, so where that electrophile will go, it will be going at ortho and para position, because directive nature is, again, they ultimately they are plus R, but the extent to which they are giving that plus R is very small. So directive influence is decided by resonance only, but electrophile is not feeling charged to attack this thing. So here with this concept we are also starting alkyl and aryl halide logic. Moving forward, sir, will you give most? Chalo. Moving forward, let us attempt the next question. Aims, sir, will you give must to do questions? Beta, this is must to do questions. Must to do. Triple must to do questions. Why? All NCRT facts, more or less, I have not tried to move larger. Mains is also restricted, but these are all PYQs which will be dealing with all the concepts of organic, inorganic, physical. Now, for the correct order of okay, now increasing pK, sir, if acid is strong, K is more. If K is more, pK is less. So increasing pK, as in who is having lowest pKa is having highest Ka. That means it is the strongest acid. So A. I've got some A's. So let's check. Answer is yes. Bingo. Answer is option A. I guess this is quite easy because now we know electron displacement effect. How to know acidic nature? If you have electron withdrawing group, acidic nature will increase because acid wants to gain electron. If you are comparing basic nature, electron donating group will increase basic nature because base wants to give electron. We know that. Now, written that also. Now, acid is strong, K is strong, pK is less. Done that. Now, these are the options that we have. Sir, acidic nature, this is minus R, strong electron withdrawing group. So B will be, what is order of acidic nature? B will be most acidic, followed by, sir, this NO2, but NO2 apply minus R at ortho and para position. At meta, it can only apply minus I. But at least it is applying minus I. Why? Because other option, which is OCH3, although it is plus R, but at meta position it is neither plus R nor minus I, because at meta you cannot apply resonance. So, but because of oxygen it is electronegative. So inductive of this O will be minus I, but minus I of NO2 is larger. So D will be most acidic. After B, D will be most acidic, then C will be most acidic. Now, this OCH3 is electron donating group. Electron donating group will make acidic nature less because acid wants to gain electron. If you are giving me electron in house, I will take electron from outside later. So I'll be a weak acid. So in fact, having nothing, as in this benzene substituted, this simple phenol is a stronger acid. So simple phenol, as in A comes first, first to E, and E comes last. This is order of acidic nature. Acid strong, Ka strong. So pK will be weakest. So reverse order will be for value of pK. Very perfect question for JEE Mains also, for practice also. Moving to the next question. Sir, only I'm confused. How to find acidic and basic? How to find acidic hydrogen? That's what I was giving, beta. I'm again iterating. If you withdraw electron, that means if I have electron withdrawing group, if somebody is taking away my money, I will want money from people. If somebody is giving me money in the home, I will be giving money outside also. So electron donating group makes you basic, electron withdrawing group makes you acidic. The simple logic, like for the basic nature of amines. Now this is a 2 degree, this is a 1 degree, this is a 3 degree, this is aniline. Now first of all, I hope somebody is giving us answer B, B, C. Okay, I'm moving forward. Now first of all, let us understand about, because through this we are entering amines also. That's why I'm coupling whole of organic together. GOC does that. That's what I'm doing. Now actually, if you compare amine, aromatic amine and alkyne amine, first aromatic and alkyne. Sir, right now you have told us resonance. This lone pair of nitrogen is delocalized in the ring, hence not available. Not available. So aromatic amine is a weaker base than alkyl amine, because alkyl amine has plus I. Now for alkyl amines, I'm saying inductive is most dominating effect. That's why every alkyl amine, any type of alkyl amine, is a stronger base than ammonia, because ammonia has no R. 1 degree, 2 degree, 3 degree alkyl amines has R also. All alkyl amines are stronger base than ammonia. That means inductive is most dominating. I mean, out of basic nature, inductive is one of the most dominating. That's why all alkyl amines are stronger base than ammonia. Point number 2. Point number 1 is aryl amine is weaker even than ammonia. Aryl amine is a weaker base than ammonia because nitrogen is not available. Point number 1 done. This one done. Now comparing the exact basic nature of amines, it is an experimental concept. Why? Because basic nature of amines not only decided by inductive. Inductive is a very dominating effect, but not the only effect. What are the other less dominating effects? Two very famous: solvation and steric. If I am a base, I will give. If I am crowded, how I will give? So steric says, because 1 degree is least hindered, 3 degrees most hindered, so it can't give, very bulky. So steric says 1 degree is a better base. Solvation says where you react with other compounds. In solvent, what is universal solvent? Water. Once you get soluble in solvent, then you will react. Who gets more soluble? Who can form more hydrogen bond? 1 degree forms 2 hydrogen bond with water. Tendency to form hydrogen bond decreases. So hydration and solvation also says 1 degree should be the most basic amine. Only inductive says 3 degree. And inductive we have taken in the dominant side also, because every amine, 1 degree, 2 degree, 3 degree, every alkyl amine is a stronger base than ammonia. Why? Because of inductive. That's why I say inductive is most prior, but not only. So because of these factors, what happens is you have to learn the value of Kb, because then it can only be determined through experiments. So rather for JEE, do not learn the value of Kb, but learn the trend. Let's say if you have methylamines, so trend is 213. If you have ethylamine, trend is 231. How to remember? See, 2 degree never loses the battle. In inductive also it comes second. In solvation and hydration also it comes second. 2 degree was neither winning out of the blue, neither losing out of the blue. Remember I told you, you are having 4 days, just work on these 4 days with a disciplined approach. Don't try to be a hero, neither try to be a zero. Be an average performer, you will do good. That's what we are doing. So because 2 degrees, I'm just giving you a logic to remember, because 2 degree is always the strongest base, whatever be the alkyl group. Now methyl is a smaller group, so 1,3. Ethyl is a larger group, so 3,1. So 1,3,3,1 is a trick I'm telling you to remember. Now sir, in gaseous phase, obviously inductive. In gaseous phase, there is no hydration factor. So decide by inductive. That's why I said inductive is the most dominant. That's why every alkylamine is a stronger base than ammonia. So for gaseous beta, obviously only do by inductive. I guess we got our answer. Moving forward. Am I clear? Some hello hi will be, I mean, some thumbs up, or just we are parting, huh? I guess, let me check. It is having 100 or so, then we can take a break. This is question number 65, na? Page number. Nahi, beta, we will finish this. Let's accelerate. Finish this. 6. Ayush is saying 6. Ayush is saying 6. Okay. Let's do this. Now, it is asking us to give us the chiral center. Optical isomerism is because of the chiral carbon. What is a chiral carbon? A sp3 hybridized carbon having all 4 differently substituted bonds. So 1, 2, 3, 4, 5, 6. Chiral carbon are 6. Answer is 6. How I'm giving you a trick also, or some help also. Obviously, if a carbon is chiral, you have to check that whether bonds are different or not. But if it is not chiral, it can be easily checked. Why? If you are having more than 2 hydrogens. So for rings, actually it becomes very easy. So this, it is a junction. So this carbon, this carbon, this carbon. So that becomes chiral. What I'm saying is, if any 2 groups are same, then obviously it is not chiral. So generally for ring, some students miss. So that's why I say make CH2 CH2. Whoever has H2 is not chiral, obviously. So answer is 6. Very easy question. Moving forward. A very logical and in fact a very good question. Now I'm doing this question. The Ayush was asking something about tautomerism also. Now it is saying compound B is aromatic. B is formed when this is reacting with 2 equivalent of OH minus ion. Above reaction is very slow. A shows, this guy shows tautomerism. Obviously this can show tautomerism because this is double bonded OH. So this is enol, and this hydrogen, this double bond can come here, this hydrogen can go here, so it can obviously form an enol form. So this, without even picking pen, I can say it can show tautomerism. Now regarding bond length and aromatic nature, we have to draw the resonating structures. Question is saying this A is reacting with OH minus ion. To make it quick, I've drawn those structures for you. Reacted with OH minus ion, obviously what OH minus, it's a base, so we'll take H plus, snatch these H plus, forms these carbon ion minus, not carbon ion, this O minus ions. Now this O minus ions, when you draw their resonating structure, you will see this resonance hybrid. Just have a look, which will show that pi cloud is conjugated in the complete ring. So because 2 pi cloud are conjugated, so this becomes aromatic. So if I'm becoming aromatic, then I will be willing to proceed fast or slow? Very fast. So reaction will be proceeding fast, not slow. It is aromatic. Yes, it is aromatic. And because it is having partial double bond character like benzene, so bond order of all C bond C will be same. It will be not be seen like this, that this is double, that is single. So because of these reasons, our answer will be option C. Perfect. Ayush, perfect. Moving forward, let us attempt this question. A question of conformational isomerism. And obviously we know, when because of C single bond C free rotation, this is eclipsed form, this is staggered form. Eclipsed form is having van der Waals strain also, torsional strain also. Staggered form has, I mean, minimum van der Waals strain and minimum torsional strain because angle is 60 degree. So bond pair electrons are quite distant from each other. But any form, when theta is 0, it is eclipsed, it is staggered. Any intermediate theta is a skew form, like a skew form given over here. Now it is asking bond angle of this H dash C, the backside C, and this. So obviously I can see this is 29 degree and this is geometrically, you can see it is 120 degree. So answer, this is very easy. I mean, this is just physics, just maths. So answer is 149, but giving you the details of geometrical isomerism, the conformational isomerism. Moving forward, let us attempt this isomerism question. Now, when I have a polyfunctional group, as in functional group having alkyl group on both sides, then if nature of alkyl group changes, it is not chain or position isomer, it is metamers. So are these ketone metamers? Yes, ketones are not position, they are always metamers, so this is right. CN and NC, yes, they are functional isomers because even name and properties are different. Now, here number of carbon, if you see, this is 1 2 3 4 4 carbon, this is 1 2 3 4 5 carbon, so this is not even having same molecular formula, so how can it be isomer? Similarly, this is 1 2 3 4 carbon, this is 1 2 3 4 5 carbon, so they are also not uh, having, so they can't also be isomers. So A and B are correct, so answer is definitely option 3. Moving forward, now let us try this question. A very common sense, a very basic question involving logics of GOC for good questions. Now see, this is an alkene, okay, carbocation stability we just now read. Now sir, alkene is pi electron cloud, so it is from upside also downside also, it is surrounded by minus, so it can be attracted by plus. So what plus you have, sir? H plus. Who will give H plus? Sir, OH bond length is very small, SH bond length is very high, down the group bond length decides, so reactive S bond H can be easily broken, so this S bond H can be easily broken. This sulfur will form S minus and this H plus will attack this pi cloud. Now when H plus attacks alkene, what forms? Carbocation. What forms? Yes, just 60, I mean just 10 more minutes, guys, just 10 more minutes, then we'll have a break of like 15 20 minutes, 15 minutes, when we can view 15 minutes is good for lunch, right? I mean dinner. One of my uncle, he used to say, raat wala lunch karana hai kya? So actually it is dinner, not lunch. Moving forward now, so where you will form that carbocation? Sir, if H plus attacks carbocation, if formed over here, sir, CN is an electron withdrawing group. Will it allow that carbocation? Sir, you said electron deficient species is destabilized by electron withdrawing group. So carbocation will say no, I'll not come over here. Rather, I should come over here. And if carbocation prefers to come over here, S minus will be attacking this carbon. So this is nothing but this S having 2 carbon here, the same S having, because then it will become saturated, 2 carbons here. So sulfur having both carbons, one side OH, one side CN. So answer is definitely Bombay. I hope you got your answer. Moving forward. सुबह वाले lunch तक नहीं. Even I want a break, but at least let us finish this live to know, because we have a task to do and we will do it, but with grace, with confidence. We will stuck at some questions, but when we'll come out of it, or when we'll go for revision, we'll see those questions. Okay, this is the question we got stuck, because this rhythm, today I will be getting stuck at some different place, tomorrow I'll be getting stuck at different places, because rhythm is always decided by practice. So practice hard so that every day becomes a constant feel. Sir, we can, yes, Ramon, good. Chalo, this question, a sample of 0.125 gram of organic compound when analyzed by Duma method. Now, practical organic chemistry question we have reached. Now, what is Duma method? Duma method actually takes some oxidizing agent and convert organic compound into its oxides. So carbon forms CO2, hydrogen forms water, nitrogen forms nitrogen gas, and they supply that nitrogen gas through a bubble of KOH. I guess I have taken that. This I have worked for you in the morning. So this all the organic compound, when it is treated, converts into stable compounds. So nitrogen is created, is converted to nitrogen gas. And what amount of nitrogen gas you created, we estimate in the volume. So there will be production a lot of CO2. That's why you use KOH, because KOH is a base, CO2 is an acidic gas, so they neutralizes. So the only gas you have over here is nitrogen. But because you are heating and forcing, so because of the high temperature, sometimes this water also, if you heat, water also vaporizes. So here you get nitrogen gas also, and because of that heat you get water vapors also. So whatever total pressure you get, that total pressure is pressure of nitrogen plus pressure of water. What pressure applied by water vapors is sometimes called equostension. So in this question is saying that total pressure is 759 mm of Hg. Equostension as in vapor pressure of water at that particular temperature is given out to be 14.2. Subtract, if you subtract, you get what? You get pressure of nitrogen. So pressure of nitrogen, what will be pressure of partial pressure of nitrogen? 759, I'm sorry, minus 14.2, this much mm of Hg, divided by 760, so it will become this much atm, because 1 atm is equal to 760 mm of Hg. So 1 mm of Hg is equal to 1 upon 760 atm. So this has converted into atm. Why atm, sir? Because volume question is giving you how much volume? Question is giving you 22, this much ml of volume. So volume of nitrogen you know, pressure you know, use PV equal to nRT. So if you use PV equal to nRT, what you will calculate? You will calculate number of moles of nitrogen gas. It will be equal to pressure of nitrogen gas into volume of nitrogen gas upon RT. R what you will use, that's why I converted pressure into atm, because R you will use 0.0821. I guess question is also, question is saying use 0.082. Into divide you have to do. So once you use those value, you will get what? You will get weight of number of moles of nitrogen. Now if you have number of moles of nitrogen, can't you find weight of nitrogen? Because this is number of moles of nitrogen. Okay, what is asked in the question? Percentage of nitrogen. So you have estimated number of moles of nitrogen. So for weight of nitrogen, what you will do? Number of moles of nitrogen into 28. Done. Weight of nitrogen you know. So weight of nitrogen upon weight of organic compound into 100, it will give you percentage, because this question is asking you percentage. So the percentage of nitrogen in the given organic compound. Weight of nitrogen you got, weight of organic compound is this much, 0.125 into 100 will give you answer. I have given you the answer, by the way. Calculative, it will be 22% when you will approx to close. Oh, very good, AKY, very good. Very good, very good, very good. Ayush, very good, AKY. Come on, next question. Again, I guess you have read the question now. Point is, picric acid is actually phenol substituted with ortho at para position or with NO2. And obviously, this is para-nitrophenol, not P, this is para-nitrophenol. So para-nitrophenol and picric acid. Actually, this thing and this thing, both of them have ability to form hydrogen bonding. Sir, if you have ability to form hydrogen bonding, you will be soluble in water. And if you are soluble in water, we do steam distillation of those species which are not soluble in water. First fact of practical organic chemistry you should know. So we can't use this. Now, this silica gel is actually, what silica gel does is silica gel absorbs the species, and by extent of absorption is different, so they get separated. But for that we need large amount. Question is saying I am giving you only 100 milligram. So because we can separate using silica gel, but when given quantity is of large amount, here given quantity is of negligible amount, therefore this silica gel methodology can also not be applied. So sublimation, when solid changes, they are liquid, I mean they are not solid, so how will solid? So obviously this is now a fact which you know. So the last option that is left with a thin layer chromatography, which is also a fact you should know also moving forward. Now Dumas method we have done. Now what do we do in Jheldal method? Actually in Jheldal method, what we do is we take organic compound. I'm just going through every logic, not leaving anything, with actually questions of last year. Organic. Now what we do with this organic compound, we add concentrated acid. What concentrated acid do to this nitrogen containing organic compound? They convert all the nitrogen to ammonium sulfate. Ammonia, and because H2SO, ammonium sulfate. Now when this ammonium sulfate because it's an acidic salt, it is added with excess of base so that neutralization will take place and ammonia's gas is released. So all the nitrogen present in this organic compound is released in form of ammonia. Now, this ammonia released, I know, hey ammonia, you are coming from where? You are coming from organic compound. Okay. Now I use a acid whose concentration I know. The amount of acid, I'll do titration and I'll check how much acid I have used. So in this question, it is saying that this much ml and this much molar of acid is used to do what? To neutralize ammonia. So you tell me number of law of equivalence without even writing the reaction. Number of gram equivalent of ammonia. How to do it? Number of moles of ammonia into valency factor, because ammonia will form NH4OH, a salt base with one valency factor. Number of gram equivalent of ammonia is equal to number of gram equivalent of acid. For acid, what you should do? Volume in liters into molarity into valency factor. Simply. So this is number of moles of ammonia. Now, because you know this moles of ammonia is coming from where? This moles of all the nitrogen is coming from this. So calculate weight of ammonia. How? So number of moles you can know. So multiply it by 17. Now, this whole weight I know. Do the unitary method. Like what? If I have 17 gram ammonia, then how much nitrogen it would be containing? 14 gram. So if I would be having 1 gram, so it will be 14 by 17. And let's say I'm having this W gram. So this will be, this much amount will be weight of nitrogen in my organic compound. And for calculating percentage, this Wn upon weight of organic compound into 100, bingo will be your answer. So 64, okay. AKY and Ayush are saying 20. Okay, you must be giving answer for the previous question. So I guess you got the 64. Hello. Say yes. Move up. Shall I move ahead? Hello. Hey, I can see 10 people watching. 64. Thank you. Moving ahead. Just few 5-6 questions more. This is having 86 slides. I want to finish this. Just these. GOC. Now, Jaildal and Duma are the longest methods. Already done. Perfect, Ayush. Perfect. Moving. Now, it is saying for now how you calculate bromine, how you calculate other elements in an organic compound. Let's say I have an organic compound 0.5 gram. Okay. It gives 0.4 gram of silver bromide. Silver bromide, if it is giving, the bromine must be coming from organic compound. So organic compound containing that bromine when it is treated with silver. Okay, why I'm doing this? I have made this box also takes time. So organic compound when added with silver gives you AgBr. Do the unitary method, which is now a fact. It is a pale yellow colored PPT. So this AgBr is a precipitate. It is not soluble in water. Now, sir, how to calculate percentage? Now you tell me. Question is saying 0.4 gram of silver bromide. This 0.4 gram of silver bromide is coming from organic compound. Silver bromide weight is 0. So what is the molar mass of silver? Just what we have done for ammonia. Like if I had 188 gram is molar mass of AgBr. You with the given mass you can calculate this much. This is if I have this much of AgBr, then you tell me how much bromine this much of AgBr has. Sir, this plus this. So bromine will be just 80. So I'll be having 18 gram of bromine, right or not? So if I'll be having 1 gram of AgBr, I will be having 80 upon 188 gram of bromine. And if let's say this is W. So this much gram of AgBr will be having this much gram of bromine. So this bromine has come from where? From organic compound. So weight of bromine, this value upon weight of organic compound 0.5 into 100. Percentage. I hope you got the answer. Okay. 34. Perfect 34. Perfect 34. Perfect. Who said 34? Ayush. Ayush. Perfect. So energetic. Thank you. Chalo. Next question. Compound P. Fast. I just sip some. No, not this one. Fast. This is still hot. Good chai. Hmm. Compound P on nitration is done. Now, we know OH is a activating group. Activates the group, therefore NO2 will be added to all the possible positions. So even if we use dilute HNO3, still excessive nitration will take place. Yield two isomers A and B. The isomers can be separated by distillation. Isomer A and B show the intramolecular hydrogen bonding respectively. Compound P on reaction yields a yellow compound, a strong acid. The number, okay. Now, this is saying compound P on reaction with concentrated nitric acid. What is P? P is a compound which on nitration is forming two isomers, A and B. And both these isomers are having difference in boiling point. That means ortho and para. So nitric acid, orthopara, phenol, nitric acid. What I'm saying is, because dilute for nitration, we need concentrated sulfuric acid and HNO3, then NO2 plus is created. If I'm not taking concentrated H2SO4 still with dilute HNO3, how come nitration is taking place? That means a group is activating. Strong activating group is phenol. So with this, we have segregated the point that phenol, when treated with dilute nitric acid, forms ortho and para-nitrophenol, and obviously para can form intermolecular hydrogen bonding, so its boiling point will be high, its boiling point will be less. Point number one. Now, concentrated nitric acid, sir, if it is concentrated, excessive nitration will take place. That means NO2 will be added to all the possible ortho and para position, and OH will be just here only. Done. This much is done. Hello. And this is actually a yellow colored compound, which is a knowledge you should have. So I hope. Now, what is the question is asking? Number of oxygen present in compound C, and this is compound C. So number of oxygen present is how much? 2, 4, 6 and 7. Answer is 7. Let's check. 7 was the answer. Para meta. No, para ortho para beta. Sir, I have not touched practical chemistry. Can I leave? Can't understand much. Tribhuvan, if whatever, you can watch it one more time, but if you feel you are not at all understanding, then obviously, except leaving, what else we have, option we have. Try to do it, try to revise one more time tomorrow. Still, if you feel not comfortable, then leave. Now, Lessegnay's test. Again, a theoretical question. I guess we should clearly do this. Lessegnay's test is actually carbon, hydrogen, whatever elements we have, how to detect their presence. It is the organic compound is treated with sodium and forms a sodium extract. And to that sodium extract, we detect using a phases of reaction that what all elements are present in it. So both nitrogen and sulfur are present in organic compound. So when both nitrogen and sulfur are present, yes, they form sodium thiocyanate. See, when you have an organic compound in which sulfur and nitrogen both are present, actually then the sodium salt formed is sodium thiocyanate, which is NaSCN. Now, a property, if to this NaSCN you add ferric iron, it forms a blood red coloration because of the formation of this complex. But if you add excess of sodium, then this particular compound gets further reacted and the cyanides and sulfides are formed. This is what is given in the question as assertion reason. So answer will be option A. Thank God. I told you na. This was done. So what is the time? I mean, not hunger. We are still left with, I guess we'll be taking 2 more hours. But let's take a break for 20 minutes because I also need a break and we will finish it completely. So let us take a break for 20 minutes. So this is 21:57. So we will meet at 21:57, na? 3 minutes and 17 minutes. So 10:17 we will meet. 10:16, 10:17. I'll be back by 10:16, 10:17. So take your dinner. We'll meet soon. Bye bye. Fast, fast, fast. Go, go, go. Hello, 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 hello. Yes, Tribhuvan. I had 2.5 parathas. Gobi paratha. Because, but because we need energy. Because we are still left with, I guess, maybe 2 hours, maybe 2.5. We'll try to finish in 2 hours. 2, 11, 12. Let's see. Hi, 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 guy, hi, hi, hi. Everybody have some food, not a lot, but have some food so that then only your concentration focus can prevail. So, am I audible? Hello. I'll be speaking in this tone. So, I'm loud, right? Hello, hello. I'm loud. Okay. Hi, Santosh. Can we complete 12th? See, Tribhuvan, I'm not saying we are completing chapters. What are we? Why are we here? We are here to revise all the chemistry by, if we do not know it previously, then obviously the questions with which I'm discussing, I'm trying to give all the details around it as much as possible, so that uh, we are aligned with the fact that if physics, chemistry, maths, like chemistry over here, if NTA is giving you a basic question, so basic and moderate you can do very well. And even if you do those basic and moderate questions, it is more than enough to get into a respectable NIT, per se speaking, just for JEE Mains. So yes, okay, now so we are starting. I hope everybody is back. And again, a reminder, scan this QR code for the practice sheet and for this lecture notes you will be getting through the WhatsApp channel. So join it, scan the QR code. Details will also be there in your screen and in the description section. Moving forward now, coming and moving to directly alkanes, hydrocarbons as such. And what does the number of alkanes obtained on electrolysis? Perfect, Ayush. Sir, we already know this, that this CH3 will form a radical, this ethyl will also form a radical. If both of them are used, then chain termination can take place between this guy and this guy. So that will be product 1. If this guy undergoes chain termination with itself, it will form ethane. If this guy undergoes chain termination with itself, it will form butane. So what will be the total number of products? Perfect, Ayush. It will be 3. Moving forward, let us try this question. Let us attempt and try this question. Answer 3. Tribhuvan is saying 3. 3 for this one, Tribhuvan. Okay, let us do this together. Now, it is saying you have an alkene. Sir, again a hydrocarbon discussion problem. It is getting acidic hydration. Sir, acidic hydration, as in first the H plus will attack. Yes, definitely. Now this H plus will be attacked by whom? Sir, this H plus will be attacked by the pi cloud. Now where you will be finding your stable carbocation? Sir, here, because here it will be benzylic carbocation. So because benzene, the carbon adjacent to benzene is a benzylic carbocation. Now after that, water will come and it will be resulting in the formation of alcohol. So a beautiful benzylic alcohol of this structure will be formed. Now, sir, what is CrO3? CrO3 is an oxidizing agent which oxidizes alcohol to carbonyl group. Oxidizing agent does not oxidize C bond C, it oxidizes all the C bond H. So this CrO3 will oxidize this C double bond, this alcohol, into the corresponding carbonyl compound. Why corresponding? Because it is having carbon on both sides, so it will be a ketone. Now this is NH2 in presence of KOH, that is basic medium. Now with carbonyl compound with hydrazine forms hydrazone. So carbonyl compound, as in this guy, when reacts with hydrazine. What is hydrazine? NH2 single bond NH2. So this undergoes addition elimination. First addition of this nitrogen lone pair to the carbonyl carbon take place, and then elimination of this water molecule. Do not know the mechanism. Basic is more than sufficient. And once this is gone, this oxygen is gone in form of water. This nitrogen associated with this is called, of this ketone, it is a if hydrazine is reacting with this carbonyl, it is called hydrazone. Now this hydrazone, when undergoes reaction in basic medium, further gets reduction and alkane is produced. So actually alkane, as in this whole groups are removed and we get two hydrogens. So this is the reagent, the action of Wolff-Kishner reduction, a very famous reduction called Wolff-Kishner reduction, which converts carbonyl group into corresponding alkane. Now, so that alkane will be your final product. So where you are seeing that alkane? Sir, we are seeing that alkane in option number 1. I hope most of you got this answer. Attempt this next question by the time I read those comments. Sir, there will be heat present with KOH. Yes, because it is boiling ethylene glycol. Actually, with KOH, it should be ethylene glycol also. Yes, heat should be present. But sometimes for reagents, you can make sure, do not go by such. The answer and the options will give you a idea of what reagent question is talking about. Do not go about the reagents so religiously. Okay, I hope it is clear. Sorry, sir, it was learn last. It is last one is Wolff-Kishner. Yes, last one is Wolff-Kishner. No, CrO3, no. CrO3 is just an oxidizing agent. You take it like that. Why name it? CrO3 is just an oxidizing agent which oxidizes alcohol to aldehydes and ketones. Moving forward. I hope this much is done. Okay, Ayush is saying option A. Now, again, it is a clear naming reaction, very, very famous, called Clemmensen reduction. So zinc amalgam in HCl, it also do the same action, convert carbonyl group to alkane. Now, sir, do I have a carbonyl group? Yes, I have a carbonyl group, but why I'm showing you this is because it is also a acidic medium, acidified reaction. And sir, alkene, we have just seen acidified reaction of alkene. Actually, alcohol. Because if we have acidic medium, alcohol in presence of acid also undergoes dehydration. So what I'm saying is, I'm not denying to the fact that this aldehyde will be reduced and will be forming an alkane. I'm not denying to the fact that this CH3 along with that CHO, so this is CH3, CH2, CH3, so this is C2H5, agreed. But just look at this OH. This OH, when sees an acid, it undergoes protonation, because this is how dehydration of alcohol take place. Because C bond O bond length is very less, it does not dissociate easily. So this OH becomes protonated alcohol, and because you are providing heat also, so bond will be broken and a carbocation will be formed. Now this carbocation, although ring expansion rearrangement can also take place, because this methyl can come here, and once this methyl can come here, so ultimately pi bond it will be forming over here, because this will be pi sigma pi, it will be okay, that will be gone. Okay, so carbocation, as it is formed over here in this carbon, as soon as the carbocation is formed, it will try to form an alkene, because this alkene is also more substituted alkene. Whatever product is formed, product form should be more stable. And I'm combining few reactions over here. So what generalized point I'm making, alcohol in acidic medium undergoes dehydration, and what product is formed? Alkene is formed. What alkene is formed? So generally, if a reactant is itself reacting and forming product, what alkene it should form? Stable product. What is a stable alkene? More substituted alkene is generally more stable. And it was told to the scientific community, not mother nature, to the scientific community by Sidzef, and such products are called Sidzef products. So what's a Sidzef product? When more substituted alkene becomes major product, it's a Sidzef product. And generally what product is obtained? Sidzef product. So what JEE has, what this NTA mains question has offered you, that Clemenson reduction reduces carbonyl group, but if at all alcohol is present, then dehydration will also take place as per Sidzef rule. Generally Sidzef rule is followed, as in that carbon beta, I mean, if you form a carbocation, so beta carbon of what hydrogen is taken? Beta carbon of that hydrogen is taken, which is having lesser number of hydrogen, so that more substituted alkene is formed. Although we will see NTA also, as we will see in the later slides, Hoffman product are also produced. The Hoffman cases we will see in the remaining slides. So answer is definitely option number 2. Moving ahead, the next question, try this one. Sidzef rule, yes. Although do not learn this, do learn whatever, I mean, if somebody is reacting, they will try to form what? They will try to form major product. Major product as in what major percentage of product it will be forming? Major, it will be forming stable products. That's why a reactant is reacting as first place, because it must be feeling comfortable. Okay, I hope you got your answer. Any option? Okay, let me change this color. I will pick, okay, green. No options, I guess. Buck up. Okay, Ayush has given an option B. Now actually answer is B only. What is happening in the previous question? I have this trans alkene and I want to convert that trans alkene to cis alkene. Now first of all, you have to remember this. Then what is the reagent in your NCRT, or the main famous reagent which can form cis alkene? Lindlar's catalyst. What is Lindlar's catalyst? Lindlar's catalyst is, you have you do hydrogenation, you need catalyst, you take palladium also, because unsaturated compounds convert into saturated compounds, you need a catalyst. So catalytic hydrogen you take, and then you take palladium, but then you poison the catalyst. If you poison the catalyst, then the poison, as in you use barium sulfate, quinoline in boiling xylene as solvent, and this complete package is called a Lindlar's catalyst. Now what does Lindlar's catalyst do? Lindlar's catalyst forms cis alkene. Now a trick to remember, Lindlar's catalyst poisons the poison the catalyst. So a trick to remember, poison is a good action or bad action? Bad action in English is a sin. So poison is a sin forms cis. Just a rhyme to remember. Now sir, if we have to form a cis alkene, then last reagent has to be a Lindlar's catalyst. So let us check whether Lindlar's catalyst is given. Yes, Lindlar's catalyst is here also, here also. So these are the two options. Then you should try. Br2, what does Br2 do to an alkene? Sir, to an alkene, Br2 forms BrBr, as in vicinal dihalide. What does alcoholic KOH NaNH2? It makes it to alkyne. And who reacts with Lindlar's catalyst? Alkyne. So obviously this is alcoholic KOH and this is aqueous KOH. No. Sir, I need to form an alkyne. So what will be our answer? Our answer will be B. And why? Because it will first form vicinal dihalides. And then first alcoholic KOH will remove one HX and another HS. We need a stronger base, which is NaNH2. So you get a alkyne. And when I add Lindlar's catalyst, I'll get a cis form of alkene. So I hope you got the point. Moving forward, let us try this question. Try. Yes. Dr. P. Ashok Babu. B. Okay, B you are saying for the previous question. Yes. Now, Let us see and check this question. The compound which will have lowest rate towards nucleophilic aromatic substitution, which will have lowest rate for what? For nucleophile. Sir, you said benzene is electron rich, so electrophile attack. But actually, nucleophile can also be forced to attack. How? Our halides does not want nucleophile to attack. Alkyl halide want. But if you increase the delta positivity of this aryl halide, how to increase? Sir, connect electron withdrawing group, but electron withdrawing group can show their effect when they are at ortho and para position. So this will electron withdraw, yes. This will, here both will withdraw, ortho para. Here only this will withdraw, here only this will. So which will be having most dominating the compound? Okay, question is asking lowest. We have ticked the highest, so which will be having lowest? It will be having this is most reactive, so this is 1. Then these two are also reactive. Okay, D, here it will only be -I, so answer will be option number 4. Yes, perfect, AKY. Yes, perfect. Answer is 4. Moving ahead to the next question. More NO2, less extreme condition. Yes, perfect. Don't know 142. Perfect. Now let's attempt this question. Now over here I have benzene substituted with 2 methyl groups. Perfect, sir. This is acetic anhydride. Perfect, sir. Anhydrous AlCl3, Friedel-Crafts Lewis acid. So Friedel-Crafts acylation. Why acylation? Because this lone pair will be attacking this Lewis acid. This pi will be taken, and as soon as oxygen has taken off the electrons, and as soon as it will try to take the, I just draw it, I guess. I'm tired. Nahi, chalo, come on, 1 2 3 go. Okay, now this is my anhydride, this is succinic anhydride. To anhydrous AlCl3, what are we planning to do? You tell me. Which bond is broken first? Pi bond. So this pi bond is broken. As soon as this is O minus, this is O, this is double bond O. Now because this is excess of oxygen, now okay, why this is O minus? It has given, oh god, it has given electron, so it is plus. Oxygen has taken electron and given to aluminium, so this is also not plus. It is giving to AlCl3. This is minus, and this guy has lost electron. Yes, this guy has lost electron. And because this guy has lost electron and oxygen has just taken electron and given to chlorine, now what happens is this carbon will force this oxygen to give away the electron. So what happens after this is, I'm trying to create, this is O, I should form a carbocation. Okay, that is why I'm not missing the heat. Okay, what you should practically do is, right, I just need a carbonyl carbocation. So what we should practically do is not this thing. Obviously that is also more that can also be done, and it can also form a carbocation, but just I'm doing this simply because we should know this, that this plus is formed, and obviously this O will be giving electron to AlCl3. So this, because it has given, so this is a minus. This much we are making and producing a carbocation, where plus the plus is on the CO bond, on the carbonyl group. Now this carbonyl group having plus is a Friedel-Crafts acylation species. Now what does this Friedel-Crafts acylation is, where it is subjected? Sir, it is having benzene, and benzene is having 2 CH3 groups. Now look closely. CH3 is what type of group? Sir, CH3 is a plus hyperconjugation group. So it will be having electron density at ortho also and para also. So let us take I mean, you can take at least one, you can attack from there also, here also. This minus will be attacking this carbocation. Perfect. Let us draw this structure. So here we have this two methyl groups. It is getting connected with this carbonyl carbon at the para position. So here it is getting connected to this carbon, which is double bond O, which is 1, 1, 2, 3, 4. 4 carbon. 1, 2, 3, and this is the fourth carbon with this double bond O and O AlCl3 minus. Now, after this, don't you feel this Lewis acid will be gone? Yes, sir. Once this Lewis acid will be gone, a carbocation will again be produced in this carbonyl carbon. Yes, sir. Now, if this carbonyl carbon has again got a positive charge, then this CH3 is again providing through plus hyperconjugation electron density at its para position. And we also know that 6-membered ring is free from any type of angle strain. So that minus will give electron to this carbon and it will let go that oxygen from its side. So it will be getting into the formation of that pink color structure will be as it is. So let me draw the structure as it is. Then this green ring which we have just now introduced is this carbon having this double bond O, this double bond O, and over here. Now let us check. Okay, this is a benzene and this is our A. When A is reacted with zinc amalgam and HCl, it is carbonyl group gets reduced to form alkanes. And further it is getting reacted with H3PO4. Further it is getting reacted with H3PO4. So if this structure is reacted with zinc amalgam, I have this guy and this is 1, 2, 3. Okay, this is 1, 2, 3, 4, 5, 6. Okay, it is also 6-membered ring. I guess we have done a bit of, because this is also CH2 because it is zinc amalgam, but this is H3PO4. So this, let us see the option. A option we have. Okay, no, see. After this, what A we have got, no A is, see, we have created this thing. Even if we stop over there, even if we stop over here, I can give a H plus at this point of time. So this will create a COOH group. This will create a C double. Sir, why you are saying it will create a COOH group? Because look at the options for option A. A carbonyl group, we want this, but the COOH. A carbonyl group, we want this, but we made this COOH also as carbonyl group. This is the mistake that we have done. This is also carbonyl group and COOH. This is also carbonyl group. Every A option is telling you to do, although the reagent is not confirming that. Because with reagent you will have an idea, because AlCl3 is there, so Friedel-Crafts acylation can take place again. But through option, question is guiding you that do not do Friedel-Crafts acylation the second time. Keeping that thing in mind through options, I am converting this, because even option is suggesting us that once that guy is reacting, as in, this is a good question. I mean, not, we have actually initiated with a problem, that's why. So this is a COOH, although the question is not mentioning to that extent, but with options it is helping us to think of this. Now, sir, you missed a double bond. Where? Okay, this one. Okay, thank you. Huh. So this is the double bond. Thank you. Which I missed. Perfect, bhai. Thank you. Now, after this, which is this A, okay, we can check this A also. So this should also have this double bond. This is A, na? So A should have this double bond. No option is having. Okay, I have lost that double bond completely or what? This is a carbocation, a pi cloud, COOH, A. Series B. Okay, listen. It is saying the option that we are having over here, this option, which is having C double bond C at this area, it is just reacting with anhydrous AlCl3. So let's say I have a carbocation over here. It is a resonance stabilized carbocation also. So it will be no. Actually, this will be. I guess it will be. It's a printing error. I will see. Sir, you missed a double bond. Listen. It will be a printing error because the options. I will just check this also because this no option is having that double bond over here. So I guess this will. It is succinic anhydride. See, it is succinic anhydride. Succinic anhydride is a dicarboxylic acid of 4 carbons. So this is not having any double bond. In the options, in the reaction, in the question, this double bond is a misprint. So that's why it has taken time also. This is the option we are interested in. And if we are interested in this option, then our answer is option A. This can be, I mean, any of the structure can be A. Now we have to move from structure A to moving forward. Now we are not provided with any pi cloud, so let me remove that pi cloud. This is not there. Now after that, now the question is easy. After that, I'll be adding zinc amalgam and HCl. What will it be doing? It will be converting the carbonyl group to alkane. Only this carbonyl group to alkane. So this is CH2. It will not disturb the carboxylic acid. Now the carboxylic acid effect will come into play. Now this carboxylic acid, when treated with H3PO4, so this OH will get protonated and now a carbocation will be formed, because in presence of acid the alcohol also gets protonated and carbocation is formed. Acid will also get protonated and you will get a carbocation at this carbonyl carbon. This carbonyl carbon will again now because this is hyperconjugating structure, so this C minus at para position will attack and you will get a product like this. So this is the 2-methyl group, a CH2 over here, this carbon, this C double bonded O has been just now attached with this para position because of plus hyperconjugation of that CH3 group. So this is your product, which I guess you clearly see in option B. A good question, but yes, took more time because A, the misprint of the question, B, we assumed that it is happening twice, but options, because nothing was giving us, because actually see, we have removed that AlCl3 also. Why we have removed that AlCl3? Here you have taken COOH, AlCl3 is removed, some acidification has been done. Whether the question has given acidification, no, but the question is telling you to do acidification through options, because in no of the option is question is saying that both of them are getting Friedel-Crafts acylated. So that's why through options you should proceed in some questions. Good one. Moving forward, attempt this one. I hope you got the answer. Now, major organic compound formed by the reaction of, now this is just a beta, a very traditional naming reaction. I'm not naming, but a basic reaction you should know. Ethane is this. 111 trichloroethane is this. If I react this with silver, actually alkyne, this is a beautiful method to produce alkyne, because this silver will take all these chronines. So obviously more of this in presence of metal free, homolytic fission take place. So this carbon homolytically terminating chain with another species of the similar being, and will terminate chain formation, leading to the formation of this butane. So answer will be butene, option 3. Moving forward, let us attempt this question. Sorry, hello farm. Sir, is this no beta? Iodoform is CHI3. This is not iodoform. This was 2 carbons. This was not iodoform. Okay. Who reacts with HBr at the fastest rate? Who reacts with HBr at the fastest rate? Sir, HBr will attack how? Sir, H plus will attack and then a carbocation will be formed. So more stable carbocation will be forming product to a faster extent. So who will be attacking to the fastest extent? Where carbocation formed will be most stable. Now, let us check carbocation stability. No extra stability. Yes, over here carbocation will be resonance stabilized. How? If this pi cloud hydrogen attaches over here, it will be plus. So this is lone pair sigma plus. So answer is, this is best. So answer is 3. I guess you got the point. We are moving a bit faster. So let us try the other question. This one, a very important slide for you, naming reactions. You, if you are lucky, you will get direct these questions. So what's a Schwarz reaction, sir? Schwarz reaction is when alkyl chloride and bromide forms alkyl fluoride. So ethyl fluoride, as in A can be linked with 4. So A can be linked with 4. So this or this can be correct. Sandmeyer reaction is formation of aryl halides. So Sandmeyer reaction can form cyanobenzene, absolutely right. Sandmeyer can form all the most of the aryl halides are provided. Acha, you sir can't see the wording, but I'm iterating. I guess because of the yellow texture, I'm iterating. Sandmeyer's reaction is used to form aromatic compounds. So through Sandmeyer's reaction, you use diazonium salt. That diazonium salt, when reacts with CuCN or KCN, it forms cyanobenzene. So that is also a Sandmeyer's reaction. I'm iterating that. So because of that, B goes with 3. B goes with 3. So obviously B goes with 3. So A is our answer, but I'm giving you this reaction. Woods fatigue. Fatigue involves aryl halide. Woods involves alkyl halide. So when alkyl and aryl halide reacts with sodium metal, they form alkyl benzene. So alkyl benzene is this. So C is 1. And Finkelstein reaction is from alkyl chlorides and bromides. You react with sodium iodide in presence of acetone, it forms iodobenzene. This is a naming reaction called Finkelstein reaction. So this is, option is 4. I'm sorry, options are not visible to you because of that yellow texture. So although I've iterated all those reactions. So moving to the next question. Attempt this one. Iodination. Number of isomeric product formed by monochlorination of 2-methyl butane. Okay. 2-methyl butane. This is butane. This is 2-methyl. Now, chlorination. You have to do chlorination of this guy. So, in order to do chlorination, let us at least check how many such structures can be formed. So, see, if chlorine coming at these two sides, it will be 1 here, it will be 2, 3 and 4. Okay. You will also with practice get this idea that if any of these 2 carbons, this one or this one, is having chlorine, it will be the same compound. What it will be? 1-chloro 2-methyl butane. Now, what are the possible isomers? Sir, if this guy has a chlorine, this is another compound. If this guy has a chlorine, this is another structural isomer. If this guy has a chlorine, it is another. So 4 structures I've got. But question is asking us number of isomeric product formed by monochlorination. Okay, isomeric product tool. At least you should check, because it is saying isomeric product, you should check whether it is forming stereoisomer. These are the structures possible. Let us check whether it is having chiral carbon. If you just go by the logic of chiral carbon as an sp3 hybridized carbon, or having all 4 substituted bond, differently substituted bonds, so this will be a chiral carbon. In this one, no, this is having CH3, so no. Over here, no, this will be a chiral carbon. So although there are 4 structures, but this guy will have dextro-levo, this guy will also have dextro-levo. 1 you have calculated, so 1 I will be adding. So total isomers will be 6, including stereoisomers. Total isomers will be 6. A very beautiful and a very lovely question to understand the logic of GOC applied in organic reactions. Moving forward, no, not 10. Ayush, not 10. Answer 6. I hope you got the point. Tribhuvan, answer is 6. I hope you got the point. Hello? Hello? Are we live? Are we live? Good job doing you, sir. Helpful selection. Yes, I'm trying at least to the best of our efficiencies. Okay, chalo. Let's move. Now, next question is, okay, this is again a alkane naming reaction. Anhydrous AlCl3 is a catalyst for isomerization of alkane. How to form isomers of alkane? Let's say I have a straight chain carbon of alkane. That straight chain carbon of alkane break 1 carbon. Draw all the possible isomers. Those isomers will be the product for isomerization reaction of alkanes. Catalyst is anhydrous AlCl3. For example, how many carbons I have? 6. So if I have 6 carbon, break 1, how many carbons? You are left with 5. So 5 carbon, you have 1 branch. So 5 carbon chain, no, okay, yes. 5 carbon chain, you have 1 branch. See, 2, 3, 4, 5. Whatever options, whatever possible position isomers you can form. All those products can be formed, and this isomerism is called isomerization of alkane. So answer is definitely option 2. I hope it is clear to you. Moving to the next question. Only organic chemistry this session, sir. Yes, this session we will be having only organic. Only organic. Next will be, last will be a very smaller one, because 11th physical we have done, 12th physical will be last. So let's see how much time we'll take for organic. No one is giving answers. What happened, guys? Try. Chalo. Okay, let's attempt it together then. See, obviously, this is also not a naming reaction, but a characteristic reaction of alkanes, which says if you have 6 or 7 or maybe more, 6 for after 6 it is, yes, all questions are important. Let's say if I have 7 carbon chain as given in the question. Now, 7 carbon chain can be dehydrogenated and aromatized. Sir, but with carbon we see famous compound benzene. Yes, benzene is 6 carbons. So if you take 7, the 7th will be an alkyl group. So how to aromatize an alkane having 6 or more carbon atom? By these vanadium pentoxide, Cr2O3 and molybdenum oxide. A temperature of around 500 degrees Celsius, pressure of 10 to 20 atm pressure. You can definitely cyclize and aromatize the compound to form substituted benzenes, like I have produced a toluene over here. Now, if we know just this concept, you just check, this is 1, 2, 3, 4, 5, 6, 7. This is 7 carbons. So 7 carbons, when undergoing something, forming 2 different compounds. See, both of the compounds are having benzene. Now, So obviously first I need to form aromatization. This is not doing aromatization. This can also do this. Okay, this is Cl2, so this is also not do, or this can also do, although temperature is not mentioned, but both can do. Now after aromatization, toluene is formed. Now both options are saying CrO2 Cl2, the chromyl chloride thing you are saying, and it will undergo to the formation of Itard reaction. And what does Itard reaction do? It converts alkyl benzene into that alkyl carbon becomes a carbonyl group. So what does Itard reaction do? It converts this carbon into aldehyde. This we know. Forming a chromium complex followed by hydrolysis, it forms an aldehyde. Perfect, sir. Now, after that, I see two products, sir. It is forming, that is disproportionation, oxidation also, reduction also. So this is a classic case of Kenny-Zaro reaction. So what is a reagent for Kenny-Zaro reaction? Any base. So base followed by hydrolysis, base followed by hydrolysis. So both options are same. Okay, then preferably, because it is mentioning temperature also, while it is not mentioning see, preferably I'm choosing option A because that is mentioning temperature also, or else there is some more difference. Maybe it is having some printing error also, but I guess everything is everything is same, only this is different. So I guess there will be some different option also, maybe, or else practically speaking you can use both of them. But yes, because it is mentioning temperature also, so relatively I'm choosing option. All the basic is absolutely clear. That what is the next thing that we should know? Kenny-Zaro reaction. What is Kenny-Zaro reaction? If I use a base and I have an aldehyde which is not having acidic alpha hydrogen, then what does it do? It undergoes disproportionation. So alcohol gets oxidized, aldehyde gets oxidized because medium is basic, so it will be sodium salt of carboxylic acid, and this will get reduced also, and it will form corresponding alcohol. So there are two products. I hope you got. No sir, I hope Ayush you got this point. Moving forward. No sir, as in no sir, as in guys. Okay, not clear, Ayush. हाँ, see, beta, approximations are always welcomed an option. See, 500 plus 273 is how much? 773. So, I mean, with options, you cannot be so specific and choosy, because actually, when whatever practicality are there, those are always involved with some fluctuations. So do not go by this that temperature. Ultimately some temperature around that, the other one was just mentioning heat, so that's why we have chosen. Although I am saying options will be different, there must be some printing error also. Moving ahead, I hope everything is clear now. Okay, Ayush, I got that. Moving forward. Now, this is also naturally, normally, don't worry, Ganesh, just be focused on the work, not the result. Now, alkane when undergo halogenation can do bromination and chlorination to famous extent, but iodination is very slow. Why very slow? Because the C bond I gets easily broken and backward reaction takes place. So because it is very slow, what can we do to make it fast? We can use oxidizing agent like HiO3, HNO3. They do what? They oxidize the produced HI. HI is converted to I2. So according to Lee-Chatelier principle, HI is removed. So product removed, equilibrium will be shifting forward. I2 produced or reactant added, so it will be moving forward to double speed. Therefore, this oxidizing agent can make iodination, which is a slow process, rather very fast. So option D is your answer. Moving to next question, attempt this one. Yes, Ayush, perfect. Good guys, good, very good. You people are making me proud also, yourself also. I mean, this is 17th, 18th, 19th, 20, 21. So on fourth day, so yes, this is the energy that we should have at the last day. Although students are less, but whoever are there, they are actively participating, means a lot for yourself. You just, I mean, once we've let's say 1:30, 1, 2, whatever time we reach, once you finish this syllabus, you check for yourself. After finishing, you'll get an energy. Yes, achieved something. Okay. Now, 2-methyl butane on oxidation with KMnO4 gives 2-methyl butanol. Okay. Now I have 2-methyl. I have 2-methyl butane. So this is butane at second position. It is having on oxidation with KMnO4. Sir, this is an alkane. Why alkane is undergoing oxidation? Alkane is undergoing oxidation because alkane having 3-degree hydrogen are reactive. But they are reactive only for strong oxidizing agents like KMnO4, and they will oxidize this hydrogen to form alcohol. So yes, this is right. N-alkanes can be easily oxidized to corresponding alcohol with KMnO4. This is what it is saying. So both options are correct, and it is saying both. Okay. Statement 2 is incorrect. It is saying N-alkanes can be easily. Okay. I'm sorry. I told you, no. 3-degree can be oxidized. So that was out of hurry. 3-degree can be oxidized, not all alkanes, because alkanes are generally paraffins. And paraffins means, in Latin, they means they are not reactive. So, but 3-degree alkane, 3-degree hydrogen, because its reactivity is high, therefore it reacts with strong oxidizing, not with all, strong oxidizing agent. So this is also right. And L-alkanes cannot be easily oxidized because alkanes are paraffin. So yes, option C is right. Definitely most of you have given the right answer. Good. Moving forward. Good, 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 very good. Now, this question, again a very famous preparation of NCERT. Alkyne, when heated with in a red hot tube, trimerizes alkyne, this acetylene, and on trimerization, what is produced? Benzene. I hope this first part is clear. Now, this benzene, when reacts with carbon monoxide and HCl in presence of AlCl3 anhydrous, again this carbon monoxide, carbon will attain a positive charge because of this Lewis acid. Once it attains that positive charge, benzene ring will be attacking to this particular carbon, and once this attack will be taking place after substitution of this hydrogen, it attains the character of an aldehyde, which is a basic reaction which you can use by which you can expect by symmetry also. Now, what the question is asking, number of sp2 hybridized carbon. Okay, number of sp2. So this 6 and the aldehyde one is the 7th carbon. So answer is 7. Perfect. So answer is 7. Moving ahead to next question. Try this one. Benzaldehyde. Yes. Ayush, yes. Aslam, yes, it is benzaldehyde, but question is asking number of. So it is definitely 7. Next, benzaldehyde. Yes, 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 yes. Guys, come on. Fast, fast, fast. This is 1, 2, 3 carbon from benzene ring. Concentrated, sir, again you told this. Concentrated acid alcohol forms alkene. Remember Sidzev product. So which will be major products? Sir, more stable alkene, more substituted alkene. Sir, pi, sigma pi. So this is a conjugated alkene. Where, okay, this is also a conjugated alkene. Okay, then go to, because it is showing the isomerism also. So this is a trans isomer, because if this is the carbon group, so this will be hydrogen. So with respect to hydrogen, you can say it's a trans isomer, and with respect to hydrogen, you can say it's a cis isomer. So you tell me which will be more stable. Sir, trans will be more stable. So A will be your major product. So option 3 will be your answer. Moving ahead, I hope this is clear. Now, why I have written this stereoselective reaction? When a reaction is choosy about the product formed, then it is stereoselective. And when it is choosy about the type of reactant it will react, it is called stereospecific. So such English are good for good questions. Moving forward, let us attempt this one. Which chapter going on right now? Beta, now for organic chemistry, what I have done for you is I have coupled all the chapters. Like you must have seen, you will be getting questions of amines also, aldehydes also, alkanes also, because generally organic offers question as a mixed packet. So we are discussing organic in general. That's why I wanted to take it together. That's why we have taken a break also and then starting with it. Now, I hope you, okay, options are, okay, that was the same question. Okay. Let us try this one. Which chapter going? Okay, I answered that. Now, see, guys, this is 20% phosphoric acid. Remember, phosphoric acid is an acid. So what does an acid do to alcohol? Say dehydration. What does 20% is saying? 20% is saying you do not have to take acid strong. Sir, because this alcohol is a 3-degree alcohol. Look at this carbon, it is a 3-degree alcohol. And for 3-degree alcohol, 3-degree carbocation formation is very easy. So 3-degree carbocation will be easily formed. And what product you will be forming? Sir, you will be forming more substituted, more stable alkene. So that one will be not more stable. This one or this one will be more stable. So A will be a stable alkene. So A will be a stable alkene. Yes, you can be an answer. No, yes. So 3 out of 3 and 2, 1 will be your answer. Now, when this okay. Now when this alkyl now this alkyl halide is also a 3-degree alkyl halide, but it is getting reacted with a bulky base. Now because a base is bulky, now this is the first case when SIDZEF product is not formed. Why? Because base is bulky. So bulky base cannot attack hydrogen which is sterically hindered. So bulky base will rather prefer hydrogen which is least hindered. So it will give, base wants to give electron to hydrogen, it give electron to hydrogen, and that hydrogen will be forming that hydrogen electron will be forming a pi cloud with this carbocation. So it will be a less substituted alkene, but it is forming in major quantity, so it becomes a Hofmann product. So this will be your answer. So no, your answer will be option number 3. Yes, most of you have got it right. Aslam, perfect. Moving to the next question, let us attempt this one. There are 3 reactions and you have to consider these reactions. Question is pending. Which of the following will not produce SIDZEF? Now here you have to say which will not produce SIDZEF product. This 2020 question, you have to say which will not produce SIDZEF product. I hope you got the answer. We just attempted this question only. Which will not produce SIDZEF product? Options are here. Okay, I've made this picture for you also to be quick. Now, which will not produce SIDZEF product? So this is the first, because this is an expanded view, so you can see in detail. So H plus, this H plus will be attacked by this OH will get protonated and form carbocation. Now you tell me where it should form the, sir, it will be more substituted, but it is not having hydrogen. So unnecessarily I have to, because I want to form a stable product, but that carbon is not having hydrogen. So I am forced to form a Hofmann product. So this is the case when more substituted alkene is not formed. So that will be a Hofmann product, so not a SIDZEF product. What about this one? Sir, again, it is alcoholic KOH. So this is a classic case of SIDZEF. Over here, these two will be gone and it will be beta elimination. You will get a SIDZEF product. What about this one? Sir, this is a bulky base now. Now, bulky base, although it is not at all having hydrogen, but this bulky base will also try to give electron to least hindered. So this will also be a Hofmann product. What about this one? Now, if this is gone, then ultimately this should be having most substituted product, because here alkene will be most substituted, and this most substituted alkene, by the way, is more stable also, because this is pi sigma pi conjugated also. So this is also SIDZEF product. Why? Because more substituted alkene is forming as the major product. So this is also SIDZEF product. So what the question is saying, which of the following will not produce SIDZEF product? So who is not producing SIDZEF product? A and C. A and C. Okay, A and C. Let us check the options. Okay, C. So A CH3, C CH. Let us check. We have drawn that only. CH3, C CH, which will not produce. Question is saying which will not produce Sitzef product. So that means it will produce Hoffman product. This is producing Hoffman product. This is producing alcoholic KOH. Okay, this is which will not produce its product. I guess alcoholic KOH C, which will not produce Sitzef product. So C only C will not produce Sitzef product. This is Sitzef product. This is Sitzef product. So we have to just check about this. So whether this is Sitzef. Okay, guys, listen. If you check this compound, what does Sitzef say? You have to take hydrogen of that compound which is forming more substituted alkene. It is not at all having hydrogen. So whatever product it is forming, it is which is not forming Sitzef product. So it is also Hoffman product. So this is Sitzef. Okay, that S I have written in a different, I mean, we should be very religious with writing also. This is Hoffman product, this is Hoffman product, and that is also Hoffman. This is Sitzef product, sorry. Oh my god. What about this? This is Hoffman product, this is Sitzef product, and this is also Sitzef product. Why? Because can you make an alkene over there? No, it cannot be made. It cannot be made. So only this structure is forming an Hoffman product. And question in theory it is saying of the reactions which will not produce Sitzef product. That means everybody else is producing Sitzef product. So this guy is not producing, although it can produce, but this is not producing Sitzef product. Rather, it is producing an Hoffman product. So this is an answer for us. I guess there will be some question error also in this question. So theory maybe. So let us move. I am summarizing that Hoffman thing for you. Now listen. Generally, more substituted alkene becomes major product when it does not become major product. 1. In case of alkyl fluorides, even CV takes place, less substituted alkene is formed. Case 2, when hydrogen is not present at opposite position, then also Hoffman product takes place. Third is when you have conjugated alkene. So you do not think of hyperconjugation stability because resonance stabilized compound is there. And last is when you have bulky base, then also Hoffman product takes place. So these are basically the 4 cases when Hoffman product takes place. Rest, there was a theoretical point in that question. Maybe that theory would have been misprinted. So I mean, logic we have understood. So moving forward, let us attempt this question. Now, let us attempt this question. It is saying the major product of the following reaction. The major product of the following reaction. Let us attempt this one. In first case, rearrangement occurs. Tribhuvan, no. Actually, rearrangement happens when you have okay, it was an alcohol. Okay, I do not wish to go back. My dear, 3 chairs for Tribhuvan. Yes, this is a point when when you get overworked, things move out of your mind. Actually, Tribhuvan is right. Thank you, my friend. Because H plus, once one H plus attacks this OH, it gets a carbocation, and once formation of carbocation take place, it is always the rate determining step, and rearrangement and ring expansion can stabilize carbocation. So because carbocation formed over here will stabilize when with this methyl group rearrangement, and therefore whatever product it will form, it will be forming a Sitzef product. In that case, the question is also right. Thank you. So 3 cheers for Tribhuvan, and moving to the next question. Thanks, bhai. Moving forward. Sometimes things get out of head. Methyl shift. Okay, let us check. Yes, methyl shifting. So that's why substituted product will be formed. Perfect. Okay. Answer: Alcoholic KOH, sir, NaNH2, we have recently seen this H, this Br, this H, this Br. So you will be getting this beautiful alkyne. Moving forward, option 3 is definitely right. Moving to this next question. Let's try. I hope you got the answer. Ayush? Chalo. Alcoholic KOH. Excess of alcoholic KOH. Now, because I'm having, so do elimination twice. Now, let's say this is having pi cloud, sir. More stable product will be formed. So this is pi sigma pi. So obviously this carbon will be giving H, because if this bromine is eliminated, a pi bond will be formed and that pi bond will be resonance stabilized. Point number 1. So pi sigma pi, yes. Pi sigma pi, yes. No, because it is not pi sigma pi, no. So out of 1, 3, 1 will be your answer. Now, what about this one? This is CH2 and this is also CH2. If I get a pi bond over here, this is pi sigma sigma, or else if pi sigma pi sigma pi, see, it is extended conjugation. If I get, let's say I just number it for you so that you may check that whether carbon is same or not. Let's say this is 1, 2, 3, 4, 5, 6, 7. Now let me make this thing for you. 1, 2, 3, 4, 5, 6, 7. Now you tell me whether this pi sigma pi makes it a conjugated alkene. Yes. So what is formed? More stable product. So this will be the most stable product. So your answer will be option 3. Moving forward, let us try this question. 2025 question. Try this one. Chalo, I hope you got the answer. Vivek, don't know. Okay, let's try. Now, it is saying ozonolysis followed by treatment with zinc water of cis-butene gives ethanol. Let us check. You are doing ozonolysis followed by treatment of zinc water of cis-butene. Now, this is butene and this is cis-butene. So, if I do ozonolysis with zinc and water, this is reductive ozonolysis. So what does reductive ozonolysis do? It breaks the bond and just attaches double bond O. It does not do anything with the hydrogen attached with the carbonyl group. So because this and this will be the same molecule, so ethanol will be formed. Answer. So gives ethanol. Statement 1 is definitely right. Statement 2 says the production obtained by ozonolysis followed by treatment with zinc of this has no. Okay, first let us draw 3,6-dimethyl oct. So oct is a 8 carbon, 3, 4, 5, 6, 7. This is 8 carbon chain. Then at third carbon I have a methyl. At sixth carbon I have a methyl. 3,6-dimethyl oct, 4-ene. So at 4, 5 I have a double bond. Now if I do ozonolysis of this guy, so this will be gone. So it will be double bond O from this side also, that side also. It is also a symmetrical carbonyl group. Now does it have an chiral carbon? Yes, sir. So this carbon methyl, that carbonyl group, and one will be hydrogen. So it will have a chiral carbon. So it is saying that this has no chiral. So this is false. So first is true, but option 2. Yes, Ayush. Perfect, bhai. Perfect. Moving forward. Let us try this one. Let us try this question. I hope options are visible to you. I hope options are visible to you. Okay. Now, again, a very good and famous naming reaction. This is an alkene. It is getting reacted with hydrolysis in acidic medium. So first H plus will attack. Then where carbocation will be stable? It will be stable at this position. Carbocation, Tribhuvan helped us. Whenever carbocation is formed, it is always the slowest step and hence the rate determining step. But this carbocation can't get more stabilized, so it will be more stable at this 3 degree carbon only, and OH will be attacking. Water will be attacking and OH will be getting added over here. So it will be a 3 degree alcohol. No, here is because that will be A. No, no, okay, you have only one option. So with this also you got your answer. So let us check for this one. Now this is B2H6 in PHF followed by H2O2 in basic medium. This is hydroboration oxidation. It is anti-Markovnikov addition of water. So like this is Markovnikov, OH has gone to this side, do the opposite, add to that side, it will be anti-Markovnikov. So obviously option 2 is your right answer. Do anybody has a problem with this? Attempt this one. Shiva Sanjay, sir, I know concepts and formula in physical chemistry, but in application part is very weak, sir. Sir, for this level can improve by watching this lecture. Yes, beta. In fact, we have discussed a lot of question in which even we discussed, because 200 questions if you discuss, obviously takes energy. So you can definitely watch it maybe 2 times so that you revise it well. Let's attempt this one. Who has the answer for this? The final product formed in the sequence. Okay, B, C, D. Answer is okay. I've kept a space for this. That means this question needs to be discussed. So let us discuss. Okay, people are saying option 4. Let us try. Now this is an alkene. Reaction with BH3 followed by H2O2 in basic medium. This is anti-Markovnikov addition of water. So this guy will be forming anti-Markovnikov addition of water as in phenyl CH single bond CH2, and this will be getting OH, and this is anti-Markovnikov addition of water because Markovnikov will be creating OH over here. Done. Now with HBr, sir, HBr will do what? Sir, HBr, H plus will come and this will be forming a carbocation. And once carbocation is formed, now remember 1 degree, this is straight chain. So for 1 degree alkyl halide is not 1 degree carbocation is not stable, it is unstable. So why 1 degree form? Rather do SN2. As soon as it is getting protonated, Br minus will come because it is least hindered. So why thinking of SN1? Because it is least hindered also, and 1 degree. Why 1 degree will be forming? 1 degree is not at all stable. So Br minus will be attacking in the same step only. That's why it is precisely telling you to do anti-Markovnikov addition. So if it has done anti, so this is the feeling of the question that Br minus will be coming from that side only. So Br will be attached to that carbon, and after that, let us form that Br product. After that, Grignard reagent. We are reacting with magnesium. So if we react with magnesium, so magnesium will come in between and it will become Grignard reagent. And now this Grignard reagent, this will behave as R minus because magnesium is plus, carbon is minus, and this minus will be attacking this carbonyl carbon. So this minus will be attacking this carbonyl carbon. So this CH2 having double bond O, after hydrolysis it becomes OH. And why? Because this carbon chain has attacked this carbonyl carbon. Which carbon? This carbon. So let me draw that carbon with a pink color. So this carbon, then again a carbon, then a phenyl group. So answer will be phenyl 3 carbon and OH. Phenyl 3 carbon and OH. Option 4 is right answer. Moving forward, I hope it is clear. Most of you are giving 4 also. Sir, up to what time you will be taking up the class? Beta, at least 1 more hour. Maybe 1.5 hours. Let's see. Because we need time, because we are discussing the complete chemistry, so we need time. So now coming to the next question, let's try this one. I hope it is clear. 3-methyl hextwine on reaction with HBr in presence of peroxide forms an addition product A. The number of possible stereoisomers for A. Any answers? All reagent function cheat sheet, sir. Don't know. Beta, cheat sheets, yes. First, let us discuss this, then we'll come back to that. Now, let us draw the structure, guys. The question says 3-methyl hextwine. So, hex is a 6-carbon chain. Hex2 is as in double bond between second and third carbon. 3-methyl as in this one. If this is reacting with HBr in presence of peroxide, so this is Markovnikov anti-Markovnikov. So anti-Markovnikov says if we would have been doing Markovnikov, here Br will be getting, but now we'll add Br in the another carbon. So what will be our product, guys? Br here, because this is anti-Markovnikov, because this is peroxide, forms addition product A. So I've got A. The number of possible stereoisomers for A, for number of stereoisomers for this A. Now let us check it, what chiral carbon it has. Yes, this is chiral because one is CH3, one is this group, one is Br, one is H. This is CH3, this is some other 2 carbon, this is 4 carbon, one is S. So it is having 4 carbon, nothing else. Because it is having 2 chiral carbon, so each chiral carbon will be having dextro-levo. So total isomers will be 4. Dextro-levo because of this, dextro-levo because of this. So answer will be 4. Not 5, Ganesh. It will be 4. I hope it is clear. I hope it is clear. Hello, hello, hello. 3 watching now. Hello, guys. See, you have to be, you are the reason which is keeping us alive. So in order to keep us charged, at least keep responding. So Vivek, Ganesh, Vivek has given 4. Perfect, Vivek. Good, good, good. Ganesh, it is not 5, it is 4. Let us try this question. Attempt this one, guys. Now, this is also a similar type of question, I feel. See, B2H6, H2O2. Sir, again, I know OH will be over here. This will be after PCC, it will be converting to 1 carbon, 2 carbon, 3 carbon and an aldehyde. And with Grignard reagent, this CH3 minus will be attacking to this carbon and it will be becoming OH. So it will be 4 carbon and an alcohol. So it will be 4 carbon and an alcohol. 4 carbon and an alcohol in the middle one, because this will be creating a methyl group. So it will be 4 carbon. In the second carbon it is having OH. Perfect. So answer is option 3. Moving forward. Yes sir, yes sir. No one has written option 3. Okay, you are responding that you are live and active. 3. Perfect, Vivek. Perfect, Ganesh. Good, yeah, guys. Good. Even one of you are learning few percent, then also this is all work done. This is all good. This is all worth it. If your marks, one of you is getting benefit from it. Now, let us attempt this one. Now, it is saying this is reacting with alkaline cheminophore in presence of heat. Now this is, again, I have told you, I have started a complete organic. This is direct aldehyde ketone, carboxylic acid. When you have alkyl benzene, then except 3 degree carbon, alkyl carbon next to a benzene, every other carbon gets oxidized to form what? To form corresponding carboxylic acid. As in, if you just check this is a 2 degree carbon. This, if you just check the degree, it is not 3 degree. So if you are not 3 degree, every carbon attached directly to benzene gets oxidized to corresponding benzoic acid, leaving all the carbons. I mean this C bond C also, because this is a strong oxidizing agent. So this carbon also becomes CO2. the COOH, this also becomes COOH, and why this carbon will be remaining, this will also become COOH. So this same structure will have COOH, COOH, COOH is the action of the strong oxidizing agent on the carbon just beside a benzene. So I hope you can see the structure. Option 2. No, 4. Acha, 4 people are maybe saying answer for the previous. So answer is 2. I hope it is clear. Moving forward, let us try this question. Let us try this question. Now, this alkene is reacting with cold and hot. Now, for cold, I guess you know through NCERT that H2SO4 is also having H plus and some HSO4 minus. So if this alkene is getting reaction with H2SO4, first H plus will attack and then the minus. If H plus of H2SO4, then what minus is left? HSO4 minus. So H plus will be attacking here because here carbocation will be relatively more stable. So this will be getting HSO4 minus. So let us check. A will be some bisulfate product. A is bisulfate product. No. Yes. No. So these two are gone. Either this is right or that is right. Now, if you just check option B, from the option only you will see, if you just check option B, this is saying an alkene. Alkene forming an alkene. Let us check this one. Sir, alkene forming a big structure. See, I mean, this is a good question, but common sense is very good. Common sense is very basic. What I'm saying is, first H plus, sir, we'll be attacking H plus. Okay. Gone, carbocation formed. Okay. Now, if this is a carbocation and you have heated the mixture, then what can take place? Sir, because we have heated the mixture, so this carbocation is electron deficient. It can attack with higher kinetic energy. It can attack another molecule of the similar type. It can attack another molecule of the similar type, as in this carbocation. I just make this carbocation again. CH3, CH3, CH3. This carbocation can attack a molecule of like this only, as in this carbocation can attack a molecule of the same format. How? See, you can check this option also and this option also. Now, if we know that this is a carbocation, then what can you suggest? Sir, plus, because this is H2SO4. So this plus can attack, this pi cloud can attack this, and where carbocation will be more stable? Sir, carbocation will be more stable here only. So let us combine these structures. I'll just draw a smaller structure over here. This yellow one over here, this is the yellow carbon. It is recently being attacked by the white one. From which carbon it will be getting attached? This one. So this carbon, this guy, because it will be happy to take this positive charge. Now, after that, deprotonation can take place because heat, obviously heat is there. So after that, you again form alkene. So how deprotonation you will suggest? Sir, not stable, not stable. Yes, sir, good stable. So this hydrogen will be taking electron from any base, and its electron will be given and a pi cloud will be coming over. So this is 3 carbon, second carbon and double bond. So 3 carbons, as in this tertiary butyl, this double bond and this methyl group. So this makes option 1 a very beautiful question for us. I hope you got the answer. Moving forward, good question. It was a good question. But logic, if you keep with yourself, you can predict through using options. I hope we are on the same page with that. Now, the another question, Vivek is saying A, Vivek is saying A. Okay, it is just asking Markovnikov and anti-Markovnikov. So A. This is alkene, ha. This is mercuration and demercuration. It gives a Markovnikov product without rearrangement. And this is hydroboration oxidation, gives anti-Markovnikov product. This we already know. So one is Markovnikov, another one is anti-Markovnikov. A is Markovnikov, B is anti-Markovnikov. Option 3. Why 2-1, guys? This is okay because this is Markovnikov addition and this is anti-Markovnikov addition. I hope we are clear with this. So A is a Markovnikov and B is anti-Markovnikov. Hello? Vivek said C. Okay. Moving forward, let us try this question. Let us try this one. Now, this question is asking us that we have to make the attack of 2 moles of HBr. Now, how 2 moles of HBr we are supposed to think? Sir, if first mole of H plus, let's say first H plus will be attacking here. So this one is a 2 degree carbocation, this is a 1 degree carbocation. Which is more stable? So 2 degree. So obviously I'll form a carbocation over here because this is more stable. Now let us check for this one. If H plus is attacking at this particular alkene, what will be? Sir, here it will be carbocation closer to electron withdrawing group. It will not be formed. So here it will be comfortable at this carbon. So these carbocations will gain the Br minus. So let us check the option. Br minus on the second carbon. No. On the second carbon. Yes. And Br minus on the first carbon. So yes and no. So answer is option 2. I hope you got your answer. 3. Option 2, guys. Hello. Okay. Option B. Moving forward. Vivek, you are doing every option. Don't do like this. Guys. You are doing 2 also, 3 also, 2 also, 3 also. Okay. Those who are studying, I'm asking, is it okay? Can I move forward? Hello? But hydrogen is less on second position. Sir, why not 3? Okay. Let me go to that question. See beta. This is HBr first. I have let's say H plus attack. So this is a carbocation. It's a 2 degree carbocation. If carbocation comes over here, it cannot be stable because this is carbonyl group, electron withdrawing group. So obviously it will be forming to the farther distance so that it cannot impact, destabilize the carbocation. So here this one will be having stable carbocation and this one. So Br will be going up accordingly and this will be your product. Is it a problem now? Yes, sir. 2 is only okay. 2 is only okay. Okay. Perfect, guys. Let us attempt this one. Tribhuvan. Okay. Let us attempt this one. Okay. Options are here. Okay, I guess this is an doable question because we have been doing this question a lot. So this is an alkene reacting with X. This is double bonded O on one side. So that means this carbon is having that double bonded O. Here also it is getting formed. Here also it is getting formed. So what are these X and Y reagent? This will be creating, this CH2 will be creating point of difference. Now options are saying if I have KMnO4 dilute, then cold, aqueous and dilute KMnO4 does not, it is Bayer's reagent, it does OH. It does not break the complete bond and do carbonyl bond, carbonyl oxygen. So KMnO4 can't be there. KMnO4 dilute can't be there. So 1 and 3, that's why gone. So what we are left with, it is either strong oxidizing agent or ozonolysis or strong oxidizing. These are the options we are left with. Now if it is ozonolysis, then this will be CH2. If it is ozonolysis, then this will be CH2 double bond O. And if it is strong oxidizing agent, then this C double bond O will, strong oxidizing agent will oxidize to this side also of the hydrogen. It will be forming CO2 and H2O for strong oxidizing agent is what I'm saying. Now The question is saying that the byproduct, it will give the detail through byproducts. It will saying oxidation of A, oxidation of this guy, gives substance produced by ants. That means it must be one carbon aldehyde. If you oxidize this aldehyde, it will form formic acid, which is given by ants. That means A is this. That means X should be ozonolysis, not complete oxidation. So X is ozonolysis and Y is using strong oxidizing agent. A very good question using common sense. I hope it is clear. Tribhuvan, other people? Tribhuvan just wrote something. Okay. Guys. Hello. Yeah. Motivate yourself, because the night before examination, this is the night before your examination. Are we together? Hello. Okay. So thumbs up will also do. Okay. Okay. Now, let us try this question. Santosh, thank you. Now, this alkene is reacting with such species to form, okay, this carbon is as it is, and this EH2 is converted to aldehyde. Okay. So PCC reacts with alcohol. This is not alcohol, so leave this. Ozonolysis form double bond. This carbon will be gone, so leave this also. BH3 as in hydroboration oxidation, so OH will be coming to this carbon because anti-Markovnikov addition of water. Followed by PCC. If PCC is there, then it will become aldehyde. Yes. So this will be your answer. HBr will make bromine because it will be Markovnikov addition, so it will create bromine at this carbon. We do not want that, so obviously we got our answer. Answer is option 3. Moving forward. Ayush is back. Missed you. Although Santosh, Tribhuvan, Vivek is now okay, gaining momentum. Okay. Let us check this one. Now, the stereoisomer that are formed by electrophilic addition of bromine. No. I have a keyword to make you remember this. Now, how does bromine attack to an alkene? First, Br plus attack and forms a cyclic cation. And because bromine is a large molecule, so Br minus attacks from the opposite side because it cannot approach from the same side. Bromine is already very huge. So actually, addition of Br is anti-addition. Addition of Br is anti-addition on alkene, and whenever on a alkene anti-addition is done, and when the product formed is a symmetrical product as in like I have trans-butene. So let's say first look at this butene transform. So when it is reacting with Br2 as in bromine water, I told you it is anti-addition. So do not look at the structure like this. Look at the structure like without looking at its stereochemistry, because bromine if added, just look at the product. You can number the product from this side also 1 2 3 4, from that side also 1 2 3 4. Such a product is a symmetrical product. You can number from this side also and from that side also. When a symmetrical product is formed, and if it contains a chiral carbon, then the optical activity can only be determined through experiments, and we have done those experiments, and for that experiments I have a keyword for you to learn. Whenever anti-addition takes place on an alkene and such a symmetrical structure is formed, then the product, although containing chiral carbon, is optically inactive. But optical inactive due to what? Optical inactive due to formation of, the keyword for you to remember this is team. How to remember it? In case of trans isomer, E is for nothing, it's just a rhyme for me. In case of trans isomer, if you do anti-addition, Br2 does anti-addition. So what product is formed mesoform. You are optically inactive, but you are optically inactive. Why? Because you are forming no racemic mixture, Tribhuvan. Mesoform. How to remember this? With the keyword team. What is its rhyme? When trans with transalkene on anti-addition, mesoform is produced. And conversely for the other things. So let's say if I have cis and if I do anti-addition, then I get racemic mixture. Okay, so team is what I remember. I mean, I like the word team, or else, yes, Vivek is saying you should write TAM. Okay, I like the word team. You can remember it by TAM only also. Now, what is a racemic mixture? See, here bromine will be on same side, because this way it will have a plane of symmetry. So molecule will be asymmetrical. Molecule will be symmetrical along this plane of symmetry, and this compound will be optically inactive because of racemic mixture. So how many? Two products will be formed, because bromine can attack from this side and then followed by here. It can attack from that side followed from here. So two products will be formed, but both the products will be mesoform, so optically inactive due to mesoform. So answer will be beautifully option number 1. Moving to, I hope it is clear. Moving to the next question. Sir, meso compound, can you explain? Meso, I'm again explaining you. See, what is a meso? I have chiral carbon. This is a chiral carbon 1, this is a chiral carbon 2. A mesoform is such a compound which, when broken along a plane of symmetry, is broken into two equal halves. Let's say if this bromine and this bromine are on opposite side, then it is not a mesoform. In fact, it will be an optically active compound. So this is a mesoform, right? Okay, moving forward. Let us try this one. Try this question, guys. Sir, I have JEE Main on 20th. What according to you I should do for chemistry till then? Beside the paper discussion of beta paper discussion, and wherever you feel you are losing logics. See, chemistry should be on your tips. Like for reaction of that, you should do that. For reaction of, learn your basics well. How to do it? Pick a chapter which you feel you are not comfortable with and revise that. Else, have a general revision like this. Or if you know your loose points, work on those loose points. Okay, now the next question says an organic compound A C4H8 on treatment with KMNO4 yields compound B. Compound A also yield B on ozonolysis. Okay, I guess this is quite easy. Should it have two chiral center? Yes, obviously, beta. If bromine is attacking at two position, you are saying for the cis trans one, so obviously it will have two different chiral carbons, and if it will have two different chiral carbons, then only it can produce a mesoform, right? So definitely. Now I guess now we should move to the next question. An organic compound A C4H8. Now looking at this, I can clearly say it is an unsaturated with DU1, because 4 2 8 plus 2 true hydrogen is less, so this DU is 1. On treatment with KMNO4 yields B, which is C3H6. Now 3 carbon should have 3 2 6 hydrogens. That means this O is a double bonded O, then only valency will satisfy. This O is a double bonded O, then only valency will satisfy. And this carbon is definitely attached with some carbon. And how many carbons? 3. Now, if first carbon is this, second carbon is this, it can either have an option, I can attach a carbon here or here. Let us read the complete question. Compound A also yields compound B on ozonolysis. Now, compound A, this compound also yield compound B, which is we are going to on ozonolysis. Now, if I react you with KMNO4 or I do ozonolysis, it is saying in both the cases you will form the same compound. That means this compound, this carbon should not have hydrogen, else with KMNO4 it would be getting oxidized. So question is saying this guy on KMNO4 also and on ozonolysis also this compound is same. So because this compound is same, therefore this carbon should be here only. So this C3H6O we have obtained is this, which is B. And if this is B, so I need one more carbon. So if I have one more carbon, this is CH2. So obviously this will be having double bond O, and if I remove these things, then I'll get my product. I mean reactant, as a matter of fact. This will be attached to this carbon, CH3. So this is structural identification. So can you tell me what is its name? Yes, definitely. This is 2-methyl-propanene. This is 2-methyl-propanene. So option 1 is your answer. Moving to the next question. Let's try the another question. I hope you got your answer, beta. Trans sync, right, sir? Yes, trans syn racemic mixture. Do everything conversely. Just remember team and do everything in opposite, on that context with opposite frame. Right now I got little bored of chemistry, so going to revise maths, and I'll later attend this lecture from here. Okay, beta. Sonali. Yes. Okay, Sonali, we have, see, Ayush has passed the baton to Sonali. I guess now Sonali has started answering. So yes, others also, Vivek, Tribhuvan, all are being active. So this is great. Now, answer is Sonali is saying 2. Anybody else? Chalo, let's start. So this is HBr in presence of peroxide, and this is COF2 metal fluorides. Sir, HBr in presence of peroxide does what? Does anti-Markovnikov addition of bromine. Anti-Markovnikov addition of bromine, as in bromine, sir, alkene, benzene is a stable pi cloud. So bromine will be coming here, hydrogen will be coming here. This is anti-Markovnikov addition. Now this will do Schwarz reaction. So this bromine will go and this fluorine will come. Aryl will remain as it is because aryl hydrides are not reactive. So bromine as it is, bromine as it is, bromine as it is. This option gone. And no pi. Okay, this is option 4. I guess this is quite clear. Sir, is this Itard reaction? No beta. This is not Itard. This is Schwarz reaction. I hope we are clear with this. Hello. Chalo, moving forward. Let us try this one. I guess this is also a similar question. I have HCl. This reactant is reacting with HCl. Now you tell me, if HCl is reacting, again pi cloud will attack H plus, forms a carbocation. Where carbocation will be stable, sir? Here it will be closer to NO2, electron withdrawing group. Here it will be closer to OCH3, at least plus R, although it is not conjugate system, but still OCH3 will apply less minus I. So carbocation here will be relatively more stable. So this will get Cl. So what I'm suggesting is, this is OCH3, this is NO2, and here I will get Cl. Now with NaI and acetone, this is Finkelstein. Okay, this is repeat you're saying. Well, let us check. This chlorine will be replaced by iodine. So A is chlorine. Yes, this is right. And B is replace this chlorine by iodine. So this is B. Answer is option 2. Yes, Tribhuvan. Perfect. Moving forward, let us try this one. I guess this is also. Hello? Guys. Is it clear till this point of time? Shall I move forward? Chalo, let's try. Now, this is a reactant, and two, we are making a reaction that twice of HBr. So again, sir, 2 HBr, so twice carbocation will be formed. So let us check that carbocation. This carbocation will be a more stable 3-degree carbocation. This carbocation is closer to electron withdrawing group, so not be formed. So here it will be formed. So one Br will be coming here, another Br will be coming here. So one Br at CH3, yes, no, yes, but here one Br will be over here. So this is wrong. This is wrong. So I guess you got your answer. This will be your right answer. Perfect, Tribhuvan. Answer is option 4. Moving to the next question. This is also quite simple. This is plus R electron donating group. This is minus R electron withdrawing group. This Hg plus 2, but I am doing hydrolysis. So what it will be doing? It will be doing, after mercuration does formation of carbocation, but demercuration reduces it. So if I do not reduce it, what I'll get? A carbonyl compound. But where it will be formed? Where you will be having more of stability in carbocation. So which carbocation will be stable, sir? This carbocation will be stabilized because this carbocation is stabilized by plus R. This will be destabilized, this carbocation, because it is by minus R. This will be getting OH doubly 2 times. So OH coming 2 times will give you the carbonyl group. So carbonyl group will be at this particular carbon. So I guess option 1 is clearly seen is your right answer, because this is keeping in presence of NO2, which is wrong. NO2 wrong. This is right, but it is changing this also. Why this will be changing? This will be just OCH3 only. So because it is just OCH3, so answer is option 1. Sonali, Vivek, AKY, it is option 1. I hope we are on the same page in this question. Shall we move forward? So that was a 20 and it was option A. Done? Perfect, 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 perfect. Now, what about this one? Sir, this is also, this is aryl halide, this is aryl halide, so no reaction. This is simple alkyl halide, and this is AgCN. So AgCN is a what salt? Sir, it is a covalent salt. So covalent salt will not ionize. So where you find electron richness on this nitrogen, so this will be attacking and isocyanide will be formed. Perfect. Many people are saying C. Perfect, 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 guys. Very good. Perfect, guys. Very good. Next. Next. The correct arrangement for decreasing order of electrophilic substitution for above compound. Now we have to do electrophilic substitution of these compounds. So what is correct? Sir, electrophile as in E plus will attack where? Which will have most electron density. Which has most electron density? Sir, this is plus R. So this will be most. Then this is CH3. So 3 and 1. So 3 and 1. So obviously option 1 is your answer. Perfect, Vivek. Moving forward. Perfect, Vivek. Moving forward. Moving forward. Perfect. This one. Now, the major product formed in Friedel-Crafts acylation of chlorobenzene. Okay, so I am having chlorobenzene. So this is simple. Friedel-Crafts acylation of chlorobenzene will form major product as para product. Perfect. D is your answer. Let us try this one. Let us check this one. Now, order of melting point of dichloro. Now, melting point, what melts? Solid. Which is most effective packed solid for di? Sir, para, because para is more symmetric. So para is having highest melting point. After that, ortho. Why ortho? Because in general ortho the polarity is more, because polarity is mu1 mu2 mu1 square plus mu2 square plus 2 mu1 mu2 cos theta. So here cos theta is less, here cos theta is more. So generally ortho has more polarity. And why para has maximum melting point? Because as a solid it has perfect symmetry. So answer is a very beautiful option. Perfect, perfect, guys, perfect. Moving to next question. This JEE 2023 question. In the above conversion of compound X to product Y, the sequence of reagent will be: first, you think of removing this NO2, because if this NO2 is removed, then also bromine, then only bromine will be coming. So NO2 will be removed by, sir, we know metal in presence of acid reduces nitro groups and forms aniline or amine. So 3 and 4 got our interest, where NO2 becomes NH2. Now once you have Br2, once you have Br2, what does Br2 do? NH2 becomes, if this changes to NH2, it becomes activating group. So because its para is blocked, so it will get excessive of these bromination. So these bromine job is done, but now I want to remove this NH2, because here it is having hydrogen. So how to remove this hydrogen? Yes, 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 yes. So nitrous acid will first make it diazonium salt, and then H3PO2 will give hydrogen and reduces diazonium to form H. So answer is definitely D. Perfect, guys. Very good. Very good. Very good. Generate the world. Perfect. Generate the world. You are generating the world for us. Good. Huh. This one now, DMF shows a solvent which is non-polar solvent, and non-polar solvent signifies what? Non-polar solvent signifies SN2. SN2 is what? Inversion of, yes, SN2. Yes, perfect. And who is the nucleophile? Sir, phenyl with S minus. Where it will go? Sir, aryl? No. Nitro? I mean, no, because these are all aromatics. So this I will be replaced by this, and this wedge will be replaced by a dash. So wedge by a dash with SF4s. Option 1 is right. Moving forward, this 2024 question attempt. This is also quite easy. Phenol with zinc forms benzene. So A is 3. So A is 3. These two can be right. They are gone. Phenol, chloroform and NaOH. Phenol, chloro is Remertiman reaction forming salicylaldehyde. So B is 1. So B is 1. This is definitely right. Phenol with CO2 and NOH is, I'm repeating, I got this is yellow. Phenol with CO2 is Kolbe's electrolysis, Kolbe reaction. Kolbe forms salicylic acid. And then phenol with concentrated HNO3 will give you picric acid. Okay, I'm just repeating the option. This is a classic reaction. So although I'm sorry, this, because of yellow color it was not visible, but I'm repeating those. Moving to the next question. Try this one. Try this one. Again, I guess it is also quite clear to you. This is Br2. Now, phenol is an activating group. So Br will be getting added because this is deactivating. So it will be happening as per OH. Then with hydroxylamine, you do what? Sir, hydroxylamine with aldehyde will form oxime. And this oxime, I just remove this and it will form an oxime. Now, this oxime P2O5 is what? P2O5 is a perfect dehydrating agent. P2O5 is a perfect dehydrating agent. It does dehydration. So dehydration, remove, sir, OH. I mean, just remove water. So what you will be left behind? Sir, cyanide. Remove water, you will be left back with cyanide. So answer 4. A very beautiful question. I hope you got this point. Moving forward, let us attempt this question. I'm bit increasing my speed. Yes, Vivek, very good. Attempt this one. Okay, so this is just a naming reaction, which is again Remertiman reaction, where chloroform in presence of NaOH reacts with phenol, and the attacking species is dichlorocarbene. This carbene is the attacking species. Here, because this in presence of basic medium, this becomes phenoxide ion, and at ortho position electron density is increased. So this ortho position attack this, because at ortho position the electron density is also high and the product form is also resonance stabilized. So ortho product becomes major product. And what is the intermediate? The question is asking about that intermediate only. So this will be your intermediate, a very famous NCERT fact. Moving to the next question. Let us attempt this one. This 2024 question. I hope this is also a very famous question of ether, which you can. How many questions left, sir? Bas beta, we are just moving from this. We will move to very quickly to physical chemistry, and then we'll be finishing till 1 p.m. In 50 minutes we'll be covering. Okay, so let us finish a bit faster. Now, this is the lone pair. This is the lone pair. So lone pair will be attacking this H plus. Now, after this protonation of ether, you can form carbocation here also, here also. Where carbocation will be more stable? So 3 degree. So 3 degree carbocation will be formed, and this will form OH. So this will form OH, and that will form a 3 degree carbocation. So option 4 will be your right answer. Moving forward, let us try the next question. Perfect, perfect, beta. So no, option 4, Santosh, not option 2, option 4. What about this one? What about this one? Now, sir, this is an alkyl halide, and this is a succinic anhydride. So potassium salt of succinimide. On the Gabriel Thelimide reaction, you must have seen this. So this minus will be attacking this carbon, and this bromine will be getting out. And once in basic medium, it will be undergoing this bond cleavage, and it will lead to the formation of 1 degree amine. So what is the 1 degree? It will be gone, and this CH2 will be getting this NH2 as 1 degree amine. So where you are getting that 1 degree amine, sir, this is classic case of Gabriel Thelimide synthesis. So option 4. Option 4, not NBS beta. This is not, this is N-bromo. Okay, yes, N-bromo succinimide. Yes, N-bromo, but that was succinic acid beta. So if you say NBS, we are precisely speaking of succinimide, but this is thelimide. This is thelimide, thalic acid derivative. So not NBS exactly. So option 4 is your right answer. Moving forward. This is quite easy question, although the structure is quite difficult. Br2 in sunlight does allylic substitution. This is the only allylic carbon you have. So this is the allylic substitution which it will result, and that is our answer. Moving forward directly. Now, this is also a basic question for SN1. So which will do SN1 fast, sir? This is benzylic carbocation. This is benzylic, and it is plus R also. So this is more stable benzylic carbocation. So most is C, then is D. You are asked increasing order. So fastest is C, then is D. Now, what about A and B? So because here at least some rearrangement can take place. So A will be better and least will be B. So least will be B. Option 2 is our right answer. I'm moving a bit faster. Now, let us attempt this question regarding aldol condensation. Attempt this one. Let us attempt this aldol condensation question. On only aldol, then I'll be skipping some questions because obviously we have to go to physical chem, because all the questions of organic, we are also doing organic from quite a lot time. So let us do some aldol questions basic, and then we'll directly jump to physical. Physical as in the coordination chemistry type of questions. So first let us do this one. Now, when this undergoes intramolecular aldol condensation, the major product is, okay sir, intramolecular aldol. Okay, now actually this is aldehyde and this is ketone. Who is more prone for nucleophilic addition? Sir, aldehyde. Who is more to nucleophilic addition? Aldehyde. So this will receive the attack. Now who will attack? Let's say if this carbon attacks, it becomes a 1 2 3 4 5 6 7 member ring. And rather, if this carbon attacks, it becomes 1 2 3 4 5 member ring, because I have counted that one. Now you tell me which is a more stable ring. 7 is a crowded ring, although Bayer's stem is also minimum in 7 also, but 5 is not crowded also, although 6 is best, but we are having option of 7 or 5. So we will be falling with option of 5. So if 5 membered ring is formed, then this 5 membered ring will from after aldol it will attack, it will become OH, and then dehydration will form alpha beta unsaturated acid, unsaturated carbonyl compound. Where is the carbonyl compound? This is the carbonyl compound. So with that carbons, first carbon, 2 carbon chain will be there, 2 carbon chain will be there, and a carbonyl group will be there, which will form a functional group. This is alpha carbon, this is beta carbon, so this is alpha beta unsaturated, this is alpha beta unsaturated aldehyde or ketone. I hope you got this point also. I am moving forward to the next question. Now again, this is an aldol condensation logic. Remember me, sir? Yes, England test, I remember you. Beta, please participate and let us finish it as fast as possible. Now this is KOH. Now sir, KOH does what? Sir, remember the Cannizzaro reaction. So actually OH minus attack to whom? To that carbonyl group which is having more extent of nucleophilic addition. So actually this is aldehyde, this is also, although this is ketone by the way, but this carbon is an electron withdrawing group. Who is electron withdrawing group? Carbonyl groups. So benzene will be acting as a plus R group for this carbonyl group. So positivity is obviously decreased. So actually who is the most prone carbon for nucleophilic addition? This carbon as in the carbon of aldehyde, this one. So this will receive the attack of OH minus, and whoever receives the attack of OH minus converts into acid and forces the other one by releasing its H minus to become alcohol. So this one becomes alcohol and this one becomes acid, but because medium is basic, so salt of acid will be reported. So answer will be phenyl, then alcohol and salt of acid. So salt of acid, but this should be alcohol. So answer is option number 2. No, Vivek, option 2. I hope. Hello guys, I hope we are clear till this point of time. Okay. So let me, so we have discussed these questions. I mean, okay, let us try some organic. We have discussed few questions. So I am directly jumping there. Now directly jumping to some questions of carbonyl compounds. Yes, because I just wish to go to the last, because physical chemistry questions of last solution electrochemistry, those are some basic questions which I want to discuss and I feel we should wind up. So I've skipped some questions just for the fact that they are just, I mean, if we would have more amount of time we would have discussed more, but obviously we have discussed a lot of questions. So moving slightly faster. Now let us attempt this one. Sir, don't skip questions. Beta, we'll come back to it, but at least I want to just go to the physical side also. So just few I have skipped because obviously I have taken more than 200 questions, so trying to push it a little faster. Now the complex cation which has 2 isomers. Now coming directly to coordination chemistry, because these are questions which are very famous. Now sir, all are metals. Agreed. Sir, if all are metals, then what are the type? Sir, as you are doing. Okay. So what are their type? Actually, their type is, this is Ma6, this is Ma5B, this is also Ma5B. So whenever so many number of ligands are same, they cannot show any stereoisomerism. So, but the question is saying which of the following has 2 isomers. Sir, then you should think of structural isomers. So, if you see this NO2, then this NO2 can act as an ambident ligand, where NO2 can ligate from nitrogen also and NO2 can ligate from oxygen also. So, this makes it an ambidentate ligand which will create linkage isomerism. Therefore, this will be your answer, which will be having 2 products. I hope it is clear. Let us move to the last question for this. I mean, not for this. I have one more slide with me, which is for physical chemistry and the last chapters. Now, A question of biomolecules. Take full. I'm taking full only, beta. I'm just moving to physical side of chemistry, because organic, I have assembled and combined so many questions that they are more than sufficient for us to uh, remember stuff. Now, the incorrect statement regarding this is a biomolecule question. Let us try this one. The statement in regarding the given structure, this is the structure, and we know this is OH. So this is beautiful case of alcohol. This is beautiful case of alcohol. So because it is alcohol, what alcohol? Glucose. This is also known as hexose sugar. So this glucose, there are some points. It can be oxidized to dicarboxylic acid with Br2. No, with Br2 it can form gluconic acid. So only aldehyde will get oxidized, alcohol will not get oxidized. So this is incorrect. It is asking incorrect. So I guess we got our answer, but checking other options also. Will coexist in two cyclic forms? Yes, it is anomeric form, alpha glucose and beta glucose. Despite the presence of aldehyde, it does not. Yes, because of the muta rotation, the ring opening and closing of this alcohol and carbonyl group, so that anomers are produced, the alpha anomer and beta anomer. Therefore sometimes aldehyde is not free to react, so it does not show Schiff's test. And has 4 chiral carbon. Yes, we can clearly see through the Fischer projection it has 4 chiral carbons. So definitely yes, it is our structure. What is incorrect regarding this? Option number 1. Now we are left with the last set of presentation, but I will be just taking 5 minutes for that. So just taking last 5 minutes break, and with just 5-minute break I'll be coming back. Okay, so this is 12:18, so we will be back by 12:25. No, not 12:25, 12:24. 12:24. This I'm saving for you. Take a water break. 12:24, exact 12:24. This is 12:19. Come back at 12:24. Come back at 12:24. I'm also going, but just just checking the number of slides which we are to. Okay, 12:24. So 12:24 p.m. we will be back. Last break, guys. So 12:24. Vivek, 12:30. Vivek, the sooner we'll start, the sooner you guys can also work for your benefit for the revisions. So 12:24. 24:25. 24:25. Because even I want time. Yes, let's start. Okay, good questions you brought, sir. Thanks a lot. These are the actually conclusions. I mean, these are the points which helps us as a teacher. So thank you for appreciating, but my greatest appreciation would be your working to the best of your efficiency, your result. So let us again welcome back, and let's move to the last slide. Obviously the WhatsApp channel, you can see. Yes sir. Yes beta. Yes Vivek. Yes Vivek, tell me. Yes Vivek. So we are starting, and we have discussed so many questions of organic also. So I'm directly now moving to some questions of inorganic chemistry, like uh, and inorganic and physical. So these are the last few selected questions. I mean, there are like 36, 37 questions, so we'll be doing these questions so that we gain the confidence whatever topics are left for us. Now the first question is oxidation state of iron in complex. Okay, now brown ring, this is also some question related to practical organic chemistry. So brown ring, actually nitrate ion gets detected due to the formation of a brown ring, and brown ring is formed due to the formation of this complex, which is having coordination number of 6. This is nitrosonium. Here Fe is in +1 state, NO is in +1 state, and therefore overall the charge on the compound is +2. So this is the complex which results in the formation of this brown ring. And if you check this brown ring, then what is the oxidation state of iron? The oxidation state of iron is +1. So this is a very famous brown ring text. This is nitrosonium. This is nitrosonium. So this is the complex because of which brown ring is formed. Now let us check this question. This is also relating to coordination also, and practical organic chemistry also. A very important fact that you can detect nickel ions. How these nickel ions are detected? Due to the formation of using this complex of DMG. What it forms? It forms nickel DMG whole twice, and this is a neutral complex which can be easily seen because it's a red colored complex forming a square planar structure. So with a reagent which gives brilliant red color with nickel ion is this DMG, which is dimethyl glyoxime. Moving to the next question. On passing gas X through Nessler's reagent, a brown precipitate. Now, this brown precipitate is obtained due to when Nessler's reagent reacts with ammonia. And when it reacts with ammonia, the brown PPT is because of the presence of HGO dot HGO NH2 and this iodine. Now, this double salt creates a color which is a precipitate, and this color of this precipitate is a brown PPT, a very famous reaction. Now these are all some questions which is very important. Now moving forward, heating borax bead dipped in cupric sulfate in a luminous flame, color of bead becomes green. Now flames are of two types, luminous and non-luminous. Now what is a luminous flame? A luminous flame is a flame when you supply no oxygen. So luminous flame is a flame when holes are closed, so it is a reducing flame. And non-luminous is an oxidizing flame. So actually this is correct, but it does show this color in a non-luminous flame, but it is saying in a luminous flame. So statement 1 is wrong. The green color observed is due to formation of copper metaborate. Now the green color is observed due to the formation of, actually copper has a color blue, it is a blue colored. So this is also wrong. So actually both statements are false over here. So statement 1 also is false and statement 2 also is false. So moving ahead, let us try this question. These are all questions of salt analysis. So let us try this question also. Okay, that was A, right? Now let us try and attempt this question. It is saying a white precipitate are formed when BaCl2 was added to water, extraction of an organic salt. Okay. Further, a gas X which with characteristic odor was released when formed white precipitate was dissolved in dilute HCl. Now, point is a white precipitate was formed when BaCl2 is added with water to an inorganic salt. So actually, actual point is barium shows a white PPT. Barium shows a white PPT with sulfite also and with sulfate also. It shows white PPT with both, but not sulfate, only sulfite, as in when you have barium sulfite, when this sulfite salt is treated with HCl, not sulfate, only sulfite when treated with HCl actually does what? It forms, it gets dissolved, you can say. It gets dissolved, not sulfate, because sulfate is still insoluble. So this get dissolved, and because of this fact, this sulfite will be our answer. Now moving to the next question. Now this is also a practical organic chemistry question. Moving forward. Now we should know that NO2 minus, we have recently done this. NO2 minus creates a brown fumes. The point we should know, this SO3 2 minus is a colorless. This SO3 2 minus is a gas which is having smell of burnt matchbox. So because it creates SO2 gas, that's why it creates SO2 gas, and it has a characteristic smell. So colorless gas which turns potassium dichromate solution green. It is also one of the property of this sulfide gas. So this C is 2. Now colorless gas which turns red estate paper black, this is the famous sulfide ion, because sulfide ion produces H2. Sulfide ion produces H2S gas, and that H2S gas turn lead acetate paper black. So B is 1. And this carbonate, which is very famous, it produces CO2, and this CO2 always creates what? It creates brisk effervescence. So A is 4 in that case. So A is 4 in that case. A is 4, B is 1, C, D is 2, D is, just check D is 3. So because D is 3, so answer is beautifully 4. Now going directly to, although I have taken some salt analysis questions, but I wish we should directly move to physical chemistry, because these are questions which will definitely make 1 marks of yours. So starting with solution chapter, this is the first question. Please make an attempt, and let's see if we can find answer to this. Now guys, for the last few, I mean, I'll be taking maximum 35-40 minutes. So I just want out of you is be very religious, take your pen and copy and start attempting these questions. Together we will learn also the theory, and obviously we'll try to find the answer also. Chalo, let's start. Now 1 gram each of compounds AB and AB2 are dissolved in 15 gram of water separately. So I'm taking 1 gram of this also and 1 gram of this also, are dissolved separately in 15 gram of water. They increase the boiling point of water by this and this respectively. Okay, that means delta TB is equal to 2.7. Boiling point is increased when you add 1 gram of AB. So what is 1 gram of AB, sir? It is Kb into molality. What is molality? Sir, molality is number of moles of solute, which is 1 gram, weight of solute. Let's say molar mass of solute is A plus B, because I do not know the atomic masses, so I'm writing A plus B. So weight upon molar mass, because Kb into molality. So weight upon molar mass into volume of weight of solvent. What is weight of solvents? At 15 gram of water. So this is 15 gram of water, and this, because it is gram, so it is 1000. Kb I'm not putting because it is for water only. Now this is equation 1, a relationship between A and B. The other, this is delta P, let's say elevation and boiling point of first. Now, second boiling point elevation is given to be 1.5. Again, doing the same thing. Delta TB is equal to KB into molality. Molality is weight of solute upon molar mass of solute, but now solute is AB2. Weight is again 1 gram. But here molar mass of solute will be A plus 2B. So moles of solute into weight of solvent. What is weight of solvent? So same 15 into 1000. So obviously you can find relationship between A and B, and what are you asked? The atomic mass of A. So if you solve, you get atomic mass of A. Perfect. Atomic mass of A, after solving you get atomic mass of A to be 2.5. So if you try to bring it into this form, it will be 25. Moving forward. Perfect. Santosh. Very good. This is 136 and Santosh, hats off. Moving to the next question. Now, it says statement NaCl is added to ice at 0 degree, present in the ice cream box to prevent melting. Now, why do we add non-volatile solute to a solution? A, to increase its boiling point. B, to depress its freezing point so that the solution can remain in solid state for longer period of time. So NaCl is added to prevent the melting of ice. Yes, so this is true. Now, what about statement 2? On addition of NaCl, there is a depression in freezing point. Both statements are definitely correct. Definitely right. So answer will be yes, Santosh. Yes, Ayush. Ayush is back. Answer is 4. Yes, Santosh. Perfect. Now, let us try this question. This question is again from solution chapter. This question is again from solution chapter. It will be containing a bit of calculation you can do. I'm just giving you the basic idea. Now, I'm consider the reaction of this weak acid. Okay, this weak acid is dissociating as H plus and X minus. K is given. Dissociation constant is given. Osmotic pressure of this much solution of HX. So if you need to tell the osmotic pressure, its formula is ICRT. Sir, why you have taken I over here? Because here its ionization, its dissociation has to be estimated. So what is I? Sir, I is basically Van 't Hoff correction factor, which is for dissociation 1 plus n minus 1 into alpha. What is n? Number of ions that a molecule is dissociating into. So it is forming 2 ions. So this n is 2. So because this n is 2, so this becomes 1 plus 2 minus 1 is 1. So this is 1 plus alpha. So we need to find alpha. So for calculating alpha of a weak acid, sir, it is a weak acid because K is even lesser than 10 to the power minus 3. So actually how we calculate alpha? By under root of Ka upon C. Basic. What is Ka? K is given. What is C? This is the concentration, 0.03. So you do the math, you find alpha, you put that alpha over here, you find value of I. Once you find value of I you put concentration, you already know. R is 0.083 and temperature is 300 Kelvin. So you put all these data, and I guess with some bit of calculations, you will get your answer as 76 into 10 approximately. You have to do that labor approximately. Once you approach it to the closest integer, it will be 76 into 10 to the power minus 2. Moving forward, let us attempt this question. Now I'm moving aside. I want someone to give answer. Because now we can try, because this is not that calculative. So you can try and do this. Kishore, Ayush, Vivek says 76 is of the previous one. This one. It says you have 2.7 kg of water and acetic acid. They are mixed. Both are 2.7 kg. The freezing point of solution will be minus X. So for the solution, you have to say the freezing point. Consider acetic acid does not, okay, good. Acetic acid is not, because acetic acid can go dimerization also, it can go dissociation also. It is saying you do not consider anything. So Van't Hoff correction factor goes nil, it becomes 1. Consider acetic acid does not dimerize nor dissociate, perfect. Molar mass of water given, of acetic acid given, Kf, I mean for water Kf is given. Kf of acetic acid, no, because water is the solvent, acetic acid the solute. So freezing point of water is also given. Now, sir, what to do? Delta Tf. Delta Tf is what? Tf naught minus Tf. What is Tf? Sir, it is of solvents. If solvent is water, so it is 0 degrees. So 0 minus x. That x you have to calculate. Minus x degrees Celsius. So directly we'll find that x. So it is equal to Kf. Kf for water is how much? Kf for water is 1.86 into, so this is 1.86. I'm just telling you what are the values. So it is 1.86. Perfect. Ayush, very good. Yes. So this is Kf into molality. Now calculating molarity separately. So molality is equal to weight of solute upon molar mass of solute into weight of solvent, and this weight of solvent is given in kg only. So this is 2.7. So there's no need of that 1000. Now, what is solute, sir? This is only the solute, which is acetic acid. So what is weight of solute, sir? Solute you are also taking 2.7 kg. So this becomes, because it is 2.7 kg, so this becomes 2700, because point. So this much of gram upon, what is its molar mass? 60. So once you solve this, you will get your answer, the put molality, put value, and while calculation you will get your answer, and exactly what Ayush has said, you will get approximately 31 as your answer. Moving to the next question. Now, again talking about osmotic pressure. Question is saying 0.4 molar K2SO4 solution is isotonic with 0.1 molar glucose solution. Percentage dissociation. Now glucose is a organic compound, so its I will be 1. So osmotic pressure of K2SO4 has to be equated to glucose. And you are asked that this much of K2SO4 and this much of glucose is having same osmotic pressure. In that case, you should tell me what is the percentage dissociation, the alpha for K2SO4 you have to determine. So let's try this one. Now we know for K2SO4 it is equal to I. What is I? It is giving 3 ions. So N is 3. 3 minus 1 is 2. So 1 plus 2 alpha, where alpha will be its percentage dissociation. It will be dissociation. If we multiply it by 100, it will be percentage dissociation. Now I into CRT. What is concentration? Sir, 4 by 1000. R, let's say R is R only, T is T only, because R and T is not defined. So they are same. R is a constant and temperature for both will be same. Now it is equal to glucose. For glucose, I is 1 because it is a organic compound. It does not dissociate, neither association taken. Now concentration is given to be 1 by 100. RT is same. So I guess you found your answer. So you just solve, and alpha you will be getting, but you have to report percentage alpha. So I'll just tell you what will be your answer. Percentage alpha over here will be perfect Santosh. It is 75%. Answer is 75. 100% correct. So I hope the basics are clear to you. Moving to this next question of electrochemistry, moving to solution, we have finished and we have moved forward to electrochemistry. Let us try this electro question. Moving to electrochemistry, let's try this electro question. Take that charge and try this electro question. Consider the half cell. We are given a half cell, which is this reduction. The reaction was conducted with ratio. Okay, ratio of these are given to be this much. The pH value at which EMF of the cell will become 0. Now apply Nernst equation. What is Nernst equation? E cell I mean E of the half reaction, this you have to take as 0. It is equal to E naught. E naught of this half reaction is given 1.33 minus this 0.02.303 into RT. This is staying, you take it as 0.059. We know this value also. Upon number of electron transferred for per ion is 6. The balanced reaction is also given into log of the reaction quotient. Now reduction half of the reaction is written, so let us write the reaction quotient. So chromium concentration raised to the power 2, it's over here. Water, pure liquid, we do not take. Dichromate ion, power 1 already given, and then H plus raised to the power 4. So this value I am directly writing as 10 to the power 6 minus 6, and this H plus ion concentration raised to the power 14. And this pH only you have to say that what will be the pH when this will turn 0. So we will calculate that pH. Good. Okay. If just hold for few minutes, we are already in electrochemistry, electrochemical kinetics, and we are done. So just hold for like more 20 minutes, I guess. Less than 20 minutes. Now, so I guess this is quite clear to you, because you calculate this. How to calculate this, sir? This is 0, so take it in that side. So 1.33 will be equal to, let's take it 0.06 upon 6, so it is 0.01. So it is 10 to the power minus 2, and putting the log property over here, so log of A upon B is log of A minus log of B. That 14 I am bringing over here. So this is 14. Now this is 1.33 is equal to 10 to the power minus 2. This is minus 6. This is plus 14. Why plus 14? Because minus of log of H plus I am writing as pH. Now this is the pH which we are interested with. So now you have this point. Now you have to calculate this pH, and I guess if you solve this, I just give you the answer. It will be some, you have to solve it for a bit. If you solve it, you will get pH which will be approximately written as 10. So at pH of 10 it will be 0. Moving forward to the next question. Now this is a question again from Faraday's law of electrolysis, a very conceptual question indeed. So let us at least do that concept. Into divide you can obviously do. So let us try that question now. Now it is also a very conceptual question. It says electrolysis of 600 ml of aqueous solution of NaCl for 5 minutes changes the pH of solution to 12. Now it's a very good question actually. What I'm trying to make you understand is, when NaCl aqueous solution is getting electrolyzed, obviously Cl minus will go where? At anode, and will undergo oxidation and will form chlorine gas. Definitely correct. So this is 2 and this will give electron. But it is not creating anything as per pH. H plus and OH minus, and it is not creating. Where it will be created? Sir, Na plus will not reduce. In fact, who is having higher reduction potential? Water. So actually water will gain electron, and hydrogen from +1 state will reduce to hydrogen gas. And because H plus of water is gone, so what is left behind, sir? OH minus. Now if you balance this reaction, you will definitely see that, let's say I add 2 over here, so I add 2 over here, I add 2, everything is balanced. Now you just check that if you take 2 electron, 2 OH minus ion will be produced. So if you take 1 electron, 1 OH minus ion will be produced. So who is actually creating that difference in pH? Because of production of this OH minus ion. So we will be calculating this OH minus ion, that how much of this OH minus ion will be created. So it will be created by what? By accepting 1 electron. So writing Faraday's law for this OH minus. How to write it, sir? Sir, we know weight deposited is equal to ZIT. This is the famous formula which I feel everyone should remember. Weight deposited at any electrode is equal to ZIT. Now For weight, sir, we are given volume, we are not given weight. So for volume, what you should do? Volume, you should, with volume, let us calculate its molarity, because molarity into volume will give you number of moles. So sir, how molarity? Weight you have, just open that formula. This is weight. Now what is Z? Z is E by F. What is E? Molar mass upon valency factor into F into I into T. I and T we know. This molar mass when goes over here, what formula you get? Weight upon molar mass will make it number of moles. And this number of moles, when number of moles divided by volume will give you molarity. So, sir, but here I know number of moles and I know volume. So, molarity is calculated as number of moles of solute upon volume of solution in liters. Now, volume of solution you have, and because you have volume, so okay, I am first calculating moles for you. So number of moles is equal to, what is valency factor for it? Sir, for valency factor, this is 1, this is 1. Valency factor is 1. So what I'm trying to tell you is, this is 1, this is 96500. I, what is I, my friends? I is, okay, current we have to find. This current we have to find. Time is 5 minutes as in 60 seconds. Now, for this molarity, we have this 12 which we have not used. So pH of the solution is turning to be 12. So pOH will be 2. So OH minus ion concentration will be 10 raised power minus 2. There we go. Molarity we know, volume we know. So molarity into volume will give you number of moles. So number of moles will be equal to molarity into volume, which is 600 upon 1000. So this will be your number of moles. Put number of moles over here. Rest of the things are there only. If you solve, it is a very, very good question, and you will find value of I. I will help you with the value of I. It will be at somewhere around 1.93. So integer type answer, what you will write is 2 ampere. I'm sorry. It is 2 amperes. Now even I am exhausted. So let us again move forward. I guess, hello, are we there? Vivek, Santosh, chalo. Let's move, because I want to finish this. So let's move to the next question, although we will be taking our time. So let us try. Whoever is there, I will be helping you with whatever content we have, and we'll finish it. Yes, Vivek, 2 ampere. Yes, yes, yes. Now that's the spirit, my friend. Now, based on this data, the strongest reducing agent, sir, reducing agent reduces others. So it oxidizes itself. So who will oxidize itself? Which will have the highest oxidation potential? Let us see. Sir, the data is reduction potential. So who has lowest reduction potential will have highest oxidation potential. So lowest as in, this is having negative data. So obviously this will be weakest. Its reduction potential is weakest, so its oxidation potential will be highest. So if my oxidation potential is highest, reducing agent oxidizes. Reducing agent reduces others and oxidizes itself. So who will oxidize itself? So this guy, chromium, because its reduction is negative, so its oxidation will be positive. So chromium, yes, perfect, Vivek. So we are back with active students. Now let us attempt this question. A very probable question, although the previous question was very good, but this is a very probable question of extensive and intensive property application. Now for this reaction, we have to find E0 cell. E0 cell is what? E0 cell is E0 cathode. Who is cathode? Silver, minus E0 anode. Who is anode over here? Iron, because it is getting oxidized. But what we put? Sir, we put the reduction potential only, because we put reduction potential only. Point number 1. Now, sir, Ag plus reduction is already given out to be X volt. So this X we know, minus. This is not given. So let's take it as A. Rather, what is given? Fe plus 2 to Fe and Fe plus 3 to Fe is given. But sir, what we need to find? We need to find Fe plus 3 taking 1 electron and forming Fe plus 2. So this is equation 1, this is equation 2, and using these equations you have to form this equation. But sir, potential is not additive. Who is additive? Delta G. So let's say for this reaction delta G is delta G1 and for this it is delta G2. So how can you create this using these two equations? Easy. 3. That means delta G2. Okay, I'm sorry. 3 as in delta G2, because Fe plus 3 I need in left hand side and this I need in right hand side. So it will be minus. So how will you get this reaction? Delta G will be equal to delta G2 minus delta G1. I hope it is clear. What is delta G? It is minus 1F, and this E naught we have assumed to be A. That we have to find. It is equal to, what is delta G2? Minus 3F into Z. What is delta G1? Minus minus will become plus. This is 2F Y. So F is gone. So what are we left with? So this A is equal to 3Z minus 2Y. And putting that over here, so our E naught will be X minus. So minus minus plus 2Y minus 3Z. A very beautiful question, and such questions are very important. Now X plus 2Y minus 3Z. Okay, option number 3. Moving to the next question. Now a solution of aluminum chloride. Now this is a very simple question of Faraday electrolysis. Amount of aluminum deposit. Now this is quite easy because we have dealt with its daddy, so this is much easier for you. So W is equal to again ZIT. So what W we have to directly calculate. Z is E by F. E is molar mass upon valency factor. Molar mass of aluminum is 27, valency factor is 3. So E, what is E? M by molar mass upon valency factor into F, which is 96500, into what is I? 2 amperes. What is time? 30 into 60. So this calculation you have to do, and options are there. Anybody got the answer? Chalo, moving forward. Now, yes, a very good question of molar conductance also. Molar conductance at infinite dilution of a solution of chloride was this much. So at infinite dilution of, so lambda naught of ammonium chloride, this is how much it is given as 1.185. Unit I'm not putting, I'm just writing as this is okay. Santosh got an answer. Good beta, good. Now this is 185. 2. Okay, for the previous question. Okay, let me tell you, if you are serious, I mean if you got the answer, obviously you all are serious, but if you got the answer for that, B. For alumina it was answer B. Yes beta, definitely. Santosh, that means we have people who are actually working till it is actually after 2 minutes it will be 1 p.m. or 1 a.m. So good. So let's finish this. So lambda m naught of NH4Cl is given out to be 185. The ionic conductance of hydroxyl and chloride. Okay, ionic conductance of OH minus and ionic conductance of Cl minus. These two are given out to be 170 and 70 respectively. If molar conductance of this much molar of solution of ammonium hydroxide, okay, so it is not infinite, it is molar conductance of 0.02 molar of ammonium hydroxide as in NH4OH, it is given out to be 85.5. I'm checking the unit now, it is Siemens centimeters. I'm checking the unit, not writing it to be quick. So its degree of dissociation. How can you find degree of dissociation? So degree of dissociation is conductivity at concentration C upon conductivity at infinite dilution. So this is given how much? 85.5. At infinite dilution you have to find, but of NH4OH, so we'll apply Kohlraasch law, because for NH4Cl it is given. For NH4Cl it will be of ammonium ion, which we do not know, so lambda m naught for ammonium ion, it is not known till now. But for Cl minus, which is given, so it is 70. So for ammonium ion you can calculate, so for ammonium ion infinite limiting value will be 185 minus 70, as in 115. This we have calculated. And for ammonium hydroxide, again applying Kohlraasch law, for ammonium we recently calculated 115. And for OH minus it is given 170. So it is 115 plus 170, whatever it is. Solve, whatever you get will be your value of alpha. So can someone give me the answer? When you'll solve it, you will find alpha to be 0.3. It is saying report it in 3. So answer will be 3. Your integer will be 3. Moving forward. Now, this is okay. I'm skipping this question because that was also a calculative question. So moving to this very famous logic, a very convenient and common logic. For all strong and weak electrolyte, as concentration increases, molar conductivity decreases. Perfect. See, good. It decreases, but when concentration approaches zero, as in dilution approaches infinite, for weak electrolyte, the molar conductance approaches infinitely large value. So A represents for weak electrolyte and B represents for strong electrolyte. This is a knowledge which you should have. So A is for weak. Perfect. We are getting so many answers. Perfect, Vivek. Now this is just simple because it's a divalent cation and divalent anion, and you are supposed to calculate the molar conductivity of the solution. So just do what? Add these values. 57 plus 73, because for any electrolyte it is equal to 1 plus 2. So answer will be just addition of these two. Moving forward. Now, active chemical kinetics, the very famous, the first and foremost famous equation of chemical kinetics. How a reaction proceeds, it always has to climb the activation energy barrier. So it says rate of a reaction is equal to A into E exponential of minus EA upon RT. This you should know, a very important collision theory also and Arrhenius theory also of chemical kinetics, that rate of a reaction is equal to Arrhenius factor or collision factor into exponential of minus activation energy upon RT. Now, for some reaction, the activation energy is given as 30, and for the adsorption of hydrogen for another catalyst, activation energy is different. So let's say this is EA1, let's say this is EA2. The logarithmic ratio of chemisorption, for the adsorption for the reaction on equal area of metal surface at this temperature. So temperature is same. Now, said temperature is same, and you have to take the ratio, the logarithmic of the ratio, the log of ratio. So log of ratio, how you will take? Sir, K1 is equal to this much. So K2 is equal to, let's say, EA1, because temperature is same, activation energy is different. So A into E raised to the power minus EA2 upon RT. If we divide, let's say, K2 by K1, if we do K2 by K1, A will be gone. So it will be minus EA2 upon RT, and the another one will come to the numerator and becomes EA1 upon RT. So if we take natural log, so it will be ln of K2 upon K1, which we have to find. So it will be nothing but EA1 minus EA2 upon RT, a very famous formula of n number of possibility question can give you. So this is your okay, you will put the value. I'll just help you with the answer. This is a calculative one, but if you will do the relevant calculation, by solving, the integer will be around 2. I mean, you will have to solve, but the integer, it will be around 2. So it will give you an answer. Now, again, that Arrhenius factor it is using. So I'm directly moving to the first and second order reactions because they are also very much asked. Now, in a first order decomposition reaction, time taken for the decomposition of reactant to become 1/4 and 1/8 of its initial concentration are T1 and T2, but it is talking of first order. Now, for first order reaction, we know T half is equal to ln2 by K. That means it is not at all depending upon the initial concentration taken. A very, very, very famous point. So let's say for 1/4, let's say I had 100 of the reactant, half of 100 is 50, so it got 50 in how much time? T half. Okay, so for 1 T half. Now from 50, half of 50 is 25, it will take one more T half. What is half of this? It is 12.5, so it will take one more T half. So you tell me decomposition of reactant to 1/4. Sir, 25 is 1/4. So 25 as in 1/4 is taking how much T half? How much time? 2 T half. And half of this, half of 1/4 is 1/8. So 1/8 is taking one more T half. So first one, it is taking 2 times. T1 is 2 times of T half and T2 is 3 times of T half. So T half is gone because it is not at all depending upon the initial concentration. So the ratio is simply 2/3. A very beautiful question, which if you do by putting the values, it will be quite difficult. I mean, time consuming. So first order reaction, this is a very, very, I mean, very famous point that its T half does not depend upon initial concentration. Now, what about zero order reaction, sir? For zero order reaction, T half is equal to A naught, it depends upon initial concentration, upon 2K, because its relation is concentration at time T is equal to minus KT plus initial concentration. Now use this formula and you will get your answer. Let us do it. Half-life of zero order reaction is 1 hour. So half-life is given to be 1 hour because question is also given in minute. So okay, let us make it in minute. So 1 hour as in 60 minutes. So A naught initial concentration is 2. So let me write this initial concentration as 2. So 2/2 upon K. So K is 1/60. Through this we know K is 1/60. Now what are we asked in the question? Time required to decrease. Okay, time, that is that T. Concentration from, okay, from 0.5 to, so initial it was 0.5. Where you want to reach? 0.25 minus K, I know it is 1/60. And this T I have to calculate. So solve this T, this is minus, into divide you have to do, but you will get your answer. Moving ahead. Now, this is also T half question. Now, let us attempt this one. The concentration of A at 10 minutes is, now, it is asking concentration of A at 10 minutes. And let us check what type of reaction it is. Sir, here T half, as concentration is increasing, T half is also increasing. So T half, I've told you, it is equal to A naught upon 2K. That means what? Sir, Y is equal to mx plus c. It is a zero order reaction. And because it's a zero order reaction, so what is value of slope? 1 upon 2K is nothing but the value which is given out to be 76.92. So K, you know. Now what is asked out of this? Concentration of A at 10 minutes. Again, that logic. Now here time is given 10 minutes and you have to tell the concentration of A. That means concentration of A at time T is equal to minus KT plus A naught. What is the initial concentration? Reaction was started with 2.5. So this was initial concentration. So this is 2.5. K is 1 upon 76.2 into 2 and T is 10 minutes, because this is also appropriate unit, so it will get cancelled, it will get neutralized. So yes, again, into divide you have to do religiously, and once you do, you will get your answer. Now Again, this question, again, this T half thing. Without doing mathematics, you can do this T half thing. How? Drug X becomes ineffective after 50%. When it is decomposing 50%, it becomes ineffective. The original concentration of drug in a bottle was 16 milligram. Originally, it was 16 milligram, which becomes 2 milligram in 12 months. Okay, so 16, because drug is also drug decomposition, these organic reactions, they are also first order kinetics. So 16 becoming 8 in how much time? T half. 8 again becoming half, that is 4 in how much time? T half. It is directly telling you 16 is becoming 4. That means it is taking twice of T half. So 2 times of T half is given out to be 12 months. So that means T half is nothing but 6 months. Now let us read the question. The expiry time for the drug in months. It is saying that when it has decomposed to 50%, it is not effective. So expiry will be T half. So what is T half? See, T half question all the time. These are all just previous year's question. By changing the representation of the question, they ask. So answer is again T half. So this is the WhatsApp channel QR code. Scan it for these notes also, for practice questions also, and join the WhatsApp channel to be updated. So this is me, Gaurav Singh Arora. Although I wanted to do more, but whatever we have done, I guess it's more than sufficient. So keep working hard, guys, and all the very best for your paper. So bye bye.